I've just pressed the button. I pressed the button, and Katie, we are live with HashiTalks Africa. I'm excited. This is like the prelude to the prelude.
Amazing. I just went and refreshed the YouTube and I see your face with your wonderful background.
Yeah, I'm suffering a little bit of lockdown hair at the moment.
Same.
Most people look at me and be like, I really can't see the difference. Nick looks just normal, a mess, I believe.
Nick, I came across a photo of our team from our company All Hands about a year ago, and you had super short hair, and I was willing to bet that maybe that's the last haircut you've had.
I mean, it's very probable. I did have a haircut. Oh, 9 o'clock, Katie. We should probably stop chit-chatting and welcome everyone to the stream. Welcome everyone. I'm really, really excited that you could all be here, and welcome to HashiTalks Africa, the inaugural community event of some amazing talks from the African continent. And like, I can't wait. I'm so excited. And we've got Katie here, and Katie's kind of been running this and setting things up. But most importantly, we have Samuel. And Samuel is going to be giving our first talk, not just the first talk of the day, the first talk ever of HashiTalks Africa. So no pressure there, Samuel. But Samuel is a certified Kubernetes administrator and also an AWS certified solutions architect. He works kind of like, helping companies gain visibility, infrastructure, looking at workflows and things like that. And of course, an avid HashiStack user. I'm like really excited about Samuel's talk. Samuel is like, looks after the hub in Lagos. Like so great to see all of these wonderful community folks. And the talk today is going to be everything as code, the new software development and delivery workflow. And it should be, well, like everything today, pretty amazing. Samuel, how are you, good buddy? Are you well and doing good today?
Sean, Nick, I'm doing excellent. And you? Hi, Kathy. Always excited.
Sam, thank you for joining us.
The pleasure is mine, Kathy.
Well, Samuel, if you want to go ahead and share your screen and kick off your talk, we'll leave you to it.
Yeah, go ahead. We're looking forward to this, dude.
Okay. Welcome, everyone. Good morning from Nigeria. Okay, my name is Samuel Nwoye, and I want to thank you all for joining, for the ones that have joined from Nigeria and the ones still yet to join. I like to call myself a development productivity engineer. You see, these days, DevOps is about a lot of things, and somehow it's become a buzzword. And most times you speak and they were like, oh, no such thing. Those are all pranks or some of those marketing terms. So today my talk will be specifically demoing a fictitious implementation of DevOps for a particular CEO by a consulting company. So I tried as much to see that this sort of a little bit looks or paints some reality to how DevOps really works. Now, I'll have to point that it is different with different companies, and the tools used are also different based on the company. So basically, it's just an eye into the reality of DevOps. That's what this talk essentially is gonna be today. Thank you once again for all joining the session. So let me begin by showing this. Okay. Can you all see my screen, please?
Yes.
We see you there, Samuel.
Okay. So let's go here. This is my slide, and that's the title of my talk. So a brief explanation of the architecture of this particular infrastructure for the CEO's homepage application. I will be using AWS as the platform for demoing this, and a quick look into what will be housed in our infrastructure. So, and how the flow of traffic would happen. So if a user hits our Route 53, which is our domain service for AWS, it takes the user's traffic through the AWS VPC flow log so that I'm able to register, or we are able to register what happens in our network. And then we also made sure to have an AWS config trail so that developers' API access and or whatnot can be tracked so that we know who did what was done and when. And then essentially, because every good DevOps engineer should be looking at having a visibility into the infrastructure of whichever company they are managing. Whichever platform you use, I believe they do have these things. Now, the AWS config is for looking into what is running, where we can optimize things, what is probably redundant, and what we need to remove. Because once you keep doing these things, you are actually you're making an action that sometimes are not automatically removed. Some things like EBS volumes, unless you actually specifically said that the EBS volume should be deleted with the instance when the instance is deleted. So AWS config helps us to look at the things that are in our infrastructures and how they are running, which has which relationships to which, and stuff like that. I will also leverage on the AWS S3 bucket and the DynamoDB. Essentially, those two are for my storage. And because I'm applying or implementing the remote state backend of Terraform, I had to call on AWS S3 and DynamoDB for my lock and then storage of my state file. Now let's look into the system itself. Now, you can see I have two availability zones here, right? They are both public, but for real clients, depending on what they have asked, this is not essentially what I do or what is advisable. It's not a best practice, just for the demo. Now, you have just one instance of the application where the application will be running, and then another instance where we have all our other services like Jenkins, Prometheus, Grafana, all that we know that is part of what will make our work a wholesome DevOps process. Next is a look into how the flow of things happen after we've stood the application. So here is our engineering team talking to the GitHub repository. And then from the GitHub repository, at push, a Jenkins pipeline is triggered. And then the Jenkins pipeline calls a Packer definition. Oh, Packer is actually an awesome tool that makes orchestration of your server instances very easy. Now, naturally, or previous to this whole DevOps movement, operation engineers more like have to go through their own books or even go through dozens of bookmarks for them to configure a particular server. Now, what automation preaches is have this thing documented, have this thing written just like the coders or the developers write their code. And by the way, operators also test just like the developers test. We'll be seeing all that today. So I will be using Packer and Ansible to orchestrate an AMI machine. This AMI machine will be containing both the applications like the software dependencies that we will need for the application to run and the application itself after developers have developed it. Now on core, after this, we'll move that AMI into a Terraform file where it is now spawned up as an instance itself. Now, this instance has a relationship to Prometheus. By the way, I need to explain a little bit of stuff here. What this flow means is that this Terraform can kickstart another Jenkins file to deploy to staging, and if it is okay, or when a user certifies that we are fine with what we have seen after the QA guys, the user testers, user and experience testers have looked through the application, we move to production. Now, the Prometheus and Grafana symbol here is like monitoring the entire infrastructure, monitoring everything we have deployed, from our EC2 instances to whatever you have in that infrastructure, as long as you pointed it to be monitored by Prometheus. Okay, thank you all. So, just like I said, what is DevOps? It's a software development and delivery methodology that combines cultural and operational paradigm in achieving business goals. So essentially, it's developers and operators working together without any of the parties blaming one another for errors. Like, we have trust that, hey, this guy is working. For me, as well as I'm working for him. We are seeing that this particular business goal is actualized without either of us pointing fingers at one another. So normally what happens when you begin a project is that the client comes to you, define whatever it is they want, agreements are signed and mobilization is done, kickoff process begins. Now, the real thing happens in the engineering team. The engineering team sits down, defines this particular requirement that have been gathered as task, break them down to be reasonable, translate those requirements technically. Okay, this is how we think this should be, this is what this particular thing would look like. And then put them out as cards and weigh what that particular task would take in time. So if we have a task A saying develop a login page, right? A login button that the users can enter their password and then username to take them to the index page, or rather to take them to the dashboard page, whichever way the flow is. This particular task is estimated how long it will take for the developer to develop it. Then what we call poker estimation is done to bring to reality the average amount of time this should take. So now, after the team has actually done their thing, usually the first guys that get to work is the ops team, based on what they have understood from the discussion they had in the engineering team. Now, what the ops team does is create the repositories and the team members for each repository. We are trying to save costs here. We don't want to run our development machine on the cloud. And again, we want our development machines to be in parity with the production machine. We define a background file, then describe configurations for that particular machine we'll be using Ansible. You could use Chef, Puppet, whichever one, but for this demo, I will be using Ansible. Then test and provision the machine. So what essentially this means is that right from the word go, we are testing and we are deploying. We are testing and we are deploying. Even as basic as provisioning the development machine for the developers, the operator or the operations team have to also test that the machine is configured appropriately using server spec. Then you will now push this to the version control system, which GitHub in this case will be what I'll do. So here is just a sample code of the Terraform file the operation engineer runs. Provision, GitHub, the name, blah, blah, blah. And here's a sample code of what our Vagrant file will look like. Okay, before this, let's just do a bit of demo. Here we go. So I have my Vagrant file here. The Vagrant file describes the VM I'll be running. Then here in the configuration page, I have the rules, what I will be installing, the Go app, the Golang binary, ng's, node exporter, because DevOps preaches CAMS. There's these 4 pillars of DevOps: culture, automation, measurement, and sharing. We have to be monitoring, have to be measuring everything in our system. Okay. So, but before then, let's since we've had our engineering meeting, let's do a quick one of provisioning our repositories. Let's just do a show of that here. So if you take a look here, I've already done that, right? And I didn't do this by hand. I'm just showing it because I don't want to kill the time. You can see the team. We have the cloud team, we have the dev team, we have the ops team. Unfortunately, because this is a demo, I didn't get anybody to collaborate with me. But what this simply means is that if anybody is part of this organization, we can simply get them on board without going through this interface. All I need to do is, as maybe the ops lead, just get on this here. Let's show it. Just get on this here and provision or add the user, whoever the user is. Just add the user. So you can see developer users, operator users, just like that. That was defined in our Terraform code. Now there's another essential thing I needed to show, and that is votes. So interestingly, because we will be dealing with a lot of secrets, right? At the beginning of every project, usually this is done online. A vote is deployed. You can check out some of my Ansible rules for automatically deploying vote with a KMS key, because up there you rather do auto unseal than go through the process of manually unsealing your vote instance. So what vote does is to keep our secrets. Whatever we did not find something that we need to put in config files and things like that, whatever we think is personal to people, they can just keep it there. Now, if someone is part of the company, they can just authenticate. Being part of the company, we get them, we configure them to be part of this, to be able to have access to vote. And the administrator of vote is actually, or the security guys are actually the guys that take care of this. And then the person can easily get their secrets or any credentials that they need for their day-to-day operations. Okay, so that is that. And assuming we've provisioned our GitHub, next thing is for us to deploy the Vagrant file. I'm not sure I want to run this. Please forgive me, guys, because it sort of slows the system. So let me just do a basic show of what would happen. I'm using my localdo. So I just want to show us a bare. just the best of this. So this is just a simple Go app application. I just run this. So I'm assuming this is the developer doing his thing, right? And once he's done, you can check out what he just did. There you go. Okay, there you go. Yeah. Oh, it's taking quite a time. Okay, it started. So basically, this is the beginning of the stuff. Now, if the developer commits that code, a Jenkins process is spawned up. So let's assume this. Oh, really? Okay, cool, cool, cool. Since I modified stuff, okay. Now this kickstarts the stuff. Now what this does essentially is take us through the flow, you know, the run, the build stage, and push back our binary into our repository. The Jenkins process is supposed to have been started. Okay. All right. For some reason, I don't know why. So let's just build this by hand so that we'll see. Oh, something is not right in our Jenkins file. So let's take a look. Something is not right. Okay. So basically, good. Okay, now it's all right. I'll have to skip this. I don't know what's wrong with it. The gods of demo are probably unhappy with me. So, oh, sorry. I was doing something else. So this is what I was actually looking to run because this is for the code. This is for the code. Yeah. This is for the code. that is for the AMI. So when, okay, it's still filling, whatever. But basically, once the developer pushes their code, a Jenkins pipeline is kickstarted, tests the project, builds the project, and submits the binary back to the repository. Here is just to look into the flow. Yeah, that's just it. That's just it. Then calls our build AMI job, so that if that was successful and when it's master, we don't want to be building development. Let it just build, drop, but don't build an AMI just for development. Now, if probably some set of reviewers and seniors have certified that, okay, on pull request, that particular pull request did not break anything and is committed to master, the next, another pipeline is started and this particular stage runs, calling this AMI build job, so that it will now create our template for us. Now, like I said, we have to be monitoring everything. Here is a Prometheus. This was also automatically installed. Here is a Prometheus system that monitors all we do, what happens in our infrastructure. So at the moment, I have just 2 instances. If I had spun up the other instance, we would have seen it here, but this is just a look. Now, because we are also measuring things, I have a Slack channel where my Prometheus sends alerts on situations of things where we can see where my Jenkins build, whether it failed or succeed, are reported. These are all that happened previously. With this, I have an eye into what is happening. You could also define an email approach where this is sent to an email address or the person in charge or the person in question that this particular build pipeline. So I think I will have to stop here for not feeding into others' time. Yeah, I think that's it. Let's stop here. So I want to take the questions now, please.
Yeah, that was really cool, Samuel. Everybody suffers the fate of those demo demons every now and again. It's the unavoidable, but very, very brave of you for doing the live demo, and everybody, I'm positive, appreciates it. If anybody does have any questions, we've got a couple of minutes. I'm going to kind of ask a question while we're waiting for some stuff to come in from the stream. But how long have you been working and operating in this manner, Samuel? And kind of what is it that's so appealing for you?
This is about 2 years. Of all the stack I demoed or showcased here, the only one that I've not been accepted by the people I've worked for is Volt. And I understand, I quite understand why. There is this fear about, wow, why would we have to manage our secrets in just one server? What if this happens, if that happens? But I'm hoping that probably the next client I'll work with will want to take on this, because Volt is awesome. In fact, just to show us the awesomeness of Volt, this is actually our secret engine. Everybody, the employee's secret and the access they have to which or whatever is defined. So maybe the CTO, the CEO can just take a look and see, oh, okay, this is the access this group of people have. This is the access this group of people have. And when somebody leaves the company, it's just a question of removing them from here. And every other places like our AWS infrastructures and whatever, they automatically cease to have access to it too. Quite awesome. Now let me also show this, because there are a lot of things you could do. Why this is cool, right? You could choose to use user pass, which has already been configured. I think I did that somewhere. Yeah. You could choose to use a number of authentication methods, and you could use auth. So if somebody wants, probably, yes, they are part of our organization now, they could sign in to vote with their GitHub account. Very easy. So
That's
this
really
is
cool.
just the only guy that a lot of people have been having issues to accept. But Terraform, Packer, Vagrant, awesome. I think it's something they are comfortable with. Vote, because it's a secret management. There's this.
That's awesome. I'm kind of a slightly biased fan. Slightly biased, but I am a fan. I was a fan always. That was a wonderful presentation, Samuel. I genuinely want to send my heartfelt thanks to you. That was absolutely fantastic. And
Thank you.
the inaugural HashiTalks speaker. But
Thank
we are
you.
not done.
Thank you, Nick.
Pleasure. We are not done. No, 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 we are not. Because we have another amazing talk to you. And we have Rian Nolan. And Rian's going to be talking about HashiCube, a development lab which uses all of the HashiCorp products. And I'm pretty excited about this. I dig developer workflow type stuff. A little background on Rian. Rian was born in South Africa and has worked for a number of different companies across the globe, Portugal, Germany, and the States, and is now working for Servian in Australia, where you're an automation engineer, Rian. I'm correct there in saying, I hope.
Hi, Nick. Yes, that's correct. I'm working for Servian in Sydney at the moment.
Awesome. And that's a rather beautiful background there. You've got one nice looking office window behind you.
Thank you very much. I used to work in Woodstock, so I used to look on the mountain every day when I looked out the window. It's just absolutely amazing. If you've never been there, you should certainly go and check it out, Cape Town.
That's awesome. Well, I have a story about Cape Town, which we don't have time for, but maybe another time. I'm going to leave it all over to you and take it away, and everybody enjoy this fabulous talk. I'm looking forward to it. All yours, Rian.
Thank you, Nick. Thank you very much. Before I begin, I just want to tell Samuel that was just had his talk before me. It was absolutely a wonderful talk. I love the way that you use Vagrant files to get developers up and running very quickly. I love how you integrated Slack with these deployments. Fantastic. So yes, my name is Rian Nolan. I currently live in Sydney, but I was born in South Africa. Just a quick answer to my buddies in lockdown. I feel your pain, man. But while we're in lockdown, we might as well just play around to some new tech and get to know some new things. So at the moment, I live in Sydney, Australia. I work for a consultancy firm, Servian. They've got offices in over across Sydney. And let me just share my screen on that. Nick, can you see my screen?
I can indeed.
Okay,
it's looking good.
There we go. Thank you very much. Let me just find my presentation, which I can't find.
It's always. They're pesky things. They keep hiding on you when you least expect it.
Man, it's it's Apple. Apple, that's the thing, you know. Anyway, so just give me 1 second while I just quickly look for it.
No, you're all good. I can tell everybody my favorite joke.
Yes, please go ahead.
Well, I mean, I'm saying I will tell you my favorite joke. I'd like to tell you a joke about UDP, but you might not get it.
Excellent. There we go. So here's my slide. Sorry for that. All right. So HashiCube, a development lab using all the HashiCorp products. So where this lab came about is when I got to Australia, I got to know HashiCorp products. And I needed a way to play with something on the train or at home, spin it up, tear it down, see how these things interact with one another. And then I started using a Vagrant. First, I used Docker. It didn't work so well for me on a Mac. Later versions work perfectly well, but it started off with a Vagrant. I use it as a wrapper so that you don't have Docker volumes consuming all of your disk space. And when you're all done, you can just go Vagrant alt. Tomorrow, when you're ready again, you can just go Vagrant up. So Servian, a lot of offices in Australia. We're branching out to New Zealand. I work with some amazing colleagues who are always there to help me learn and to try new things and to try out new features of HashiCorp. So the HashiCorp was, the HashiCube was started for a development lab that I can use and test with. And I'd like to share it with you today so that this can also help you benefit and use all the products of HashiCorp. I use it currently to study for my Vault exam. And I hope it will benefit you as well. So first off, this lab runs all the products of HashiCorp. It runs Vagrant, which Samuel explained to us earlier, that he used for developer environments. Packer, which builds AMIs, machine images for use in AWS or Google Cloud or Azure. Terraform, which we can spin up some infrastructure with to use these AMIs. Sentinel is a policy framework that tests things like, has your resources got tags associated to them? Have they got any ports open to the public which should not be allowed, maybe SSH? Nomad is an orchestration framework similar to Kubernetes that runs workloads. Vault keeps your secrets. And then Consul is a service mesh DNS product. So starting off with Vagrant, we use a Vagrant file. It uses 4 gig of RAM, 10 gig of disk space. And when you go Vagrant up -- provision in the directory in which you've cloned the HashiCube repo, the following things will happen. It will look like this, the command with the output, just to give you a couple of road signs on the way as you go, and what we are going to be doing. So Vagrant will bootstrap the virtual machine. It will install some stuff like JQ, curl, wget, the Docker daemon. So it will install the Docker daemon. It will install the Terraform binary for us. It will download the latest Vault, install that for us, Consul, Nomad, Packer, and Sentinel. It will also download a local stack Docker daemon, and local stack you can use to test things like creating AWS infrastructure locally without the need for an AWS account. It will also bring up a Node.js app for us, Doxify, which I use to do my documentation in. It turns your markdown, your GitHub READMEs into a beautiful looking website. And then it will output some welcome messages when it's done. So I have already done this. Let me just kill this guy and fire up this guy. So after you've done Vagrant up -- provision, you will see something like this output. And the first thing you can do is open up this little Doxify link. There we go. So now you have your documentation locally. You can read up what you need to install, how you need to do it. You can configure Consul locally, and then you can click through to the different kind of things we are going to do tonight. Just a little bit about the Vagrant file. I had at a stage Atom here, which I might have minimized. There we go. So a little bit about the Vagrant file. We just specify our fully qualified domain name, service.consul, which means that we can get to vault.service.consul on the local host and within the Vagrant. We're going to set a little bit of VBox configs, how much RAM we want, the CPUs we need. In here, we are going to specify machine details, the SSH port, the IP address, the disk space, and the directories we are going to mount. Below is a hash. So if you want to set up a cluster, of machines, you can unhash this code and spin them up, and then you can play with clustering these virtual machines. Later on, I will show you how we do this on AWS and GCP. There's just some separator for Windows. Whether it's Windows, we use a separator, and then we can install these plugins automatically. So the plugins I install is just Vagrant disk size. You can install the VB Guest, which will install your guest utilities for you. We do some SSH forwarding, and here we expose our ports. So 8200 for Vault, which means localhost port 8200 will be Vault, and also inside of the Vagrant, it will also be Vault. We export some ports for Favio and Favio dashboard for MySQL. And then at the bottom, these port ranges are for local stack. Right. So going right on, here we mount our Vagrant folder and we start our bootstrap process. We output some variables, that's handy for us, and we install the tools that we need: swapspace, JQ, curl, unzip, etc. Then we say end of the bootstrap. Now we install the Docker daemon. All of these provisioners will be run if you do Vagrant space up space minus minus provision. It will install Terraform for us. Terraform Enterprise is set to run never because it conflicts with Vault that we're running here. It has its own Vault, so these ports conflicts. But if you want to, you are more than welcome to give it a try on your own. It will install Consul for us and bring it up. Same with Nomad, with some Nomad jobs. And it will bring up Sentinel for us, validate a couple of policies for us. It will install local stack. And then this LDAP provisioner is for use with Vault, which I'll show you now, which means we can log in using an LDAP username and password. And then MySQL will bring up a MySQL Docker container. It will specify the MySQL root password and enable the database engine in Vault. And then Vault will create a user for us in MySQL. In this Docker container, there is Jenkins here that you can play with, and then finally Doxify and the helpful messages. All right. So back to the presentation. Now that we have brought up Vagrant, Vault should be accessible for us. So let's see if it is. We should be able to click on this guy over here, boom, and it should open Vault for us. Excellent. We can copy our initial root token right over here, and we can sign in. Excellent. So Vault is alive and well. As you can see, it's only got cubbyhole and the KV secrets engines. So let's add some more. Let's bring up MySQL Docker container. So we will go Vagrant up minus provision minus with MySQL. Boom. This will pull down a Docker container for us, run it on the local host, set the password. Maybe while this is busy, I can just actually show you what it will do. So this provisioner will be in database MySQL, and this is exactly what it's going to do. It's going to stop MySQL. If it's running already, it will kill it. It will delete the dangling volumes for us. Then it will run this Docker MySQL latest on port 3306 with the password and an initial database. After that, it will connect to this local Docker container with MySQL, and it will go show databases. Then it will create a user for Vault at anywhere, identified by password. It will grant all privileges to this user Vault, and then it will grant user on all of the databases for Vault so that Vault can create users for us. Let me see if I can move this guy. Yeah, I can move it. Excellent. Then we will write the database config for, first we will enable the database secrets engine. We will configure this database engine, give it the connection details over here. And then next we will create the create user statement for MySQL. And we will ask Vault to create us some access. Next, we will select the user and host from MySQL, and we will see if this user exists in MySQL. So let's see. Good, we're just in time. The Docker container should have been downloaded, and it should be starting right up now. Just another couple of seconds. I realize seconds is relative. Voila, just in the nick of time. All right. So it has done exactly this. It has started the database container. It has done MySQL E show databases. Then it has enabled the Vault database secret engine. It's written the role config, and it's created this user for Vault. And now we're using this Vault user. We're going to ask Vault to create us MySQL access, which it has done over here, the username and password. And if we list the username, the users, we can see it here. So that means if I have MySQL installed, you should be able to use this guy, -p, that guy, -h. Let's see if this will work. Command not found. Nevertheless, we have a Vagrant box with the MySQL client installed. So let's just use that. Boom. There we go. Show databases. It's working. Now, if we wait about 5 minutes, Vault will again remove this user. As you can see, the least duration is just 5 minutes. So Vault will remove it. If we look at Vault and we just refresh this guy and we grab our initial token, which is this guy, we log in over here, boom, then our database engine has been enabled. So now I just want to log in or log out, and I want to bring up an LDAP container. We will connect Vault to this LDAP so it can look up the user credentials, and we're going to try and log in with the details specified in this LDAP container. If you want to look at the code while this is busy, you can always just hit the repository, go to LDAP, and this is exactly what it's going to do. We just give it a second. Last time I did this chat, I was fortunate enough to be at work in the Servian offices with blazing fast internet. Now I'm at my home with my son watching Netflix. He's 5 years old, so it can get really noisy during demo time. Anyway, so here we go. So let's see if we can log in with username Hermes, password Hermes. LDAP. Hermes. I didn't think of these names. I just got a container from the internet. Hermes. Boom. And we're in. Easy as that. So this demo doesn't last forever. That's it for Vault. Moving right along. Let's just hit view present again. All right. So basically, this is what we did. This is what it will look like. A little bit of road signs going down the road. This is exactly what we have done. Just a note that in the Vagrant, we set the Vault address and the Vault token in environment variables. So you can use Vault inside of the virtual machine without authenticating because these Vault tokens are set. Next up is Consul. So Consul should already be running. Let's see if it is. And actually, before we do that, in /etc resolver Consul, I have set the name server to the virtual machine IP address with the port. So which means we should be able to do dig console.service.console at localhost dashboard 8600. I want the A record. Okay, excellent. So our DNS is working. It's using console. With that, we should then be able to go to console. Let's see if we can. So we're going to go console.service.console. We're going to go 8500. Bam. And we're in. Fantastic. So we see here a couple of things. We see the count-demo, the count API. We see Fabio. We see Nomad. We see Vault. The reason we see that is because in HashiCorp, in console, we set the server config file over here. And we also set some services for console. So we set Vault. We give it this URL prefix. We tell it it's vault.service.console, the Vagrant IP, the port. Similarly with Doxify. And then because we use console for DNS, we've configured it on our laptop locally, we can access it. We also set some routes which propagate over to Fabio. Fabio is a load balancer, which we spin up using Nomad, and a little bit more about that. So let's see what we've did. We need to go present. Boom. All right. So right on to Nomad. Nomad runs a Fabio load balancer and the count-demo. So this is what it's going to look like. When you go Vagrant up minus provision minus with Nomad, you're going to see this screen with a couple of jobs running. Nomad, the details are specified in the HashiCorp folder nomad.sh. It gets a CNI plugin for use with the console service mesh, and Nomad should be available on port 4646. And we could actually, let's see if we can use Fabio load balancer via port 9999 to get us to console. So if everything worked fine, we should be able to go nomad.service.console port 9999. Fingers crossed. There we go. So now the traffic is going with DNS from console. It gets routed to the Fabio port, which is port 9999, and it then loads Nomad for us. So if we want to look at the Fabio port, this is over here. And these routes that are specified here are coming from console. So we can add a route and Fabio will automatically just get this from console very, very fast. And this is how we get to these endpoints. Let's quickly go present. Sorry, I'm rushing, but I really want to get to the good stuff as well. Therefore, I'm just rushing a little bit. So Terraform and local stack. So what is this? This container is a gig big. So what I'm going to do is I'm just going to scroll back because I don't think anyone has got time to wait for us to download a gig. So when we go Vagrant up minus provision minus with Terraform, it's going to download Terraform for us, the binary. It is also going to download the local stack Vagrant and, sorry, not Vagrant, Docker container. And it's going to use this local stack to create us some resources. So here we go. I can see my output over here. All right. So it is in here. It is downloading local stack for us. Over here, we install AWS CLI and AWS CLI local, which works with local stack. We do Terraform init, which downloads our plugins for us, the provider AWS and the null resource, which I'm using to output some data and see if my Terraform code works. Then it's going to run FMT to format the code, and it's going to validate it and lastly, it's going to run a plan. The plan will take us through these null resources, which we are using for data details. I will show you a little bit about that now. And it's going to show us what is to be created. So at the moment, all we are going to do is we're going to create one S3 bucket. And the S3 bucket, which is local stack-s3-bucket, will look like this. You can copy and paste this code into your Terraform, and it will create you the same bucket. Let me just see. All right, these are my output from Terraform over here. And you can see it's quite a bit of data, but I'll show you where that comes in and it will help you as well. And then lastly, it will create our bucket and we will use AWS S3 local, AWS local S3LS, and it will show us the bucket that has been created. So back to the code. If we go here to local stack, you will see there is a main.cf. It uses the provider AWS with a mock AWS key and a secret access key, and all of these endpoints at the bottom. These ports are what we exposed on the Vagrant earlier on. Excuse me, all this talking making me thirsty. These are the ports for these endpoints. So S3 connects to this one. This is the local S3 bucket that we created. And then in my locals, I get to mangle and, if you could say, mangle some data that we want to do stuff with. So where this data comes from, my colleague, Patrick Conheady, helped me with this code. He works with me at Servian. It's brilliant. So here is a variable, EC2 instance. It's a type list, and here is our object. Here we give a default value for this variable. And as you can see, it is indeed a type list. So there are EC2 machines with the AMI ID, and we've got EBS disks on each of these machines, and there are 3 of them. Now, using the locals, we can convert and mangle some of these data so that we can later on use this in a for each loop using our null resource to output some of these data before we run apply. We just want to see before we run apply whether this is in fact the values that we are looking for, that we want Terraform to do. Right, that's it for Terraform and local stack. Demo time. Did I move back? No, this is Terraform. Okay, excellent. So next up is Packer. The previous attendee or speaker, Samuel, showed us how Packer works. And also Packer is indeed very, very useful. Let me show you Packer using a Docker container using Ansible to connect to Vault to get some secrets. With that, let's go to demo time. So we are going to go Vagrant up minus provision minus with Packer. All right. So basically, while it's pulling down container, all right. The demo gods aren't with me today, but nevertheless, let's just see whether this works. Okay, so it's getting a Docker container for us, downloading the Ubuntu Docker container. I wonder if this will work. Anyway, let's just go for gold, fingers crossed. What this will basically do is in the HashiCorp, in Packer, which is over here, it will download the Packer for us, and it will run where? Just give me 1 second. It will set our policy for us in Vault for Ansible to connect. Ansible will get the role ID, get the secret ID, and generate the token. Lastly, it should be doing Packer build inside the Vagrant, this Ubuntu 16.04. So let's just see how that went. Oh, moment of truth. Let's see. And it did work. That's great. So, so what this did is, firstly, it brought up a Docker container, and it's using Ansible to run a playbook for us. If I quickly show you what this playbook looks like in Ubuntu, there is a playbook looking like this. It will add to root foo in the Docker container, hello world. And it will also do a lookup using the HashiVault plugin. Can I move this guy? There we go. Looking into the secrets engine KV Ansible using this token on this URL, and it will get me the value of Ansible. So let's see if we can quickly just verify that I didn't lie to you. Localhost :9000 localhost. Whoops. That's Elasticsearch. We want Vault. All right. So we can just quickly go up here. Just going to seem the long way, but trust me, it's longer. There we go. All right. So let's see in the KV secrets engine, what is the value of Ansible? And it should be all the things. There we go. So we've used Packer to spin up an Ubuntu Docker container, which used Ansible, running a small playbook, connecting to Vault, fetching a value for us, and printing it out onto the console. Let's move right along. I'm scared I'm going to run out of time. Okay, that's what we did with Packer. You're welcome to read it. These are the commands that we did. Packer build Vagrant, this Ubuntu JSON, and that's the output we got. Sentinel is a policy as code framework. So, which means once you use Terraform to bring up some resources, we don't want some ports to be available to others on the internet. So let's quickly see how this works. Once again, I just need to move this guy a little bit more down, or let's move this guy a little bit more up. Right, with Sentinel, boom. Okay, let's see how this looks like. All right, there we go. It's beautiful the way Sentinel outputs this. So there are some policies. So it's AWS block allow all CIDR, one post for, if it looks like this, the ingress passed and the egress failed. Let me see, ingress passed and egress failed. And then it will also check for us whether we have a redirect rule from port 80 to 443 on our ALBs. Now, looking at the code, because the output looks beautiful, but the code is much prettier. So if you want to see what Sentinel has done, you can open up this sentinel.sh. This is exactly the commands that it's going to use. It's going to run Sentinel, apply, config, test, the AWS CIDR, Sentinel. In the Sentinel directory, I've written some Terraform code to help you write these policies. So here I've written a provider for AWS. I've added a security group, which has this egress CIDR, which is blocked, and it's got this ingress CIDR, which is allowed. Then it's also got an AWS ALB for us test, and with, let me just see if I can move this, with a redirect from port 80 to port 443. Now I use this code when I go Terraform apply, I take the state file, and then you will see here that I have made some tests for you. So let's just look at this allow CIDR. So here I've got the Terraform plan. This is the Terraform plan that I've copied and pasted from my Terraform, and I've just cleaned up some of the details. Using this, if you see version resources instances, you can create an empty mock plan. you can create the file mark plan resources applied with the ingress and the egress, and we can write a pass with both of these not blocked. All right, so that is it for Sentinel. There is one more thing I wanted to show you. So if we go into console service mesh, then we see there is a .sh file which runs in the Vagrant, but we want to go to Terraform ls-la. While I show you the code, I want to do Terraform apply -- auto-approve. If that spelling is correctly. Terraform apply auto approve. All right, so there we go. Starting off. So if you go here to this console service mesh directory, sorry, I'm speaking super fast, but I really do want to show you this and finish up for the next speaker. In here, you're going to get a main. And all that this main really does is uses the data function to get my IP address, which is mine at my house. It will run curl on this URL, and it will put it onto the output in data external my IP address. This we will use now in AWS while I'm to whitelist my IP for these resources. While I'm on this, in AWS, you need to make sure that you've got SSH key pairs generated on your local machine. So you must have a public and a private key pair. The public will be copied onto these instances. Your AWS credentials need to be in .aws credentials. And then for GCP, it needs to be in .gcp credentials.json. All right. This will then look up an Ubuntu AMI for us. It will set some instance profile, role AMI roles for us with policy. Then it will use this data template, and the file that it's going to use for the startup user data script is the startup script. We're going to pass these two variables into the user data for GCP and AWS. And the one is the AWS EIP, and the other is the Google Compute instance. The startup script looks like this. This is where we catch the variables that we passed in. We can also create some variables of our own on these AWS instance. And we can access these variables with just $hostname instead of $curly bracket, the variable name curly bracket, because that comes from Terraform that we are passing in to the startup script. Basically, the startup script will install Consul for you, configure it to join the other machine in a cluster, set some services for you that we can use for DNS. It'll install Nomad and Vault. So looking at this, we can copy that address over here and we'll be logged in without fail. We can go tail-f/var log user data. Oof. All right. Anyway, that is the user data that's busy writing to this log that's installing Vault and Consul for us. Boom. We just want to scroll up. If we click on this, we should have a Consul running. Excellent. You can see these services are coming up. Earlier today, when I tested it, I ran out of credits on my GCP account. Nevertheless, our Consul is working in GCP as well. So if we look here, if we refresh it, you can see you've got a DC1 and a DC2. The DC2 is GCP, which the services are busy coming up, as you can see. DC1 has got more services because it's got Nomad already running and Vault already running. Here is Nomad launching. When we go here, whoops, let's just go here. When we go here, we'll be able to log into Vault. And when we go to Nomad over here, we can access Nomad. And with that, I think I just have about one more slide to go. This is what we did with Consul, with Sentinel Policy as Code Framework. Firstly, I just want to thank everyone for joining us for HashiTalks Africa. I want to thank my previous presenter, Samuel, for his excellent presentation. I also want to wish my friend in Cape Town, Kobus Bernard, luck. He's at 1 o'clock today with his presentation on AWS or on multi-cloud and how we approach that. And lastly, I want to thank Servian for being such a wonderful company to work for, and HashiCube, HashiCorp for giving us all these awesome products. Thank you very much. I hope you enjoyed it. If you have any questions, I'm all yours.
Brian, that was incredible. Super interesting, and a lot for folks to go through. So I've posted the links up in the YouTube chat there, so folks can go away and play. And maybe if there are questions, we're running a little over, but maybe if you wouldn't mind, jump on the YouTube live stream there. And if any folks have any questions, we can kind of do things asynchronously, because...
My apologies, Nick. Thank you very much. I'll jump right on.
Because what's next? Well, we have Olubusio and Odun, and they're going to be talking about the impact of tech scholarship on your career and personal development. And welcome. You're both live on HashiTalks, and we're really looking forward to your talk today. So just as a little bit of background, now I do apologize if I'm pronouncing things terribly, because I'm awful, but I'm trying. But Olubusiu, you were a HashiCorp scholarship, I believe, in 2019 for HashiConf in Seattle. Is that correct?
Yes, I was. Hey, Nick.
Hey.
Yeah.
Oh, that's all. That is awesome, and I hope you enjoyed that there. I think I had a great conference there.
Yes. It was awesome. Our session was like so funny. I remember very well.
Unfortunately, or kind of fortunately and unfortunately, but Odonayo was supposed to be coming over to HashiConf, in Europe this summer in Amsterdam, but because of COVID-19, we've gone digital with that. I do look forward to seeing you next year, though, when we're back on the physical conference again. But it's a real shame that we don't get to meet up this year. But next year, it's not too long. Everything in life is a lot quicker than we think. Welcome to HashiTalks.
Yeah. Thank you so much. Thank you for having us.
So I'm going to let you take it away. You feel free to start sharing your screen whenever you're ready. We're really looking forward to your talk. I'm kind of think it's super interesting to hear firsthand from the beneficiaries of tech scholarships, why they're so important, and your talk, Impact and Tech Scholarships, Career and Personal Development. So please, ladies, take it away.
Thank you, Nick. Sharing my screen now. Can you see my screen, Nick?
I can barely see it there. It's just loading up there now. Yes, we can see it.
Okay.
Got your slides.
All right. Okay. Hi, everyone. It's nice to be here on HashiTalks today. Thank you, Nick. And I want to say thank you to the previous speakers, Samuel and Ryan. It was really an enlightening talk out there. My name is Olubusayo, and I'm a software engineer. My major stack is C# backend development. And as Nick said, I was a recipient of the HashiConf scholarship last year to attend HashiConf at Seattle in US last year. And it was a really awesome time. And I'm also here with my friend, Odunayo. I will let her introduce herself.
Hello, my name is Odunayo. I'm a software developer and I specialize in creating applications with React and Node.js. I'm also a recipient of the HashiCorp Diversity Scholarship for 2020.
All right, we're really like excited to be on HashiTalks today, and we'll be talking about impact of tech scholarship on your career and personal development. We are actually from Lagos, Nigeria, and presently like there's a lockdown. So I mean, I I don't know how the lockdown has been for others. Maybe they can talk about it on the YouTube chat. But I just want this period to be over and life to go back to normal, because it's staying home and all of that, like it's getting boring. I mean, so I just hope that things like get back to normal. Odun, what do you think about the lockdown?
For me, I'm actually enjoying the remote life, like away from the hustle and bustle of Lagos. That's just it, except from the freedom. Other than that, I'm enjoying the lockdown.
Okay, all right, let's go straight to our talk. So today we'll be discussing the overview of tech scholarships, the impact on personal development, the impact on career development, and resources you can use or where you can go to. I'll also be sharing our personal experiences in scholarships that we've gotten in the past. So tech scholarships, we have different categories of tech scholarships. We have bootcamp scholarships, and bootcamp scholarship can be on different topics or courses or any area in tech. And boot camps could be on-site or virtual. On-site, like this picture where there's a physical teacher or a physical tutor and a student who's trying to learn. And we also have virtual boot camps where, I mean, tutors and students can communicate via messaging apps like Slack, Telegram, Discord, and all of that. And we also have course scholarships. This is a bit popular. If you go to places like Udacity, where you see nano degrees, there are some courses there that you can get scholarships where you can apply and get selected. And then Pluralsight as well offers scholarships on some courses, and Coursera as well. So you take the course, it could be videos, it could be transcripts, and you take quizzes in between, you take exams, and then you finally graduate or you finish the program with a certificate, and you'd have gained a lot of knowledge. And we also have conference scholarships. So if you're interested in attending a conference, it could be local, it could be international. There are places where there are opportunities for you to attend conference. Like I attended the HashiConf last year, and it was really an exciting time. Conference scholarship makes you to see experts in your field, and you even be able to communicate with the people who actually build the solution you use. You actually like communicate with them, you to see or address them, you rub minds with them. So Audrey is going to continue with the talk now.
Okay, thank you, Bisayo. Talking about the impact of tech scholarship on personal development. So one is that it expands your knowledge. Online courses provide an opportunity for you to expand your knowledge by providing access to a wide range of courses. Since everyone is battling with lockdown, so there are so many online courses that are out there where you can learn directly from experts who are in similar fields as you are, and you can learn about new technologies, you can learn about existing tools or new languages. Also, you have the opportunity to learn beyond your particular interest. Say you're a front-end developer and you're interested in cloud computing or any other field, you have the opportunity to get free courses or even attend conferences that are not entirely related to your field. And lastly, cultural diversity. Traveling to new places, meeting people of different background can impact your personal development. So diversity is a great opportunity for you to get exposed to different people from different backgrounds or culture, and it gives you the chance to live outside your comfort zone, to communicate better, and to learn from different people. You learn about their backgrounds, their belief, and their perspective. Next, I'm talking about the impact on your personal career. Okay, thank you. So networking, I personally believe that the importance of networking is often underemphasized. Say you attend a conference or you are in an environment with people that are in the same stage in your career and people that are even experts in the same field as you are, or in different field. So networking is very important for job hunting, obviously, but having a big network benefits you in other ways, like getting advice from experts, getting support from people who can relate to the problems that you are facing in your career. And this does not mean that you have to like get a tech scholarship or you have to travel out of where you are before you can network. No, but networking is just one of the benefits of getting a tech scholarship, and it's also has a positive impact in your career. Secondly, it boosts confidence in yourself, especially in your ideas. I know most developers are faced with imposter syndrome. So these conferences are venues for you to meet with people that have similar ideas as you are. And even I know online courses have channels where you can post your ideas, and people who are experienced in this can share their perspectives with you. So this is good because you'll be able to get newer perspective, and also you get feedbacks to improve your ideas. So this can help you boost your confidence and also improve your skills. Finally, adding it to your CV. So this is the part where you get to show off your achievements. I mean, it's a great thing for you to apply for a scholarship and get it, because there are so many people that would have applied, hundreds and thousands of people that would have applied for that same application, but you came out successful. So adding it to your CV would be a great advantage for you, because a recruiter that sees it will definitely know that, okay, you are passionate about what you are doing, you are dedicated, and you're hardworking. Plus, it makes you stand out from other applicants, and it makes your application look very interesting. So I'll let Busayo take the resources that you can use to apply for scholarships.
Okay, all right. Thank you, Odun. So before we even go to the resources, we could like share some of the experiences that I've had in scholarships that I've attended. So Odun talked about you expanding your knowledge in beyond your field or beyond your day-to-day activities. So like, for example, I'm a web app developer, and like I work with .NET like daily. And so when I had this blockchain scholarship one time, so it made me understand how software development in blockchain, how it goes on there in the blockchain space. It's made me know about tools that blockchain developers use. So like, it wasn't like my day-to-day activity. So my knowledge was broadened, that I understood how things are being done in that space. And when I attended HashiConf 2 last year, I got to know about a lot of tools from HashiCorp. I got to know about Consul, Nomad, Vault, Terraform. It was really, really enlightening. And then there were hands-on lab for like these products where Nick himself actually took us in a class, and there were hands-on lab. It was great. And then there was even an opportunity for you to there was a beta course that you could like have a certification in. It was Terraform Associate. Some people took the course and then some people passed. So like, it gives you like first-hand information, like maybe the next tools or the next update or recent updates that people that won't attend won't necessarily know, or people who don't watch won't necessarily know. So it kind of gives you an edge. It kind of gives you like this gap between like, I mean, there's this like knowledge gap between you and like others, and it's a really good opportunity. So I know Odun has an experience as well, a few experiences.
Yes, I do. Yeah, I remember when I had this Udacity scholarship for a course. At first, it was really, really interesting. I mean, I got to learn a whole lot. So that's like expanding my knowledge. I learned about tools that I would not, I don't normally use normally on a daily basis. So yeah, I learned about Docker, Kubernetes, how to deploy application. I think that's the first time I wrote my first Flask application. Yeah, so it was more about learning, and also in a way it boosted my confidence, because I was able to like gain more skills. Yeah, so yeah, it was really, really beneficial to me.
Yeah, thank you so much. So here are some of the websites you could go to if you're interested in opportunities like this. There's diversifiedtech.co. It has like a list of conferences that you could apply to, and some of them offer scholarships if you're interested. So you could look it up. Then there's a repo on GitHub as well, FVC Productions Diversify Me, also has a list of tech conferences that you love to attend. And then on Udacity too, there are courses, a lot of courses, nano degrees with scholarships that you can apply to. And also for women who code, or women who are interested in coding, beginners, mid-level experts, there are opportunities too for women who code on womenwhocode.com. So thank you very much for joining us on this talk. I don't know if there are like any questions on the YouTube chat, but if they're not, thank you once again for listening to our talk. It was a really good opportunity to talk to everyone and meet people like from Africa. So these are our handles on Twitter. You can follow us. Oh, Nick wants to say something.
No, I was going to say we have a question for Busayo.
Okay. Okay.
Are you using the knowledge from HashiConf 19 to better your community? Do you see an opportunity for scholars to collaborate beyond the conferences, and how can they do so? Have you got any suggestions?
Oh yeah, okay. So the first one, yeah, I'm using my knowledge from HashiConf 19. I've worked with Terraform a little after the program, and then do I send opportunities for scholars? Oh yeah, there are a lot of opportunities for scholars. Like right now, I mean, I'm in touch with like 2 scholars. Yeah, like we still keep in touch very well. We still chat very well about the conference, what we learned, career, and everything. So like those are the advantages of attending a conference. You get to network and you still get to keep the relationship with people from different countries and different places. And how can they do so? How can they collaborate beyond these conferences? Oh, they can collaborate by still keeping in touch. The main thing is keeping in touch with people that you meet, like whether it's online, virtual, or anywhere. The main thing is keeping in touch. Yeah.
Awesome. I'm really pleased to see you.
Thank you. Me too.
And I think I'm as I say, I'm really looking forward to seeing you two next year. Hopefully,
hopefully
we're going to get everything rolling again.
Yeah, hopefully. Thank you so much, Nick.
Thank you so much.
It's an absolute pleasure. Literally anytime.
Okay.
You are more than welcome.
Thank you.
Hey, I got a quick question just before we go.
Okay.
So I think when you're kind of looking at the conferences, was there anything that was kind of a little bit overwhelming? I mean, is there anything that maybe, this is a question for maybe conference organizers that could do better to welcome scholarship students like yourselves?
Okay. Well, it wasn't really over. I think the fact that it's been overwhelming depends on the person attending the scholarship. Like if you are maybe reserved, you just have to find like maybe a buddy there. So at least you guys could move together. It actually does help, because when I got there, I met like 2 Africans and someone, so like we blended very well. So it actually helped us to like understand the conference. So it actually depends on the person. When you attend a conference, don't walk alone. Try to find a body, try to find bodies so you guys can find things and do things together. And well, maybe the only thing that might actually sound overwhelming is probably during hands-on lab, the tutor might be too fast, but I mean, it still depends on you. You can actually call the tutor back or the person beside you that is getting it right and all of that. So it actually depends on the individual.
I think there's some great advice there for anybody who attends conferences, actually. I mean, especially the larger conferences, it can feel like there's a lot going on. But genuinely, thank you both so much for sharing your experiences. I'm sure everybody loved the talk. I certainly did.
Thank you.
Thank you. And
next, well, we don't have a live show coming up next. What we have is Ahmad Abadullahs, and Ahmad is a tech lead at Druve in Abuja, Nigeria, and he's the sort of the co-lead of Facebook Developer Circle as well. And what we're going to be doing is we're going to be having a look at Ahmad as he kind of runs through his approach for building API first applications with Node.js. So I think this is going to be super interesting. Let me see if I can actually make this work, because, well, I mean, there's an opportunity that it'll work. It might work. It might not work. It should work. We will see. Oh, it's all going. Let me see. I am pressing that play button.
Everyone, good morning. My name is, or good morning, evening, afternoon, depending on your time zone. Okay, my name is Ahmed Abdulaziz, and I'll be presenting a talk on that's building API first application with Node.js. Yeah, that's the topic. A little bit of myself. Just like what I said, I'm Ahmed Abdulaziz, lead for Druve Limited, and this pre-record presentation. I'll be on the chat if anyone have any questions, so I can actually answer the question. If you have any question, just drop it as a comment, or be glad to help or to clarify anything you want to know. So clearing that, so first, what is API? Well, according to Google, an API is a set of function and procedure that allow the creation of application which access the future of data and operating system application or other services. Yeah, that's the Google definition for that. So I'm going to use a kind of slide to a picture to explain that. So what API actually helps you do is a kind of, it started as it helps you to assess, let me give a scenario. Let's say, for example, you're trying to build an application that is going to cross different platforms. So instead of having to fix every platform one by one, I think with API, you can actually build for web, and it's going to actually serve it. You can build for mobile, you can build for IoT, even if you have an admin system, it's actually going to do that. And from just like what you see from the diagram, like your cloud service can actually be attached to your API. If you have API partner, maybe you have a partner API you're actually working with, you can actually come into your own API gateway here. So your API is actually going to distribute or feed the mobile, the web, and the IoT without you having to create different application for all of them, or different database. So all can actually access different database, different backend, and the rest. So I believe that actually simplify what API actually helps you with. So knowing that that's API. So what is API first approach? API first approach, just with a very simple definition, just from the word API first approach, is an API first development. It simply means developing your API first. Yeah, I think that first is already in the definition. So that's actually the really like a very simple meaning. And another thing, like another definition that you can say, okay, that is your business logic, the functionality will first be exposed to the API before building the rest of the application. So what this actually means, literally like, okay, you firstly, anything you're trying to build, any feature you're trying to build, logic, anything on your application, you firstly build it as an API before telling the front-end guy, the UI guy, the mobile guy that, okay, you guys can actually connect to this particular functionalities. Okay, if your user asks for new functions or you're trying to fix and you're trying to add a new logic, it will always be an API first before actually exposing it. So that I hope I actually justify that and simplify it. Okay, and so API first actually helps us with a lot of things, and one of the things, some things that actually help us with, it helps us to plan. So API first helps us to plan the functionality and the logic of the API. Yeah, well, because you've actually firstly tried to do all your Yeah, I know a lot will say that. Of course, I do plan before I write my code. But with API first, you already draft all the logic and the functionalities of the application, and you know how you're actually going to expose this to your user. Data to be exposed. And with API, you actually really plan the data that will be accessed internally, or the data that will be accessed to your users. That's if you're definitely if you're building, let's say for example, you're building an API that is supplying other users, maybe apart from your internal application, you're building API, for example, GitHub, yeah, there's public API for them. So you know the kind of data you're actually going to. So API first, actually that thinking helps you to kind of settle down and think, okay, how are we actually going to plan this? And scalability, yeah, it's API first approach actually make it easy for you to scale your application, right? It's really help you instead of when you're actually growing, it's really helps you to grow fast. So why API first approach? Because okay, I've been building API, I've been doing this, so why should I do API first approach? Why is that? Okay, API first approach, your development team can work in parallel. Like API first approach really help you with agile system. Yeah, it helps you because when you don't really have to wait for the designer to finish or this one. Everybody can actually start working on parallel, like work at the same time. It's really to support agile system, which I think that's the best way of building any software this time around. So far, actually very small software. It reduces the cost of app development. Yeah, it actually helps you reduce the cost of app development in the sense that you don't really have to build for different different backend from different platforms. You're just connecting to all your platform are actually just connecting to one single API, which that really help you a lot when building an application. It increases the speed to market. Yeah, when you're actually exposing, when you're working with API, you expose the API that are actually ready to your user. You don't wait until all the application is actually completed before you know that, okay, yeah, my application is complete totally. Any part that is actually ready, you can expose that to your user. You can test that with your user, and that actually helps you. We reduce the risks of failure. And from the application you actually send to your, or from the one you test a lot before you actually send it out. So that will actually help you to iterate fast and know that, okay, yeah, this is actually going to work. This is not actually going to work. So that really helps you to really move fast and fail fast and actually fix your bugs and failure fast. And scalability again, yeah. From what I explained the other time, is help you move when you're thinking of, okay, I'm trying to grow, when you're building like all the cloud service or any cloud service, you actually, almost everybody, yeah, is actually using cloud service now. So with that, it helps you actually scale to other platforms, to other device, or to actually grow bigger. So that's another why I think we should all use API first. So API first approach might not be for you. Yeah, like as cool as it is, it might not actually be for you. Like if you are building a very simple stack application, just your front end, back end database, like just very simple application. Yeah, you can use it. It's not bad to use an API first, but I think it's kind of the overkill. Yeah, that's what I think though. So a startup trying to get out fast. Yeah, if you're a startup, I've worked with different startups, and one thing I really noticed is that for startup, they really we need to be out there very fast. We need to be out there very fast. An API first approach will really take time because you need time to plan, you need time to test, you need all those time. So it might really kind of slow you down. But apart from after that, trust me, it's really worth it, because after all your testing, you know, okay, you're not getting this kind of bug, you're not getting this, you really test a lot. And so, but if you're really trying to kind of hit the market very fast, or as fast as you could, API first might kind of be a challenge because it's really slow down when at first stage. But after that, right, it's really easy for you to grow more faster. So, and if you're wondering like, okay, API first, is anything, or how many companies actually, these are some list of companies that are actually using API first Twilio, I think Twilio is actually a API only company. Twilio just expose their API to you. They don't really use it. So it's API only company. I had someone who was actually talking of something like API as a service. I don't know if that's actually a real thing, but I think that we're actually moving towards that. And I think that's what Twilio is actually doing presently. We have Stripe, we have Angolia, we have ST, we have Netflix and Sendgrid. So these are like kind of big companies that are using API first approach. So you know that, okay, this is actually something you should really explore. So that part, that's me clarifying what API first really mean and what API is stuff. So I say, okay, building from the topic said building with Node.js. So for those that actually don't know about Node.js, it should be kind of weird. So Node.js is actually an open source cross-platform JavaScript runtime environment. They're very popular tool, and it's suitable for almost all projects you're trying to run. Is a JavaScript runtime engine on V8, that's Google Chrome engine. So it helps you, basically it helps you run your JavaScript on backend. We all used to running JavaScript on our browser. So this actually helps us to kind of develop JavaScript on our server. So clarifying that, a kind of prerequisite on what you actually need for you to start using a Node.js application. For you to start building Node.js application on a machine, you will need to install Node.js. Yeah, obviously. You need to install MongoDB. It depends on, sorry, these are actually, but for this example, I'll be using MongoDB. You can install MongoDB on your system locally, or you can actually use MongoDB Atlas as the cloud support for MongoDB. And I think it's really, really cool. MongoDB is a non-relational database. So it's really good for startup like you're trying to actually build fast and go out there. So Postman for testing, we'll be using Postman for testing is an headless browser for testing your APIs. Getting all that too, moving forward. So bien pasemos. I don't know if I pronounced that right. So let's get started. So to build your API, sorry, I'll be using, let me put this, I'll be using Node.js library that actually make it easy for us to call our HTTP and kind of make it easy for us to work with Node.js writing a big code, and it's very, very simple and straightforward. That's Express. So for you to actually start, you can create your I'll be building a very simple application. That's my contact. I just want to build a very simple application and show you how it is, but in a kind of API format that will make you very easy and scale. You can actually think of scalability of that. So I'll show you that. So make that's on your terminal. You create a directory, my contact. You cd into that. So after cd into that, you create a package.json. To create your package.json, you actually depend when you install Node.js, you install npm directly with it. So if you install your Node.js, it's actually coming with your npm. But I prefer using Yarn, which is another kind of did the same thing that npm, that's Node Package Manager, actually does. So this is your package, the JSON. So that will actually help us to know, okay, all our dependencies we know for this particular project and start everything. So I'll be using Yarn. So for Yarn, you'll be using Yarn init, that's initialize -y. This -y flag is just to show that, okay. And normally if I remove the -y, it's going to ask me some couple of questions, but just for me to skip all those questions and just create the package.json file for me. So I'll be using -y, just like, okay, yes, -y actually means yes for every question you have. So after, you can use your npm to, if you use npm install -y, so it's actually going to give you the same thing. Sorry, npm init -y is actually going to give you the same thing. So here we have yarn had. So I'm trying to install all the dependencies I'll be needing for this application. So I have yarn had express, body parser, mongoose .env and ESN. These are the dependencies, just like kind of basic dependencies I'll be needing. I'll be explaining these as we actually move on. So yeah, and I'll be installing NodeMon. NodeMon is actually kind of help me instead of anytime you kind of make a change instead of restarting your server all the time. Yeah, npm NodeMon actually help you to restart automatically without you restarting your server all the time. Clearing that. So this what your package of JSON will actually look like. You will see the script, the author, that's your own name, that's your GitHub name, the license. Then these are the dependencies. You see the body parser, the .env, the ESM, the Express, the Mongoose, and the NodeMon. So what the body parser actually help us to kind of pass the JSON directly into our like anything we send from the HTTP, right? It actually helps us to handle that the JSON. We have the .env. .env is kind of environment file, so you use it to store all your environment. But let's say, for example, you have keys, you're actually using maybe your API keys you don't want to send to GitHub, so you use your .env file to actually save that. Then your ESM. ESM is actually application that allow you to import, to use import instead of normal Java Node.js require. Yeah, the Node.js team are actually working on the ESM. They are working on the import part, which is I think I've forgotten the extension we use for that, but they've released that, but it's not like completely stable. So I prefer using ESM. Some actually use Babel, which I prefer, but I think configuration and everything, I don't really like going through that stress. So, but with ESM, you just install the ESM. So after installing that ESM, you can use it to run your application. So just like what you see on the start here, Node does R flag to like pass it to the ESM, then ESM the server that's just it. Then the Mongoose will be like it's the ORM for our database. Yeah, MongoDB is actually is non-relational database, right? So and that can actually we can actually mess up the database very fast with that, because you can just kind of start pouring all the data without any structure and everything. So which that might actually affect your API or the way you actually build this at long run. So with Mongoose actually helps you to kind of structure your database, like give your database a structure. So that's why I choose. They are actually different out there. And if you want to use a MySQL database, there's SQL tool that can actually help you with that. So then we have the NodeMon to actually help us restart our server. So your package of JSON should look similar to this. At least you should have all the dependencies installed. Before I actually start going, I want to explain how my folder structure will actually look like. I love when I'm building API, I love actually using the MVC. That's model view control, which I think is the general accepted design for Node.js. Like you have your controller, you have your model, you have your view. That's when if you're actually building. But since I'm actually building an API only, so my view will be omitted there. But you can actually, everybody can actually, I can build my view like with maybe React separately, then can connect with this, which is really, really fine. So I love using MVC as my design. So this is my controller here. I have that's the user controller. Then I have the model, which I have the user model too. I have the routes index. That's all my routes will be in there. Then I have my utilities file, which my DB connection will be there. My error handling. Then the helpers file. That's just for me to write some function that I really want to use. So after initializing that, I just want to show you the structure of how my folder usually look like. So which is that we can you can maybe use if you're used to GUI, you can create a file, name it server.js, or you can do that directly from the terminal to just touch server.js. And that server.js actually help you to create your file. So we've installed our dependencies, we've created the first file, which is your server.js file. So it's time for us to initialize the server, like, okay, let's get our server running first. So to get our server running, I already explained that, okay, we'll be using Express, right? So you import the Express, from Express, that's you're actually importing from your dependencies. So you have the import JSON, that's the, I'm destructuring this from body parser. Then I'm requiring the .env to, like, from the configuration, and then I'm passing the part of that my .env file, which I actually have from the folder structure. I have my .env here, so that will actually help me with that. So I create after importing my Express, so I have my app equals to Express. That's me now initializing calling the Express function itself. So I can now use that app now, actually use it, that's the server now, to pass every other middleware and anything that I'm actually want to pass. So now here I have app.use, which is express.use JSON. I'm trying to pass the body parser and everything here. Then I have my route. So I have my route here. So this route is just like the welcome. So welcome page, that's when you have your slash, just like you have your index. So router dot, sorry, this is actually supposed to be app.get. I'm going to explain why I router.get here maybe later along the way. So I have res.status, which is 200, is going to actually return 200 status for you, that, okay, what you're actually trying to do was successfully. So welcome to HashiTalks Africa. And then I have my app.set. This app.set helped me to set the port of my server. So we have different, most randomly used ports are actually maybe 80,000. So just like that. So this will actually display your app is running on your console. So this actually is what will display when you try to run this. So moving forward from that, we have my database connection, just like what I told you, we'll be using Mongoose, which is an ORM for MongoDB. So this is how my database connection actually looks like. Yeah, I have the calling that's importing the Mongo, and I have the DB connection. Then yeah, pretty much that's just the connection and everything. So if you have an error, it's going to log the error that, okay, maybe the database is not well connected and the rest. So you're actually going to have that there. So you export it so that you can actually use it in other files. So so this comes to the model part. So, I talk about MVC, that's which is controller, MVC, that's model, V, that's for view, and we have the C, which is for controller. So the model part of it helps you structure your database. So here I import my Mongoose, which is the ORM I'm using. I'm trying to say, okay, use, because there is this error that usually pop up for. So I'm trying to tell the Mongoose to use the global promise. I use Node.js global promise for handling promises. So here I'm kind of, I'm trying to structure, that's my schema structure that I'm passing here. So mongoose.schema, then I have that's the first name, it has to be string, it's required. The last name, string, required. Then the gender, which is string, is not required. You can put the gender or not. The email will have to be, the email string should be unique. This part actually means, if the email is not there, which will give you null, you can have multiple null with that. Then I make it index, that's on the JavaScript index, on the MongoDB index. You can really check that out. That actually really help your database with run your database fast. Depend on the index you're actually using. Then I have the phone number. So this is just the structure of my application. This is everything. This is just the structure of my database. This is everything I actually want to collect from my user, and this is the way I want them, right? So after that, I export to my database using mongos.model user. So the name of that collection will actually be user collection, which is just like your table. Then you pass your user schema there. Wow. Then now we have our controller. That's the C part of the MVC. On our controller, we importing the model. That's my mongoose model I created. I'm importing the model. That's following the part, import the model. Then I have these function sync. Instead of like I tried not to kind of repeat try and catch all the time. So create a function that actually helped me to handle that try and catch. So instead of writing try and catch all the time, this helped me with that, which is inside my helper, that's utility folder. And I have so for me to create you to create a contact now. So I just name the function create user, which I'm exporting immediately. So you can do this in a different way. You can export the whole thing at the same time, but I just prefer using this method, which is me exporting all the functions I'm actually creating one by one. So with that, I have the create user. So this async handler actually helped me, just like what I said here, imported, helped me to handle my try and catch yourself, writing try and catch all the time. That actually helped me with that. So I have the request async, then the request and the response. Here, I'm just trying to make it as simple as I could, since I'm just trying to create a contact, not any kind of big logic that actually could actually running here. So I have a constant that's a variable new user. I'm passing the user model that I imported from there, so .create, and I'm passing all the query. Actually, that's everything I'm sending from my front-end application, everything that is inside the body, I'm passing it directly to create my user. And normally, right, you have to kind of check all the okay, and you have to validate your inputs. Like you just don't pour the input directly into the database. You have to validate that, okay, is this email actually correct? This phone number the way it should be, and the rest. But I'm just trying to make it as simple as I could, so I'm passing that directly. So this actually helped me to create my user into the database. So this is the response. The response will be 2.0, and which means it's actually successful. And you have your message. Depending on the kind of message you want, you can actually pass it anyway. Then the data will be new user, so it's actually going to return the new data you just created for you. So we have the get user too. So if I want to get a particular user, right? Let's say, for example, I'm trying to search, okay, this particular user in all my numbers. So I can pass the parameters, the ID. I will be expecting the ID from my URL, or from my URL. So I'm catching that ID and passing it, which is a parameter, right? I'm passing it into this. So I'm going to use the model.find by ID, which is the ID. You can actually use different things. So actually, I can use name, I can use, but I think ID is kind of simple and straightforward. So, and a username would be kind of weird because you might have different people with the same name. So you choose something that is kind of unique, right? If you're trying to find one particular thing, at the same time, you choose something that is kind of unique, maybe email, or phone number. So this will actually return the data you're trying to find, and it's going to check if the user if you can't find any user there or user that have that particular ID, it's going to return user not found. So this is you reading now, right? We create with the create user, we create with that. So me now trying to read maybe the user I just created or that. Then after that, I'm trying to update. If I'm trying to update, so it's still the same process. You pass the parameter. That's the one thing that is unique about the user. You pass to find the user. After finding the user, if the user is found, it's return. If it's not found, rather to return user not found. Then you await it. That's find by ID and update. That's you're still passing the same ID now. After search for the ID, which I think that's actually repetition. So you're passing that ID and updating. That's with require. That's body require.body. So you're still passing all the parameter you get from your body. Now that's, let's say for example, I'm only want to update my name. I'm expecting only the name to, my first name rather, I'm expecting only the first name to come, so I'll update that. Just that's straightforward and simple. Then I have what's it called, to delete a particular user. If you want to delete a particular user too, you just need the parameter to delete that particular user. So this is just a very simple CRUD, right? Create, read, update, and delete. So I think going through all that, so now that means I have an API I can actually expose. I have some routes rather that I can expose, right? So these where the routes actually came in. So for the routes here, I'm importing the express rather. So the express, which is the general, which I'm using to at the HTTP library for managing my Node.js. So I have the create user from my, the create user is from my controller, right? So I imported all the create user, the get user, the update user, and the delete user. That's from the controller, that's the parts from the controller here. Then I'm declaring my route here, that's express.router. So this router now, right, is just like, okay, it's a method inside the express. So that's what will help me create the route. So router.get slash that's, which is the same thing we saw when I was actually trying to initialize the server. With this slash actually tells me the index, which will show you welcome to HashiTalks Africa. So I just want to use that as example. Sorry. Yeah. So yeah, down here I have my, why is this not scrolling? Okay, yeah, that's one. So down here I have my router.post. So which means this is where when you your post method from the front end. So when you use slash user, right, it's going to call this particular function which I imported from the controller. So that will actually help me to create my user. So I use router.route. This in Express actually, instead of you having to do, if you have the same path you're trying to call, which I have the same route rather here, which is router slash the ID, that's the parameter I'm sending from the front end. So since I have that, so instead of having to create them one by one, forget update, which I use put or delete, instead of having to do that for each one of them, so you can just do that on a straight line. So I have router.route instead of .get directly. So I'm going to put the route that I needed, which is user slash ID. .get is actually going to call the get user, that's this particular one here. Put, which is update user, is actually going to get that, and the delete is actually going to delete the user for us. So here I'm exporting that, right? That's after creating my router, I'm exporting my router. Then finally, finally we have this, how your full server will look like now. After creating all your controllers, your model, so you have your parser here. You have I'm importing the DB creation I showed earlier on. I'm importing my routes, yeah. So this is the DB connection. So I'm calling the DB function here that I imported above. So I have my app, which is so the same thing I explained earlier on. So we might actually have different version of our application. So since we have different version of the application, so we can use that as app.use/API/version1. So this another thing that API actually help us to do. Let's say let's say when we started, we have version 1, right? And maybe in the next 1 year, we make some changes, we make some this, we can have version 2. So instead of trashing all the version 1, right, that will cause some break, that will cause some user applications to break, or some, if you are building API only for other people to use, that may actually break their production too. So you have them in different versions for it to actually help maintain everybody application. So you have the ports, just like what we have initially, and you expose that. So this will actually look like. I have all the code like on my GitHub, so which I believe I actually have the link to it, or I will be sharing the link on the comment section for everyone. I need that. So, and me using Postman to test, right? We have to actually test that, okay, is this really working? Is this how we actually expect that? So I create a collection, that's a content API collection. So we have the user, that's the user collection, sorry, content API. Then we have the user collection, which we have the get, we have the create, we have the update, we have the delete, and the rest, right? So these are how you actually pass your data from the as a JSON, right, from the Postman. So after passing this, if your creation was successful, it will give you this. So yeah, it will give you this. So I think that's how to actually use your Postman, which is really, really simple and really, really cool. So this actually help us to expose the different version, like the different routes. So here we have a URL, which will be the URL of your, if you host it, since I have not hosted it, to be my local host and the port, then I have the API version, which is version 1, and the route I'm trying to access, right? So I have my post here and I send the data and the creation was successful. So as that, so we have different routes, there are different API routes you're trying to access depending on what you're actually doing. So yeah, I think, yeah, thank you. That's all. Thank you very much.
Well, that was pretty awesome there. We had Ahmad just kind of giving us the run through of Node. And next up, we've got an equally amazing talk, because I think pretty much everything is amazing today.
That's all. Thank you very much.
Always a pleasure. Now, coming up next, what we have is another wonderful talk, and we're going to be looking at how you can kind of keep your CI/CD pipeline secrets. And we're going to kind of look at Abu Kar, there's Ango, and his talk is going to kind of dig into these things. He's a certified Kubernetes administrator. We're going to hear some wonderful things and a wealth of what information, I believe. If I can make the technology work because the technology does not like me, maybe I can make the technology work. Can I make the technology work? You can do it, Nick. You can make it work. I can't do it. Am I doing it? Well, I think you might.
Hello, everyone. Thank you very much for joining. I am Abubakar Siddiq Ango, and I'll be talking to you about secrets. Can your CI/CD pipeline keep a secret? Secrets are so hard to keep. Yeah, as humans, we usually say 1 is private, 2 is company, and 3 is a crowd. Once something code there is exchanged with another partner, every friend has a friend. That information is already gone, and you have to no control over where it goes and how. But first, in terms of computing, what is a secret? In this talk, we are going to look at what's a secret and why it's so hard to keep, how most CI/CD pipelines currently handle secrets and its vulnerabilities. We're going to look at how you can use Vault with your CI/CD pipeline and the JOT authentication method. And at the end of it, I'm going to show you a demo of how you can use GitLab CI with Vault. First, what is a secret? Secrets are any credentials that you need to authenticate, authorize, or approve access to a resource. So this can be tokens, it can be API keys, it can be passwords, it can be certificates, it can be anything that allows you to authenticate, authorize access to something. Now, but it's very, very hard to keep secrets safe. It's not about if your secret will be discovered, it's when. And in the news lately, we've seen several stories. A simple search of on Google will show you different news stories of how secrets were stolen or how they were dumped by hackers. Now, why is it so difficult to keep secrets? It's because these days, we manage hundreds of unique secrets for various purposes. You have AWS keys, you have API keys for different services, you have passwords, and so on. Keeping track of them is difficult. Now, and multiple people need to have access to these secrets, probably for authentication or for deploying services. And again, we also want to use complex passwords because we wouldn't want someone to be able to guess our passwords. It becomes more complex. We can't remember them, and writing them down is definitely not advisable. So, and we've been advised very most lately to rotate our passwords very often, almost every time. But how do you rotate if every time you have to go to you have to create new complex passwords, you have to go to the services, change them, and so on? Manually rotating password is a lot of work. Then CI/CD. CI/CD is basically automation, and we love automation. Continuous integration and continuous deployment or delivery allows us to be able to build our projects, to be able to test them, and to be able to deploy them automatically. It's gone are the days where after writing your code, you have to test them manually on your system and then upload them through FTP or any other means online. Now, you can set up a CI/CD pipeline where just a little change in your code is automatically tested. It's automatically built, tested, and pushed to production staging or anywhere you want it to be. Now, most of these CI/CD tools, there are tons of them out there, Jenkins, Drone, Go, and so on, including GitLab CI. Almost all of them, if not most of them, use environment variables to be able to pass secrets to the jobs, the CI jobs. Most of them provide you with an interface where you specify the variable name for each of the environment variable, and you supply the secrets that you want to be held in the environment variable. And to be able to protect these secrets, some of the CI/CD pipelines mask the variable so that it won't get exposed. But we are humans, and we are usually weakling in this kind of secure systems. What could possibly go wrong when using secrets with CI/CD, especially when you're using environment variables? First, expose secrets in job logs. There has been a ton of incidents where hackers comb through the job logs, especially job logs that end up being public. Those that are not being public, when probably a CI/CD provider is hacked and they are able to get access to these job logs, they comb through them to discover any secrets that have been exposed. And secrets are usually get exposed by either echoing them or using them as part of a URL request, and it ends up being shown. A lot of the CI/CD providers provide a means for you to mask this password. But it's even with the masking, someone can still get access to the password if CI/CD provider is hacked. Now, I provide here an example of a news article stating some of the recent incidences where hackers are combing through CI/CD job logs to steal any exposed password. Now, the other major thing that could go wrong is privilege escalation. Yeah, even when your password is masked in a CI/CD provider, the next thing is your employees or developers who manage the job, who write your code or manage your deployment. When a secret is kept in a project or a level where someone who is not supposed to get access to it gets access to it, even if it is masked, they can easily take this secret and do whatever they want, especially when you have disgruntled employee or you have an employee that's recently been sacked and he really wants to do some harm. So the two major things that could go wrong with using environment variables and CI/CD is secrets getting exposed and privilege escalations. Secrets getting exposed, a lot of the CI/CD providers are now providing a tool or a means or some mechanism. For example, like Travis CI, when they discovered hackers are combing through logs to discover this, they decided to create a logic that checks the job logs to see if there's any pattern that is similar to a secret, and they mask it or obfuscate it. So other providers like GitLab provide you a means to mark your secret as masked, so that even when it's echoed or displayed, or an instruction is trying to display it in the job logs, it only shows masked. Now, the best kept secret is a secret that doesn't exist. But how do you create a secret that doesn't exist when it needs to be used? That's where you have things like dynamic passwords. Passwords that only get generated when they are needed. And as soon as they've been used, maybe once or after a particular period of time, they expire and they are no longer needed. And constant rotation of password. The password is created today, maybe by midnight, it has been rotated by midnight. So it's very difficult for a password or a secret to stay too long without it being replaced. This allows an organization or a company to be able to make sure their passwords are always fresh, and they are, for anyone to, like a disgruntled employee, to want to have and keep a secret to harm the organization. Probably by the time he gets home, the passwords have already been rotated. It might be all the secrets within the organization. And that way, the organization has no secrets while having secrets. Now, the best solution to be able to effectively manage secrets is to use a secrets management tool to provide you with a secure secrets management, constant rotation of secrets, and data encryption. And one of the major players is Vault. It's Vault. Vault gives you a very robust and secure way of managing your secrets, including data encryption. It also comes with a data encryption API that you can use to encrypt any data that you want. Now, one of the beauty of it is you don't need to start coming up with any new identity management system. It can readily plug to any identity management system you have and help you manage your secrets effectively. Now, when you're using Vault, you need an authentication method to be able to authorize your users whenever they want to request a secret or put a secret. And one of the ways you can do that, some of the ways you can do that is by using a username and password or using AWS if you already have, if you are using AWS as your identity provider, or GitHub, Radius, Okta, and a number of them. But the one we'll be focusing on in this talk is JOT and OIDC, OpenID Connect. Now, the JOT method allows you to use a tool, for example, like GitLab CI or Travis or any other CI/CD, to send a JOT to Vault, and Vault authenticates it and provides the token that is necessary. So there are two ways. You can either use JOT, which is authenticated using OpenID Connect, or you simply provide the JOT to Vault and it authenticates the user. One advantage of using JOT without OIDC is it can be simplest without any user interaction, but OIDC will authenticate against an identity service provider like Auth0 and so on. But you wouldn't be able to use that. That won't be effective for a CI because everything needs to be automated. But with just using a JOT file, sending a JOT token, it's no user intervention is necessary. It simply sends it to Vault. Vault authenticates, moves on. Now, how does Vault authenticate your JOT signatures? It can do it in three ways, either by you providing Vault with the static keys it needs to authenticate the JOT token with, or you provide a JSON web key set URL, where anytime Vault receives a token, it sends it to the WebKit set URL, and which authenticates it and responds back to Vault to provide the token. Or you can provide an OpenID Connect discovery URL. But for our case here in this talk, we'll be looking at using a JSON web key set URL. Now, when you are creating your JOT signatures, one of the ways that you can use to limit or authenticate, authorize who uses Vault to access secrets is by creating bound claims. You can say, for example, okay, this CI/CD should only be authenticated to retrieve secrets if it's for a particular project, a particular branch, and there needs to be a user, or and so on and so forth. You can even go as far as saying production keys should only be accessed by a job being run on the production branch of your project. And staging should only access keys from the staging keys that are already stored on Vault. Now, this is a diagram showing how the JOT authentication happens. Now, when you are running a CI job on, for example, GitLab CI, it automatically generates a JOT token containing all the necessary information needed for Vault to authenticate the request and sends it to Vault. Vault then communicates with the GitLab instance using the WebKey set URL to verify, is this token still valid? And the claims that has been listed in it, are they correct? Are they valid? If everything is fine, then it creates a token and sends it to GitLab CI. Now, the token has a TTL, time to live. By default, if none is specified, it's 5 minutes. Or it uses the TTL of the CI job, the timeout time of the CI job itself. As soon as the job is completed, the token has expired. So this way, no token lives further than it's needed. Now, I'll be running a demo of how you can do this on a CI/CD service like GitLab CI. First, to do this demo, we'll look at the JOT payload that is created by GitLab in the first place. Now, for every project, GitLab CI creates a CI_job_JOT environment variable and provides it to the job. Now, and in this variable is a JOT that contains every information that Vault needs to authenticate the request. Now, first, aside from the usual JOT data that are included here, we can see a namespace ID. This is, okay, if a project that you are trying to work on GitLab belongs to a particular group, GitLab provides the group ID, provides the group path, it provides the project ID, it provides the part of the project, the ID of the user who is running the job, the email of the user running the job, the pipeline ID that is currently running, the job ID that is currently running, the reference of the job, which is usually the reference that is used to mark the job that is running, and what is the reference type? Is it a branch or what is it? Now, then also if the branch is protected, here the ref type that GitLab sends is a branch. And within GitLab, you can specify if a branch is protected or not. So if a branch that is not protected is running a job and tries to retrieve a secret, it will fail because we already specified here that it's only when the ref, which is a branch, is protected, that is when a request should be authorized. Now to enable JOT on Vault, one of the first things we need to do after you install Vault, unsealed it, and so on, is to enable the JOT authentication method itself by simply running Vault auth enable JOT. Then we will now write the configuration for JOT using CMD. You can also do this in the Vault UI. Now, in the configuration, we are going to specify to Vault that our JSON web key set URL is gitlab.com/jwks. And, oh, a little mistake there. I put double dots instead of single dots. Now, then the bound issuer is gitlab.com. So any issue authenticates that this request has to come from gitlab.com. Now, we also need to create access policies. For this demo of mine, I have a GitLab project that has 2 branches, the master and production. I'm using the master branch for my staging code and the production branch for production. So I'm creating 2 policies here. One, the first policy is for staging. Anytime any password is accessed in the path KV vault demo staging, if any staging secret is accessed, it should apply, it should only give it the capability to read. Now, if any secret is trying to be read from the production path of my keys, it should apply the staging policy and only give it the read capability. So if a request is being made for a secret and probably is trying to access production keys and specify the staging policy, it won't be able to read it. Now, then the next thing we need to create is roles that will link our JOTs to the access policies we just created. The first one I'm creating for staging, and I'm specifying that the token that will be created should only last for 60 seconds. Now, and also the user claim should have user email. It should be this specific project ID. If you remember in our JOT, GitLab sends the project ID, the ref, and also user email and all the information that is necessary for you to authenticate. So now in our role here, we are saying we'll be checking the user claim should have a user email, and the bound claims must be this project ID. It must be, the ref type must be a branch. If it is anything else, we are not accepting. Then it must be master for staging. Then for production, we are creating production for role also, which all uses the Vault demo production policy, has a TTL of 60, and also this particular project, the ref, which is the branch, should only be production. Now, once we've done this is an example of a GitLab CI script. And what it does here is it uses the Vault Docker image and creates a job called read secret. But this job only runs for ref production, that means the production branch. Now, the first thing we did here is to echo the commit reference, just for diagnostics, is for us to see exactly what it's doing. Then we specify the vault address, which is here, for in my case here is vault.abango.me, port 8200. Then we request a vault token. From here, you can see we are saying request a token from our vault with the role vault domain production using this jot from provided by GitLab. Now, once it does that, it authenticates and authentication goes smoothly. It retrieves the password in the field key from the path production API, and it echoes the password. Now, we also try to show that if we are now using, trying to access the API key that is stored in staging, it will fail because this branch is for production. The same thing goes for when we are trying it on staging. Remember, we said our staging branch is master. So we use the staging role to retrieve our vault token, then retrieve the staging API key. But if we try to access the production key, it fails. Let's see this in action. Not going anywhere yet. Now, this is my demo project, and this is the GitLab CI file that I have. Now, just like you saw previously, the CI file has two jobs. First one is to read secret, and it only runs when you merge or push to master, which is, in this case, is our staging. Now, the second job only runs when you push to production. And the production job uses, let me zoom in to make this more legible. Awesome. Now, like I started earlier, the first job only works when you merge to master, and it uses the vault demo staging role that we created to retrieve a token, authentication token, vault token from vault. While the second one, which is which only works when you merge or push to production, uses the vault demo production role to retrieve a secret, to retrieve the vault token, and tries to access the production API key that it needs. If it tries to access staging, it fails. Now, let's run this as a CI pipeline and see it in action. Now, I run pipeline now. Yeah, this will simulate, okay, merging to creating a push to production, to master. Now, let's run this pipeline. It will create a job called read secrets. Now, in this job here, I already have my vault instance at vault.abango.me, and I've created all the policies and rows needed to make this demo much faster. Now, this is pulling the vault image from Docker Hub, and as you can see here, based on our job, we said it should echo out the CI job jot, but it's maxed. GitLab maxed it. It won't appear. It's one of the ways you can protect your environment variables. Then it commits our ref name, its master here, and it's protected. So it tries to, it sets the vault address to our address here, and it tries to retrieve the vault token, which is authenticated. If it failed, it will have logged here that it failed. After accessing it, then it retrieved the API key for staging and displayed it for us here. Now we tried retrieving the API key for production. It failed because permission denied. It's not authorized. Why it's not authorized is because we logged in with the Vault to demo staging role. Now, let's run this pipeline again, but against the production branch. Now, I was specifying the branch to use here, which is production. And I'll run the pipeline. Now, it will create a read secret prod job. And that job only has the role for production. So it will now fail when you're trying to access the staging secret, but work for production. Now, as you can see here in this talk, we've seen how, now, you can see here, it was able to access our production key, but failed when I'm accessing staging. Now, you see here, we have been able to use GitLab CI or any other CI tool that you're using to access secrets that we are authorized to get access to, using a token that only lives for the duration of our job. So here we have secrets that don't exist. Because even the secrets that are in the API that are involved can be rotated at any time, or can be dynamic secrets that are automatically generated when requested. And as soon as you are done for one time use, it's gone. So even if someone picks a secret here, they cannot use it again. Now, for purpose of this demo, I decided to echo the secrets I'm retrieving from Vault, but it is not advisable, or you shouldn't or never display your secrets in CI log. Thank you very much for joining this talk. I'm happy to take questions in chats, and you can follow me on Twitter at Saruki247, and also you can check out my website abuango.me, so we can share more and collaborate. Thank you very much for joining.
Well, that was pretty awesome. I think you will all agree with me. Now, who has been having a pretty terrific time today? Because I think every single one of our speakers has been nothing short of outstanding. And I am absolutely full of appreciation and awe. Thank you so much for giving up your time and sharing some wonderful content with us all. But it's not even over. It's not even halfway through. We've got so much more great content to come for you. And next up, we've got Kazman. Hey, Kazman, how are you doing there? Are you excited? Are you all ready for your talk?
Yes, I am. Thank you.
Awesome.
Yeah,
we're all excited, and you're going to be talking to us a little bit about how to bring communities together, and maybe using the Swiss Army knife of IT.
yes, exactly. It's a tool that helps bring communities together. It's a bit of. I will try to talk about my show in the process. I have a show that I run weekly, and so I've been able to leverage on different tools, and I come up with this tool after the lockdown. So I figured this tool is helping me get the job done.
Awesome. Well, I'm going to just let you take it away. Whenever you're ready, feel free to share your screen, and really looking forward to it.
Okay. Thank you. All right, so I can get to it now. So the topic again that I'm going to be covering, I presume everyone can still hear me and can hear me clearly.
Yeah,
I can.
loud
Okay.
and clear, buddy.
Okay, perfect. All right, so the topic that I'm going to be covering today is Microsoft 365, Office 365, using the Swiss Army knife of IT to bring communities together. So here is an overview of what I'm going to be talking about for this, my 30-minute window. I'll talk about communities just a little bit, and talking about the fact that we need different tools to drive, some of these community events, some of these community activities that we put together. And I'll talk you through my show and, some of the challenges that I've faced on the show and how I've been able to also leverage, a number of these tools to get things to work. Then we'll try to wrap things up. So a little bit about me. My name again is Kazim Adegwega. I'm an IT professional and I'm a cloud master as well. I've been doing this now for more than 15 years, and I'm also a Microsoft certified trainer. So let's begin with communities. As someone who is been running community events for a while now, we know that the role of community leaders, that's IT community leaders now, is to ensure that we're bringing about the technological well-being of individuals and or group of individuals by empowering them in the area of technology. And sometimes too, we happen to act as a role models, so for some of those people who share the same interests as us. So I'm a trainer myself, I train, and as a trainer, I just naturally, love sharing my knowledge. And, one of the ways of giving back to the community is by cooking up, some of these events from time to time, free events, cooking them up via meetups, and sometimes it might be
Oh, we just lost, I think we just lost audio there, Kazman. I'm running out of jokes. You can't rely on me.
Hello?
Hello. Oh, we got you back.
So I'm sorry about that.
Oh, you're okay. Internet.
Okay.
It's just
Sorry.
designed to be unreliable.
All right. So I'll jump back at it now. So I was talking about community, how IT community works. And I was, referring to myself as somebody who organizes community events from time to time. So I personally think that the way IT community, or what is expected of IT communities, is ensuring that we're bringing about the well-being of people through technology by empowering people, a group of people, through technology. Some of these people might share, the same kind of interest that we do. And for me, I'm a trainer, I'm a technical trainer myself. So I just naturally love sharing my knowledge. And so it's one of the ways of me giving back to the community. And one thing we also will notice when we share our knowledge is that we become better at what we do, by sharing our knowledge with others. And we're also in the process able to empower people, to, do some of these things that we know how to do as well. So that is what IT community is all about. And it's important to note that some of these community events that we bring together, we cannot do them without leveraging on tools. So we need tools to be able to effectively build an IT community. So one of those tools that we can leverage on would include social media kind of tools. When we have an event that we're trying to cook up, we'll need to reach out to different people. So there are a number of tools on social media that we leverage. We use Twitter, we use Facebook to ensure that we get the message across to people out there. And we also have some advertising tools that we need to use. Tools such as the Eventbrite, the Meetup, to make all of these things happen. And we have other tools, like my own favorite all-in-one tool is this tool known as, is a solution known as Microsoft 365. So I just happen to see it to have all of the different tools that I need to get my community event up and running. Now, I'm going to be sharing my story about this tech show, this weekly tech show that I run. So it's named Tech Talk Wednesday with Kazim. So I run it. It's initially a radio show. So I run it every Wednesday on a radio station. So it all started with my new engagement. So my new engagement happens to be inside in a university environment. So what I noticed in that environment, LASU to be precise, that's Lagos State University. So I noticed that that IT community activity is a little, it's not up to speed, in the environment. So I thought it's something I could help improve. So I started up with putting together boot camp, a day boot camp, and have people attend. I have meetups as well from time to time. So I do this, every once in a while, and I've been able to even record a few success stories. Now I have some of the students very, each time there is an event coming up, they really want to be, at the forefront of the event. They want to speak, at the event. And I've noticed some of them would even come to the center to say, oh, can you please help us set up a space? Can you help with internet? I have the solution that I'm working on. And to my surprise, one of them was able to, come to me just recently, and then he showed an app that he was able to build, with some of these tools that we taught during the meetup. This app, is able to detect currency. So once it's a mobile app, so it just launches the app on the phone, and any currency that you have, so the app just, the mobile device just needs to sense the currency and is able to tell you, oh, this is 50 naira, this is 100 naira, this is $1, so I was really impressed, So that's how some of this meetup started, and then eventually the community radio station in the university approached me to see if I can run a tech event, on radio. They would like to have a tech event on radio every once in a while. So we agreed to have something done weekly. I agreed to do something weekly for them, and that was how the Tech Talk Wednesday with Kazim radio show, was born. And when I started the show as well, there were a number of challenges that I encountered. One of the challenge was poor connectivity. So I remembered, the first show, I had planned to stream live. Everything was set up, and only to get to the radio station, to get to the recording room now, and we figured, oh, there was poor connectivity, and even internet on my device too was not working at the radio station. I couldn't get the internet on my phone, my mobile phone to also work. It wasn't as good, as I would have wanted it. So eventually it turned out that, I couldn't stream, live, that day. So we just had to make do with just, the dissemination of the information on people, to people listening on the radio show. And, I'll get a copy of it and also share it, on YouTube. So bottom line shows that when we run community activities, there are a number of tools that we need to leverage. So I've just mentioned, some of the challenges that I face in trying to, get my radio show up to speed now. And eventually to later on down the show, I decided to start inviting people, other IT professionals to come on the show with me to discuss those different techie topics, those different weekly techie topics. And I also figured again that connectivity was an issue for those that could not be physical, with me at the radio station. So I had to, again, try different tools, different ways of getting them to connect so that they could as well share their knowledge with the listeners. So we, in the process, we tried Facebook, sometimes we just have to do it way ahead of time. We tried Zoom, Zoom didn't work, the way we wanted it to because of the connectivity still. So we needed something a little bit light. So sometimes we would try out Facebook Messenger, and yes, Facebook Messenger sometimes work. So I just need to communicate with the guests. Oh, we're going to be doing Facebook Messenger today. And, we use that for a while. Sometimes we might try, a WhatsApp call. So the person calls via WhatsApp to contribute on the radio show. So we did that also for a while. And then the lockdown, the COVID-19 pandemic, happened. And so this also forced the radio station now to lock up the radio station, because it's a small radio station, a community radio station. So they could not continue to operate as well. And it was difficult for them, doing some of those things from home. So I still wanted the radio show to continue nonetheless. So I still wanted to proceed with the radio show. So I had to also think through it, what tool can I use now? Because, when this show happened, I leave it to the radio station to help me do the production, and then I can share some of those contents on YouTube. But now that the radio station is no longer there, it means that I need to do all of these things myself. And, a tool that I came up with is, Microsoft Teams. So Microsoft Teams came to my rescue then. So I figured all of the things that I needed to do, I can get it done from within Microsoft Teams. Microsoft Teams is one of those suites with the Office 365 family of products. So I figured, so if I need to do the video production, I can do recording and I can do the video production. Sometimes, they are part of the videos that I need to cut away. So there are other tools like the Camtasia, recording is a very fantastic tool. So I use that also in between, but that was only for a trial period of time, and I noticed, wow, this tool is costing me so much. So I figured, I can actually get to use Teams for free, and it comes with things like Stream that allows me to trim those videos, to get them into what I want, download the videos, and then eventually, have those videos, uploaded onto YouTube. So this is how some of this tool has been able to help. And from using these different tools, from Zoom itself, to Facebook Messenger, to WhatsApp, and to the other tools. So I found that, the Microsoft Teams just get the job done, for me. And because I'm also a Microsoft, certified professional, so I have some background knowledge on how some of this tool works. I know, of course, for a fact that, it's an excellent tool, depending on what you want to do, everything before now used to be around email. Once we have our email, from within our email, we can get access to every other thing. We can communicate with people, we can look up people's contacts, and then be able to call them up if we need to call them. So everything is usually, in the workplace is usually designed around email. But, now what I've noticed with this Microsoft Teams is that it's been able to help me. So if I need to do some collaboration, I need to collaborate with some of these, my guests on the radio show, so I can collaborate with them seamlessly. I can set up live events, I can set up meetings, share my meetings ID, and a number of those things, with this tool. So I'm going to quickly wrap up with this Chinese proverb now, and maybe if there's a time, I can just, for those who would like to see what the interface looks like, I might just, show us what the interface of the teams that I'm talking about looks like, or I'll just show the Microsoft 365 interface generally. They say this popular Chinese proverb reads, may you live in interesting times. May you live in interesting times. So some people consider this to be a curse, while others consider it to be a blessing. But one thing is certain with regards to technology today. What is certain is that we are definitely living in interesting times. And now, for instance, that we're having to work from home. So a lot of people are having to leverage on so many tools, to get their job done from home. So I think I still have some time. So I will just, quickly show people what it looks like. So let me share this. All right, so I have a web browser here. So if I, portal.office.com is the URL, and you can log in with your account. And, so this is what the landing page looks like, and everything can easily be accessed from here. So if I'm talking about, some of these very nice tools, all of the tools that I need, to get my job done, so I can find all of them from here. And they are all not, Microsoft centric. Very, very good one is this Power Automate. One of what it can do, how about, if you get an email in your inbox and you want the email to automatically leave your inbox to your Google Drive, for instance. So you can make all of these things happen without even the need to code, so that's, why I found, this Microsoft 365 tool to be very, very useful. And I will also show quickly what the interface of this Teams that I'm talking about also looks like. All right, so this is also Teams. This is what it looks like. So each time you can see I have a channel for my Tech Talk Wednesday, so I can create a meeting invite from here. I can create live events also from here. We can share files. I can decide to bring in other tabs if the need be. And when I have a live event going on, I can simply easily have it recorded from here. download the recording, go to stream within still Office 365, and be able to trim it the way I want it and have it re-uploaded. So I think I can. All right, so I think I can wrap up now. So I will be available for any questions that you have. So if there are any questions that I can respond to.
Hey, Gazman, that was awesome. Thank you so much. I'm just checking the live stream. I need to move that window over to there to see my live stream. But if anybody does have any questions, I'm going to sort of seed things with a little question here. Kind of when things go wrong, and I'm not today, but kind of in the past, and you were saying like you couldn't stream, you couldn't get connection. What do you feel is important in terms of being able to manage your composure, being able to stay like cool and calm under that sort of pressure?
Yes, so that's a good question. So you need to, IT requires that we need to be able to work under pressure. So that's one of the good quality of IT people. So what we have to do is to try our best to keep things under control and then remain calm in the process. Just yesterday, the show yesterday, the guest that I have coming on the show could not make it yesterday, so we had to do a pre-recorded session, a day before. And so when I was trying to hear it yesterday, the audio quality was very poor as well. So I just had to apologize, to those listening and, tell them, oh, there's going to be a better version of it, and then I can share that with them on YouTube. So I think what I would advise is for the person to stay calm, so when you are calm, you're able to put things under control. So stay calm and then figure it out. And if you need to apologize later on, try to do it.
Exactly. And I want to add, I think everybody is with you when you're suffering. I think nobody ever wishes bad on anybody else. So just adding to a wonderful answer there from yourself. Thank you again so much. We really loved having you today, and we will look forward to maybe next time as well. But hey, who do I see in the room? I see a couple of people. I see Katie Reese. Hey, Katie.
Playing Travis Scott.
Hello, how are you? I think your Alexa just thought you wanted to listen to Travis Scott.
Google. I dig it, but I question its sanity.
Definitely understood. Nick, thank you for emceeing this morning. Kazim, thank you for your talk.
All right, thank you.
All right. It's been an absolute pleasure, and I will. I'll go disappear and leave these people in peace. Well, I'm not going to be leaving them in peace. I'm going to be watching along, but
I was going to say the opposite, that you've left some big shoes to fill MC-wise, but if you want to see,
I do have big shoes, but then I am 6'6". So if I didn't have big shoes, I would fall over. That's kind of like cantilever type thing.
Well, thank you both.
Thank you. Thank you.
Hello, Bakari. How are you?
Oh, yes. Hello, Katie. I'm doing good. Hello. Good morning.
Thank you for being here.
Well, yes. There's no problem. Indoor vibes. Corona is really quite everywhere lately.
Same.
Yeah.
Same here. Absolutely. Well, thanks for being here, and I'll let you get started with your talk, end-to-end testing on Terraform with TerraTest. I'm personally excited to learn about that. So thank you.
Okay.
I'll let you take it away.
Okay. Cool. Okay. Can you see the slides fine? Screen good?
Yes, looks great.
Okay, cool. So today the talk is just going to be on end-to-end testing with Terraform. Terraform is a tool from HashiCorp. You simply use it to spin up servers, or in this case, basically something called infrastructure. It's basically like a very big word for a personalized setup of your services. So at the moment, my name is Bakari Emmanuel. People call me Backman. It's kind of like a very small nick. I like to say I'm an express plumber because what I pretty much do is fix pipelines and other stuff. Sometimes I also break stuff. So kind of like falling over that kind of thing. Also a failure comedian in real life. I might go there, but I might not really make it. So just easing out on the dev work for now. And then you can always check out my website and follow me on Twitter. I post some interesting stuff. You might like it. So it's basically testing, right? Testing is pretty straightforward. Until you don't really do it, they're like, I can pretty much leave it out for now. No issues with testing. Then you write a couple tests one day because you really have to. It's not like you really need to. Some people just feel like at some point you have to just show that yeah, it works. Then you remove some because they don't work. Pretty much like I think we've all done this before. Where we set up a service, then we disable the test, push it to production. Then we were like, testing was actually pretty easy. Like 1 was equal to 1. We didn't really check anything. All the values were fine. You keep on writing more code, no tests, keeps working until one day it doesn't. So the thing about tests is that writing code, sometimes it works, then things change. Some services get pulled out. Some APIs change on AWS or GCP or Azure, they'll get deprecated. Some new features get added and interfere with stuff. Somebody pushes the spoil button on your server, different things like that. You never know who's doing what. Then it's no longer simple, right? You get to this point where that 1 is not equal to 1 because now that 1 is a string, and sadly, your infrastructure doesn't allow that. Infrastructure testing is pretty much like this. Things change a lot. And when they do change, you can't really set it up the way you just write like your normal code. Like you actually need to run everything live. You can't test code by mocking. You have to literally spin up your infrastructure to mock it in reality. So even if you were to find a way to hack it, you just do some light testing, it doesn't always work because you've got like multiple environments. And these multiple environments have different services working on there. Some have, some different configuration. And then, somebody might be deploying dev to prod. Somebody might be deploying staging on dev, different configurations, and you don't even know whether it's working or not. That's why testing is really important, right? The testing parameter pretty much goes from unit testing to integration testing to end-to-end testing. Although pretty much people don't test infrastructure. So, that's why I'm actually going to start off by, getting off with this. So HashiCorp has quite some tools. I'm pretty much just trimming them down to Terraform and Packer. So I'm going to be doing like a very short demo. I'll be spinning up the entire infrastructure with Terraform. So Terraform is they call it infrastructure as code. Simply, it just helps you not have to, go to the AWS console and start clicking on buttons to create the infrastructure. You pretty much write it the same way you write code. It has all the functions and different things that you actually use to spin everything up. So to actually then, do everything, I'm using AWS because, Terraform and Packer help you build things, but then you need to host it somewhere. So I'm using AWS and then Docker to run like some very small application that we can push on the VM that we'll be creating. Then with TerraTest, which runs on Go. So I pretty much gave the Go logo the HashiCorp insignia. It pretty much looks cool. I think it's leeching on it, so moving around. But the main idea is that all these tools pretty much form together and they work very, very nicely together. You could change AWS with GCP. You could change it with whichever cloud platform you like. TerraTest supports multiple clouds, supports multiple services, it supports even testing Docker, supports testing Packer. So every single tool that we have listed here can actually be tested using TerraTest. So what is TerraTest? Because I've been talking quite a lot about it. So it's basically a testing library. So similar to how you write infrastructure code, you need to actually run it to test. So TerraTest helps you spin everything up, check whether it's working, then it basically takes it down. It doesn't really do anything more than that. But the good part about TerraTest is that it's already been pre-configured with different modules that, the modules are basically like, okay, fine, if you want to test Terraform, there's a part of TerraTest that can handle Terraform code. There's a part of TerraTest that can handle Packer code. there's a part of TerraTest that can include Docker code and all of that kind of stuff. So you never really have to leave that environment. You can pretty much use the modules to test everything. And it makes sure that it works because you can also extend it too. So right now, I'm just going to showcase like a very, very small demo. The repo is actually here on github.com/tma/HashiTalks TerraTest. Should have made this link a lot shorter, but this might work. So I'm going to change over. I'm going to change over which screen I'm sharing so that to my IDE, then just basically showcase how TerraTest works. So whenever you're using TerraTest, you first of all need to write some Terraform code, which I'm going to show you guys. So in this case right now, I have a couple, they call them modules. So remember when I was saying you can test your modules. So modules are just like, it's basically like a folder with Terraform code inside. Like that's simply what a module is. The only difference is that now the variables that you actually pass into it, you can basically just have it stored in one place. So this is me using a module. This instance module is from here, from this main.tf. So main.tf is where we most times keep our resources and everything. But the main idea here is that because of the way I've written it, this is basically a module, right? This is going to deploy like an AWS instance. Pretty much basic stuff, you create it. For those of us who actually haven't used Terraform before, it's pretty much very straightforward. All that I'm doing is that this is basically the operating system I'm using. This is the instance type. All of this is found in here, like a variable. So you just put it in there and then, you can define it. So in this case, you can see that this is the instance type that I'm basically pushing on here. Is basically a 2 micro, like a very, very small VM, like 1 gigs of RAM, that kind of thing. So moving on, like this is all the code I will basically write. Like it doesn't really have to do anything. It just has to run in this same manner. And then from there, we can now check whether everything is good. So let me actually then run like a very quick demo. I'm actually going to do a demo with Packer. So this is basically Packer. Packer basically helps you test. Packer helps you test your build. So like say I have a custom image that I want to make on Terraform. Rather, I want to make so that I can run it in a VM, for example. You can use Packer to do that. So the main idea of this talk is that when you're basically doing it, you basically have Packer build an AMI, basically a very big word for like the operating system and all the files that should be inside. Then we basically use that to run a VM. Then we can now run our application in a container with Docker. Very, very straightforward. So normally when you're running with Packer, you can use Packer validate to just quickly test everything. Rather, the Packer, so Packer validate, then you basically pass it the name of the file. So I'm going to do Packer validate builder.json. So do Packer validate builder.json. That should actually be there. Packer. Yeah, so that should actually be good. Oh yeah, sorry, I'm actually in a test folder. So I'm going to cd into the modules folder where Packer is, then I can then run Packer validate builder.json. So now I can run Packer validate builder.json. And this works fine, right? This is like a small version of testing, right? You test whether it's valid, then from there you can now run the actual test that verifies that everything works fine. So to do that, I'm basically going to go to a test that I've written. This is where TerraTest comes in. So in this case right now, you notice that I have a couple stuff imported. For those who might be looking on, this is Go. It's what do you call it? It's very, very straightforward. I'm just importing TerraTest. I've downloaded the libraries before. To download it, you can check out the documentation on TerraTest. It's actually quite explanatory on where you can actually find this. So basically, I download the module for TerraTest. I'm using the modules from TerraTest. I'm using the one for AWS and one for Packer because since I'm building an AWS image, I'm going to push in it to Packer. So all I'll do right now is just to test this, right? Because yeah, like the validation went fine, but like, is it actually going to build? So in this case right now, I'm going to basically run this. It takes quite a while to run. So we're actually going to come back to this in a bit. But the main idea is that like this is going to run a couple tests. We can actually leave it to run for a bit. It's going to keep on like, what do you call it? Passing this, it's going to try to connect to AWS, and it's going to take those details. It's then going to run that, regarding like connecting to AWS. So let me actually move back to the slides. Then we'll come back to that once it's pretty much done. I'm basically then going to cover up on like how to make great tests with TerraTest. So this talk is actually take quite a while to run, because spinning up infrastructure takes quite a while to run. But then you can always find great ways to actually do things outside of that. So like the main idea behind writing tests is that most people basically avoid them, right? You don't need to test anything if there's no quality inside, and that's basically the truth. If you are scared to test your code, if you are scared to test your infrastructure code, or you are scared to actually run it, there's some infrastructure that they have glue tape on it, like there's that one service that's been running since like 1990s, and they've never touched it. They're like, if you press just that one button, it doesn't come on anymore. So then you go online, and then someone actually tries to actually change something, then everybody gets fired, and it doesn't work anymore. So that's the difference, right? So actually start testing, you need to actually break it down and start small in units. So if I actually go back to the main example that we had in the code in this case, right? You basically have to then see that what do you call it? Most of all these tests are like unit tests. Like now, this Packer one is a unit test. And as you currently see right now, you see that, wow, it actually failed. And the reason for this is because of what? No valid credentials. This was actually intentional. And this was just to showcase like how some things work. So you could actually have built it up, but the main idea is that you do not want to be testing infrastructure randomly that way. So what I'll do right now is to go back and unset it. So from there, you unset your AWS access keys. You unset everything. Then you actually now try it again. So in this case right now, when I actually then try to run it now with the correct credentials, and we see something different. Wait, let me switch over to the actual terminal. Yes, here. So right now we're going to run the tests using go tests -run that will specify the name of the test that we want to run. In this case, this test is called test Packer artifact. So we basically run test Packer artifact, and then we basically run this. So what this is going to do is that it's going to basically start off. It's going to pick up on the Packer template, and you notice that now it's pre-validating some stuff about the VPC. It's creating the Packer image, found the image, it's creating the temporary key pair. And then all of this is basically us just trying to build it. So this is basically Packer doing its work. The main idea behind it is that once Packer runs, TerraTest then checks whether the output is the same as what we're looking to see. And how do we verify that? So in this case right now, I've already written here that whenever I finish building an image, right, this is the builder.json file. This is this file that we opened up a while ago, which is right here. So this is the builder. Let me actually switch. So this is the builder.json file, the one that we have. And this is our tests. And this is our test, Packer Builder. So what we're basically doing is that we want to be able to run this and also then have it here. So we basically pass this into Packer. This Packer object is from here. We basically got it from the TerraTest module that runs Packer. Then we then use this to then, what do you call it? We then run this. We then run this template using the build artifact function. We check whether it matches some string called AMI, because in this case right now, when you actually build it, you're going to get something called AMI dash a random string. So we check whether that's actually true. And if it is, then we actually say, okay, fine, yes, that's actually correct. In some cases, you could extend the test to actually go further into doing things like, okay, fine, let's actually see maybe, what do you call it? The AMI is in this particular region. Let's actually see whether, what do you call it? This AMI, like if I were to actually create an instance with it and exec and then check whether it's running, whether it actually goes. We could actually always do that and verify that all of that works exactly the same way. So now if I were to switch over to our demo, because what do you call it? If I switch over to our demo to showcase the tests, then what you'd notice is that right now we've created, like you see the AMI, right? It's basically like AMI dash some random string, right? And this is basically the value that we're actually going to be using to test. But the good part about TerraTest is that after it builds everything up, it then destroys it. That's where that line that was actually doing the defer, that's where it actually comes in. Let me change to the slides back again and showcase what that's like. So like in the previous example, like we're just testing only Packer, right? There were other tests for things like Docker. There were other tests for things like the AWS instance, all those other things. The main idea is that when you're actually testing, your modules should be your starting point. So the reason why I created everything in modules is because modules are easier to test. Like the same way you have like, what do you call it, variables, functions, those ones are like first-class citizens when you're writing code. Resources are like that, right? So they are the ones that actually do everything, yes? So you can't really test them if you keep duplicating them multiple times, because it becomes harder to be able to find out, if I change this guy, do I need to change that guy? And then your test begins to fail because there's actually no consistency with the way you're actually writing Terraform code to start with. Again, there's no substitute for writing bad infrastructure code. So it's always best to start writing your Terraform code as modules. Then after you write it as modules, then you can then start testing, because it's only then that you actually then have the proper structure to keep testing. And then, if you choose to write a 200-line script, then you might just actually have to write shitty unit tests too. And unit tests should cover like small parts of your infrastructure. Like you shouldn't be covering everything. You shouldn't have to, what do you call it, take up the entire bulk of everything. Like you can run your unit tests, you can run your integration tests, you can then run your end-to-end tests. Your end-to-end tests are the ones that would run. That one is actually in another folder, but that one takes a lot of time to run. So if you run your unit test first, then you have a much, much easier time writing your end-to-end test, because if every single stage that can run independently builds successfully, then putting them together, they should work properly. Any issues that you then have after that, those ones become a lot more minimal, rather than having to deal with 5. If one fails together, then you just fix that one. You should also randomize configurations when testing, because you don't want to hard code things. You don't want to have like your production environment variables always staying somewhere and then you go test staging and it doesn't work. So you should always make sure that you change those variables. Make sure that they're not static, ensure that you always have configurations that you can basically specify as you move along different environments. Also, make sure to always separate environments. You can't run your staging on prod. You can't run your test on staging. It's basically like moving around, driving a driverless car. You never really know whether you're in control or whether the car is actually taking you on the ride. The same thing with the environment, right? There are various times when you'll be running in the staging environment and you might actually overwrite something that is running. So it's always best that when you're writing your tests, even if they're end-to-end tests, because that one has to spin up every single part of your infrastructure, that you take it out, then you run it on a different environment. So And also, there's also a part called state locking. So state locking is a thing where like you move your state and you store it somewhere else. Like, so if you run a Terraform plan, it's going to output like some JSON that tells you like what your current setup is like. You should actually take that out and not have it in there. Else you might, be reusing configurations like, that prod example. And if you're lucky, you might go from unemployed to customer, cover all these things. It's always good to test. And the last part that I would say is that you should actually drag most of your application and third-party integration tests to your infrastructure test, because there are various things that require you to actually set it up. So you should always have these things running beforehand. It's not just enough to set up your entire infrastructure, you also set up your applications too, and make sure that as you test them, as you go along that testing pyramid cycle, once you get to the integration or end-to-end test stage, you actually then bring in all these things to make sure that, okay, fine, the way you are configuring your infrastructure is actually the proper way to set it up, those kind of things. And to just kind of round up, they don't really, tests don't really catch all your errors, but they kind of make most of the bugs go away. So the more you actually keep testing, then the less errors you might actually encounter while actually running your environments. And just to finalize, since there's still some time left, we can actually go back to where we have our code running. Yes. And then we would actually go down and we'll see that, yeah, so the test passed fine. Like we had everything running. We basically ran the Terra test part, and then we got, all the environments good. So I'm actually going to showcase another one where we're actually now testing with Docker. Let me switch over to the IDE so that I can show that. So in this case right now, we have this IDE and what do you call it? We need to reset a couple things. So I'm going to come here and I'm going to create a new one. I'm going to set a couple environment variables, the things that we actually need to run it. So basically like a profile of like, this is just my account on AWS. And then I'll basically just set so I'll set the environment and pretty much that's about it. I don't need to set anything more to run this. And then when I'm actually here, so I have this test also for Docker, which is something most people don't really test, right? So the main idea for this is when you're actually testing, you should test from the units, right? The individual parts that actually make your application work. So in this case right now, I'm testing Docker because I have this main.go application. Very, very simple. It just returns hello world spelled backwards because, why not? Say you have the hello in your application. It's pretty weird, but it's kind of good. So right now, like the same way that we do the unit test, we then come on here and then we can actually then run this and just see whether this actually goes. So if we want to go run tests, then we actually go test run. And then we actually then see this go through. So what this does is it basically just checks whether like our build can run fine and whether, we can actually access a port on the application as running. So I check whether the return code is 200. And then I check whether, the response is the same. So right now, if I run this, right, you see that at the moment, oh, this is actually running for Packer. So I actually want to run this for Docker. So I'm going to copy this again, and I'm going to change it here. And what this is going to do is that it's basically just going to start off, it's going to build the image, then it's going to test it. So what this did was it just checked whether it's just set, some build flags, set some, other things like environment variables for like the ports. And then it basically just checks whether like, okay, fine, can we actually access this application and do we actually get the same response as what we actually have here? So this enables you to like keep on, testing your applications until when you can get to an end-to-end test stage where you now put it all together. It's Packer with the Terraform code, and then you actually then check whether like, you can access the same application. And at the moment, you just see that after you do all of this, you pretty much have your end-to-end testing framework up there. So to just quickly finalize, I'm just going to run through this and say, once you've actually had a great time updating your tests, you can pretty much continue doing that. Thank you.
Thank you. I will say you definitely have very creative slides.
Oh, thank you.
I very much enjoyed your slides. Great talk. Thank you.
Yes, you're welcome.
So it looks like we have our next speaker joining us. I see him in the panelists. Awesome. Hello.
Hi, Katie.
How are you today?
I'm doing great.
Good.
Thank you.
I'm glad to hear. Thank you for being here. And may I ask where you are streaming in from?
So I'm streaming in from Lagos, Nigeria.
Are you part of our hug there?
Yeah, sure.
Nice. Awesome. Okay, so I will let you get started. Well, actually, we have one more minute, but that should be fine. Love to see that you use the slide templates as well.
Yeah, absolutely.
Awesome. So in our speaker confirmation, you mentioned that you are a hobbyist photographer outside of your, I think that's awesome. That's very
absolutely. Cool. It's just something I picked on the side. There's a lot of beautiful things out there that I just want to capture, you know. It's pretty much fun.
Definitely capture and share, I'm sure.
Definitely.
Okay, well, without delay, I'll let you get going.
All right. So, hello everyone. I'm Itunu Lulua, and I do DevOps, and I work also on the back end. I was previously with Andela, and right now I kind of work freelance. So I'm going to be talking today about Terraform infrastructure and using that to build blue-green deployments in AWS. I guess a lot of you out there would have wondered of different ways, or would have definitely come across this at some point in time. So what I'm going to be running you through today is the importance behind infrastructure as code, just a brief snippet on that, the importance of blue-green deployments and how you can do that using Terraform. So we go to the next thing, which is the 3 big whys. So you'd be wondering, why do you have to automate? And why do you have to automate using Terraform? There's tons of other tools out there. We have CloudFormation, we have Azure ARM templates. We have Google also has what they use to automate. So there's tons of tools out there, but why use Terraform? And then we'll also talk about why blue-green deployments, right? So during the course of this, I'm going to run you through this basic things, and then we're going to have a little demo setting up a very simple to-do app using Terraform and implementing. We're going to push a change to it that is going to definitely show in the production. All of that will be implemented with Terraform using blue-green deployments. So why automate? The reason why you automate is simple. It's just these 3, right? There's more, but let's focus on these 3. You want rapid delivery, recovery, right? For companies these days, with the pace at which tech is moving, you really want to move as fast as possible. And you can't just do that if you do things manually, because mistakes are going to come up and you wouldn't be able to recover as fast as possible. So you want rapid recovery and delivery, you need to automate. Secondly, we'll talk about predictability, consistency, and repeatable builds. That's another very key thing. You don't want a case whereby today you deploy an update and you try to deploy the same update the next day following maybe spreadsheets or whatever it is that was used back in the days, and you end up having some sort of errors that you just didn't anticipate. As software developers, we're all familiar with the whole concept of, but it worked on my system. What's going on here? You know, that's basically what causes it. There's some sort of difference between where you're coming from and where you're taking this. So when you automate, it helps you solve all of that because you would have handled all those issues in your code, in your infrastructure as code. And then basically all of this boils down to greater productivity. You can get your automated code and just run it. It comes up with your stuff within minutes, as against you having to do this thing stepwise. You end up spending hours of you not even being sure you're going to get it right. So that's the reason why you automate. Now we come down to Terraform. Why do you have to use Terraform against the other guys? In Terraform, you have one configuration and it gives you services across multiple cloud providers. If you go over to the Terraform website, you're going to see that they offer services across the major cloud providers and even little ones. It's pretty much whatever cloud provider you're looking for would definitely be there for you to use with Terraform. And then there's a very strong community base with Terraform. You can always find somebody to answer questions and help you with debugging. And a simple Googling could help you with a lot of problems that you're going to come across. Then talking about hybrid infrastructure, if you're going to be working with some of the other cloud infrastructure as code services, you may run into situations whereby you cannot create hybrid solutions. Speaking about maybe ARM templates being for Azure and CloudFormation being for AWS, you may run into a situation whereby if you want to integrate different cloud services, you may not be able to do that with any of those guys. But with Terraform, you can easily just put in those and it flies for you. So that's that. Talking about blue-green deployments, really, a few people may be wondering why blue-green deployments. Why can't I just go with rolling deployments? Why can't I just go with kill the server, restart it? Well, best practices, right? So one of the things that blue-green deployment gives you is an ease of recovery, right? So you can basically spin up your updates and keep them, right? And keep your existing deployment while your update is getting live and you're testing it to see if it's functioning the way you want it to. If it doesn't, you can easily just revert to what you had previously at the split of a second without your users even noticing anything, apart from, say, UI changes. So secondly, buttressing the point I made earlier, zero downtime. It's pretty amazing when you just refresh your page and you see fresh updates. It's pretty amazing for anyone, I guess. You're working on your Google page and you just refresh and all of a sudden the page has been modified. It's pretty like more than you having to say get an email that, hey, we're gonna be down for 3 hours because we're trying to make an update. So zero downtime, blue-green deployments give you that. Now we'll talk about eliminating configuration drift. Now, the beauty of blue-green deployments is that it works with immutable infrastructure. So this is what I mean. It basically takes your whole existing environment and trashes it and gets you a totally brand new environment. So in this way, you don't go in there trying to modify configurations. You're basically actually coming up with it as fresh. And this is beautiful because your configuration is always true to your single source of truth, which is your infrastructure as code as defined in your version control system. So that gives you just that, and it's pretty awesome. Now, talking about canary compatibility, like I mentioned earlier on the first point of ease in recovery, you are able to deploy changes and actually see them work in action for some of your users before you gradually move everybody in there. The point this does for you is that it helps you to minimize the surface area for failure. So assuming, for example, that you make a deployment, a fresh one, and you send it out there to your users and it actually has a problem. Now you could have easily made a deployment in which you start from, say, 5%. So you make your new deployment and you serve it to just 5% of your user base. It works fine with the 5%, you can increase it to 10 and gradually keep increasing it until you get cover the 100 and you can discard of the previous environment. The beauty there is if you run into any errors or challenges, you can easily just kill the new environment and let the old environment continue to run and to serve everybody. Meanwhile, you would have also limited the number of people who are to encounter errors in your deployment. So those are very key points, and I'm pretty sure you all would have run into situations that would have had you thinking of these things. So those are what I have to offer. We'll do a quick demo with this. I came up with a little small approach to automate this whole process, and that will be using Terraform, all right? So this, for example, is a classic DNS implementation of blue-green deployments. It's pretty visual. What I did isn't this complicated, but this kind of just describes everything. So you have a Route 53 endpoint here. You have an environment that's currently live with your load balancer and your instances behind it, right? And your database isolated somewhere. And then you have an update, and then you spin up the update, which is going to be this, the green guy on your left-hand side. Apologies for that. The green guy on your left-hand side. And then once you're done, you can easily just take the pointing of the Route 53 and shift it to your green, all right? It becomes live, all right? And then take the database, point your green to the master, while the blue still stays idle. And when your green has worked just fine, you can easily trash the blue. And the cycle continues for another deployment. So that's basically what blue-green deployments is. So now let's run into the demo, all right? You can go over to the links below in the slide. You'd find the repositories for the demo. So what I did was to build a web server configuration, infrastructure as code, to handle the uniqueness of the code I'm working on here. And then I have a generic HashiCorp Terraform, which handles the whole process of deploying it blue-green. And there's a couple of scripts in there that help us handle that smoothly. So I'll run down to that right now. So, okay, so I have a few scripts here. If you go over here, that's we have the scripts which are decommission the blue, decommission the old project, and we have a launch green and upgrade green to prod, right? So we're going to start with launching a brand new green environment, all right? So that's going to be just a moment, scripts, and then we'll launch a green environment. So this is what Terraform gives to you. Pretty swift. It's just going to come up with the environment without you having to do anything in there manually. So if you have any questions, please feel free to put them up in the chat. I'll respond as soon as we're done. So what is happening over here right now is the server is coming up. It's loading up all the data and deploying a green version of the server. So this will take a few more seconds and it will be up. All right. Just give me a second. Okay, apparently I didn't get the environment ready before running this, so forgive me for that. I'm just gonna do that quickly, all right?
I'm sorry to interrupt you,
Yeah,
but
sure.
I think you need to switch your screen.
Okay.
Sorry, I hope I didn't mess up your flow, but I figured you'd rather know.
Oh, I didn't realize. Please, what is showing right now?
So right now I see the holding slide for the demo and then the GitHub links.
Oh, that's, I didn't realize that, all right?
Okay.
So just a second, please. Let's do this. Okay, so yeah. All right, so I forgot to set up the environment for this before I run it. So that's what I'm doing. I'm just clearing out what already exists in there to get it ready for the fresh run. This will take a second or a bit of a minute. Okay, so I am with this, we are ready for the deployment. So that would be so we're launching a new green environment here. And I've set up what they call it. I've set up DNS resolution also. All of that is defined within my Terraform configuration. You can actually just go over to the links of the repo and you'd be able to see every bit of what is done in there. It's pretty self-intuitive if you have some knowledge of Terraform. So you'd be able to understand what is going on in there. So at this point, the server has been created. It's connecting to it via SSH to set up my configuration as defined in the code also. All right, so we have a successful deployment and our green environment is ready. So we would be able to check that here. This is the output, and that would be the link to the load balancer. So I'm going to open this up. It may take a moment to load up because the load balancer would have to come live before we can access it. Okay, so this is it. Of course, it's still trying to come live. This will take a moment. And just so we don't lose time, I'm going to promote this to, this isn't what is going to happen in an ideal situation, which is going to be live, because you wouldn't want to put something to your DNS which isn't yet live. But just to save us some time while the load balancer is resolving in the background, I'm going to run the script that is going to put this up to attach this to our DNS name so we can have it available at that. All right, so I'm just going to run that already. Just a moment. So over here, what that would be scripts. All right, so it would take that and attach it to that DNS name and would have it available at the DNS address I showed you earlier. Okay, so I just checked it out, and the green site is live. Of course, the DNS isn't ready yet. Oh, okay, apparently it's ready. So I'll take you there now so you can see that. Just a moment. Where's this guy? So if we come over here, you'd see this here. All right, so this is a simple to-do list. I guess DNS is still trying to come to life here. So that's, you know, the time to live thingy. But meanwhile, we can access it on the load balancer. It has resolved over here. So what we have here is simply a to-do list, a very simple version of it. And of course, it has some bugs. So you see over here, you can add an empty list, which is not accurate. You can just type in anything you want in there, you add it. It's pretty interesting. A friend of mine built this and I decided to use it up. So this is what we have in version 1. So what we are going to be deploying in version 2 is going to be a new one that is going to have a new clean blue background. And it's also going to have delete and completed check marks here. Yeah, and you wouldn't be able to, of course, add blank spaces this way. All right, let's see if this guy has resolved. Time to live is still coming up, so we'll wait for that for a bit. It's not exactly in my hands. So while that is going on over there, we can come over here and deploy a fresh green environment. Now, here's the idea. The current environment that is running is our blue environment now that it is running and it's live. So we're going to deploy an update, all right? So I'll come over here. I already have a pull request ready for this so that we don't cause any delays. Right. Can you please let me know if you see this? Can someone just put that? Okay, awesome. So just a moment, still with you. Okay, do you see a pull request, please?
Yes.
Okay, awesome. Glad to know that. Okay, so this pull request basically puts in all those configurations that we have. So what we're gonna do is to merge this into master, and then we create a green environment, which is gonna have all of this. All right, so what we just do is merge this pull request. All right, so we have that merged in. So we can go in now and create a green environment that is going to go in there and replace the current version of this program, which we have live. All right, let's check if the DNS has resolved already. What's up with this guy? Okay, this is taking a while to resolve. I didn't expect it to take this long, but it's still taking a while. All right. But anyways, this is it from coming straight directly from the load balancer. Okay, so we have that. All right, I wouldn't hold up on this. So I'm just gonna go back and create a new green environment. All right, so I'll go over here. We're going to deploy another green environment. All right, so that's going to be just a moment. I keep forgetting the name of the script. Okay. On screen. This time we're not going to use the true tag because, oh, screen sharing is paused. Oh, sorry guys, please. Sorry about that.
Right now I see, oh, now I see your terminal.
Yeah, sorry about that, guys. Okay. All right, so I'm going to do this now. We're launching a new share. Oh, sorry, we're launching a new deployment, a new green environment with the updates. Okay, so our green environment is live now, all right? And we have our changes in there. We're just gonna need to have to wait for a second for this to resolve with the load balancer, so we can then get it to connect to our DNS, which unfortunately has refused to resolve. I'm still checking it over here and it's taking forever. Unfortunately, there's no way I could possibly hasten it because it's an alias setting. It's an alias setting in Route 53, and unfortunately, you can't control time to life for alias settings in Route 53. So there's pretty much nothing I can do about this than to just wait and keep trying it. All right. So we have this. Let's see what comes up here. Okay, this is still resolving at the load balancer level. Once it's up, I'll let you know. It takes something close to 3 minutes to resolve with the load balancer that it's live because of the health checks. So I'm still very much with you all. I'm just going to share this quickly with you since the DNS is refusing to resolve, just so you have a little bit of insight into what's going on with the DNS. All right. So just take a look at this for a moment. All right, I guess you see this. Some DNS entries here. You see over here, this is it. This is the alias pointing here to the load balancer. All right, that is it. And if you look over here, this first guy is that load balancer. You see that that's Terraform example ELBA as it matches example ELBA over here. It's just not resolving for whatever reason. All right, let's try that one more time. Still not resolving. All right, so I'm just gonna go past that, all right, and get the other green version to live. So this is our green version. I guess this should have resolved by now, and it's live actually. So let me show you this, just 1 second. So that's it, that's this version, all right? You see that? So it comes with a blue background. And well, if you try to add that, you get an error. You can put in something new and add that and add that. We have all of that. And of course, you can tick this as done. You can delete and all of that. So this is a new update. And it's unfortunate this refused to resolve. So what you would have seen is that this would have the previous, what do you call it? This would have the previous version. This current page where I'm on would have the previous version of the code, right? And then when I run the script I'm about to run right now, it's going to, by one refresh, change to this. Right now we have this. This is the previous one in the load balancer. Sorry, this is not it. Just one moment. It's this guy. Still with you.
While we're giving it a moment, we do have a question in the YouTube chat. If you'd like to take it, I can read it to you.
Yeah, please do.
Ebenezer is wondering why, instead of redeploying the whole infrastructure, why don't you just deploy your code into a new auto-scaling group?
Okay, all right. So that is also a very good possibility. All right, you can deploy it into a new auto-scaling group. But interestingly, what you should know is a new auto-scaling group is basically still going to redeploy the particular instance or container that actually holds the particular code, right? That is running the program, right? So it's just not deploying your network and your load balancers and all. So yeah, there's actually nothing wrong with that. And that is probably a lot smoother way of doing it. But you know, this is just a very simple demo. So we can't be going into fine graining and all of that. So that's the reason. So yes, you're pretty much accurate, Ebenezer. That's a good way of doing it also, because that still stays immutable. It gets rid of the old server and just brings in a new one. So it's still smooth, yeah. Okay, so I'm running out of time here. I can't wait for this guy anymore. So I'm just gonna, wait. I'm just going to upgrade this to, what they call it? To the no one. All right, so that's upgrade. That's the prod. Sorry guys, this was totally beyond my hands. There was nothing I could do about this.
I think you said it well when you said, for whatever reason, it's not working.
Yeah, it just has a mind of its own. All right, so what I'm doing here is to replace, right? So the replacement that happens, I'm swapping out the environment that's tied to the DNS. It's not yet live, so you probably wouldn't see any difference, but that's just what is going on here.
Thank you.
Okay, so that is done. Of course, you can't see that. So anyways, I'm out of time. And I wouldn't be able to take any questions because of time also. It's all right. If you have any questions, you can always reach out to me on Twitter, or we can keep the conversation going, really. It's been a pleasure having this talk with you guys. And hopefully some other time we're gonna have it a lot better. Thanks, guys.
I think you did very well. And I do encourage you to go to the YouTube live stream right now, in case people do have questions that they want to ask you. Like Ebenezer is also responding to us as well.
Okay, absolutely. I'll be there with you guys. All right. Cheers, everyone.
Thank you for joining us. I'll talk to you soon.
Thank you.
Our next talk is pre-recorded, so give me a moment to get it pulled up and I'll share my screen and we can get going. Our next talk is from Cobus Bernard, who is an AWS developer advocate for Sub-Saharan Africa. And he's actually one of the first people I got connected to when I was doing outreach for this program. And he's been really helpful along the way and helping me promote this, and was one of our first CFP submissions. So thank you. And I do think he mentioned that he would be in the YouTube live comments today. So if you have any questions, I encourage you to ask. And let me share my screen. Okay, and share computer sound. Okay.
Hi everyone, and welcome to my talk here today at HashiTalks Africa. I'm going to be taking you through how to go multi-account with AWS, and I'll show you how you can split out your dev, testing, UAT, and production environments into separate AWS accounts. Then we'll go through how to make it easy for your users to switch between the different accounts, and then also show you how to provision resources between all of these different accounts without too much config. So let's get started quickly. Okay, so a quick intro. So my name is Kobus Bernard, and I'm the Senior Developer Advocate for AWS for Sub-Saharan Africa. Before joining AWS, I was a developer for about 15 years, and of those 15, 8 was spent being an actual AWS customer. And I've been working with Terraform since version 0.6. And in case you're wondering, yes, that is my roof that you can see over there. For today, we're going to take a look at the following points. We're first going to go over why you would want to use multiple accounts. Then I'm going to show you how you want to split your resources between these different accounts. And then I'm going to show you how we do account switching as well as role switching. So on the one hand, I'll show you how you do that in the AWS console to jump between the different AWS accounts. And then I'll show you how to do that with Terraform to be able to create your infrastructure between all of these different accounts. So today's session is going to be primarily demo driven. I've got a few slides to start us off with, but then we're going to jump straight into the code. This is a pre-recorded session, so please ask me questions as we go along. I will be available to answer the questions in Zoom in the chat interface. This next slide is normally reserved for when we do talks about AWS's infrastructure, and the only reason I have it here today is to just let you know that we've actually opened up the Cape Town region last week. So if you have any workloads that you want to run in Cape Town, it's now available and you can go play with it. So let's get started with why you would want to use multiple accounts. So let's say you've got a scenario where you've got a single AWS account and you want to run different environments. Let's say your dev account, your testing account, your UAT account, as well as your production account. Each of these have got different types of resources. For example, let's say S3 buckets. So you can see them on the screen over there. Now what will happen is, let's say you want to give your devs some access. You would go ahead and create a policy to allow them access to, for example, the dev bucket. They get full access because this is the dev environment and they need to be able to add files, delete files, and do whatever they want to that bucket to be able to develop the software. Then when they start moving over to the testing environment, they likely need the same type of access because they need to provide it with all the files needed to run tests properly and make sure that everything is working the way it's supposed to. Then when we start hitting the UAT environment, you can see that we're now starting to lock things down a bit. We only want to give them the ability to read objects and see what files are inside those buckets. They can't edit them anymore because otherwise they might break the user acceptance testing because the devs should be fiddling on that UAT environment. And then lastly, when we look at production, we definitely don't want our developers to be accessing user data in production. So what we can see over here is that we have got 4 different policies that we now have to apply to a single user account, or let's say the group that they are part of. And this becomes complex because now this is just for one resource that we're doing it. If you look at all 4 individual policies that we have to set up now. So this will become very complicated in the long run if you have to do this for every single resource that you're splitting up times, let's say, 4 inside a single account. So the alternative is, instead of doing this, is what you can do is you start getting rid of the single AWS account and you spin up additional accounts. So you spin up one account per environment that you want to deploy to. And then instead of having all of these resources in a single account, you'll have your single policy per account, and the resource lives inside that same account. So you'll do that for your test, dev, UAT, as well as production account. And you can even, in this case, remove the policy that lives inside the production account. The reason is that with IAM policies, unless you explicitly give someone access to specific resources, the default action is deny. So by not giving the developers any kind of policy inside the production account, it means that they can't do anything inside that account. So you may not need a copy of certain resources in every single one of these accounts. And for that, you would create a AWS main account or master account. Now for this, you would put resources like, for example, your build jobs where you compile your code into this one account, because you don't want to have a build in each of these individual accounts, because you shouldn't be rebuilding the code for every stage of your development cycle that you're busy building. You can also have your pipelines that you use to deploy your code with, or for example, if you're building golden images for your instances to boot from, you can build them and you should build them in this main account. Or you can, for example, store your containers here. What you'll see is a theme of things that are not copied into each environment live inside this main account, including, for example, your domains that you register and then configure the DNS for. So now what we're going to do is we're going to jump over into the actual demo, where I'm going to show you where we spin up a VPC and as well as S3 buckets inside different accounts, and then also how to set up the user permissions to make it easy for them to navigate between the different accounts, as well as what does account and role switching look like inside AWS. Okay, so what you can see now is that I've logged into my AWS account on the console, and I'm currently looking at the VPC view for this specific account. Now, what account switching is that when you look up here in this drop down, you can actually see that we're currently in this specific account, but then you can completely switch out to another Amazon account or AWS account by just using role switching. And how that works is you would click on the switch role button down there. It's going to ask you for an account ID, which I'll punch in there. Then it's going to ask you for the role you want to take over. So I'm going to use administrator that I've pre-configured. And then also you need to give it some kind of display name. So let's call it HashiTalks, but not dev. This is the prod environment. And then you can choose the color that you want. My recommendation here is to keep production red, because normally when you see red, you go like, okay, wait, let's see what's going on here, danger. And things, for example, your dev environment can be green or whatever color scheme makes sense to you. Now we're going to hit the switch role button. So now what you can see is that at the top right here, it's got that name and color that I used, and I'm actually now in a completely different AWS account. And what you can see over here is that there are different VPCs. There's only the default one here that we have. And if you want to go back, for example, to the main account that we had, you just click on that back to whatever your username is account over there. And then you'll hop back into the main account. And that, once you've set this up correctly, is how easy it is to jump between these different environments. And remember, when you do have an AWS account per environment that you're dealing with, there's no overlap between the two or no connection between the two. So in other words, the one environment can't affect the other environment. So it's a very good way to actually keep production safe and also make sure that somebody doesn't accidentally make a mistake in production by not giving them access there. So now we're going to head over to Cloud9, which is an IDE built inside the console. But for our purposes, it's basically just a text editor for now, and it has got a terminal view over here where I have installed Terraform for us. So the two folders that we have over here, let me just quickly make them small, is that I've got an environments folder which contains all the infrastructure for our different AWS accounts for the environments where we want to deploy our code. Then I've got the folder for the main environment, and this is where we will spin up, for example, our build jobs, our pipelines, etc. So let's first take a look at this main one and see what this folder structure looks like. So what you can see is that I've got a bunch of Terraform files down here, and then I've got a Terraform variables file over here. So this naming convention will make a little bit more sense when we get in the environments one, but it's just to keep things the same, so don't confuse you in terms of what happens. So the first thing we want to take a look at is the make file over here. So this is just a convenience wrapper for some of the commands we want to execute when we interact with our AWS account using Terraform. And what you can see, there's a little bit at the top to figure out if you're using OS X or if you're using Linux. And then what we do is we pin the version of Terraform that we deal with, and by doing a MD5 sum on the actual binary to make sure that we've got the right version. The reason for this is that when you do use different versions, and especially if you go back a version, you might have some issues and you'll get errors when you try and run Terraform. Or if someone accidentally has got a more recent version of Terraform on their system, you want to prevent them from accidentally upgrading the state file to that latest version, because that's what happens when you execute Terraform plan and apply with a newer version. So what I've got in here other than that is just quickly a default that echoes out what the options are, and this is just a check to make sure that you've got the right version of Terraform. So what the plan step does is that it will run the normal Terraform plan, but before then it actually runs the Terraform format command. The reason is that you want the files to actually be formatted nicely, so I always prefer running that. Then what we do is we go pull the required modules, because you might have some new ones that you need to. And then what we do is we actually switch to the environment that we want to use using the built-in functionality of Terraform called workspaces. So I've gone ahead and firstly initialize this Terraform repo, and then I've created a workspace per environment that we are dealing with. So there are 4 at the moment: dev, test, UAT, and prod for our different environments. And then what we can see over here is we execute the Terraform plan command using a variable file, and we actually point to that specific variable file in that folder. And you can see over here what I'm doing is I'm actually extracting an environment variable to decide what the file name is going to be. And then also I output that to a plan file. The reason here is that we want to explicitly create the plan file, review that plan file at some point, and then also ultimately execute that plan file. We don't want to go straight to apply, where we just see what is going to be applied and we say yes and go, because that doesn't work well for your CI/CD pipelines. So just quickly, sorry, a correction is that the workspace in this case, because this is the main repo that or folder that we're dealing with, there will only be one workspace, and that'll be the one for the main. But this is the same make file that we use inside our other project. So it's worthwhile knowing about that workspace switching. Okay, so the first Terraform file we probably want to take a look at is the provider. So there's nothing too special here other than the fact that I'm using the specifically shared credential file because I don't want to mix in my other profiles for this demo. Other than that, I'm using the default profile, version 2 of the provider, and also I'm just passing in the AWS region that I want to create these resources in as a variable in here. Then in terms of the variables that we set up, I've got an AWS account ID, a region, a list of account IDs, or rather a map of account IDs, the CIDR, and all these values. But let me show you the actual values for these and they'll make a little bit more sense. So here inside the main variable file, what we can see is that I've set the AWS account ID and I've set the region. Then I've given my VPC a CIDR range and I've set the availability zones that I want to deploy in, all three of them, as well as the private and public subnet ranges over here. Then I've also got a list of account IDs. And we're going to dig into exactly how this works a little bit later when we get to the section here with the IAM users. So the VPC itself is just making use of a public module. You can see the URL up there from where I grabbed it. And we're just giving it a name HashiTalks Africa and creating it with those variables. I'm also creating it without any NAT gateways because I want this to be able to execute quickly. And NAT gateways do have a little bit of time spinning up and it'll slow down our demo today. So what we're going to be doing is we will be creating two users. There's a Bob user and then there's a Quibus user, and both of them are part of the developer group. And if we go up here into groups, what we can see is that there's just a group called developers, and I am attaching some policies to it. And this is where the fun starts. So how the account role switching works and assuming roles inside other accounts is that you have two components to it. The first one is in the account where you want to take these actions and actually switch to or assume a role into. You have to create an IAM role, and that IAM role actually has to extend trust to a different AWS account. That means that what you say is that this role, which has got a specific IAM policy or set of policies attached to it, I'm now allowing another account to assume the specific role inside my account. Then on the actual account that you're giving this permission to, that means that the root user is able to assume roles or switch into your account, but no one else is. Then you have to explicitly also have a policy with users to allow them to actually assume that role or to switch into that account. So specifically how that looks is like this. Well, before we actually look at what it looks like on the console, I should probably go ahead and create the resources. So let's quickly head into the main directly to create the main accounts resources. Now this is where it starts differing from using Terraform just on its own. So all that I do is I say, env is equal to main, and then I go make, and I say plan, because this is the main environment that we're dealing with, and because we've got that make file, I'm actually making use of make, which is a build type system that's commonly available on most Linux operating systems. So it's running those steps that I showed you inside the make file, and it's going to go through a whole bunch of resources that it wants to create, 32 in total. I'm not going to be taking a look at the detail of these specific resources in this demo. The reason is that I will make this repo available to you afterwards, and I'll coordinate with the organizers to send a link to it for you. But let's go ahead and apply that now. So we're making use of that plan output file that we had, and we're now quickly creating our VPC, we are creating our users, and we're creating the group and all that. So let's head over to the console and see what we created. Cool, let me refresh over here. So I'm now inside the IAM portion of the console, and we can see that there is a group called developers. And if I go into it, I can see that the user Bob and Quibus are both part of this group. And if I look at the permissions for this group, and this is where the interesting part comes in, I've got 4 individual policies in here. And I can look at one of those specific policies. Let's look at this one. And what this does is it says, well, you're allowed to assume the role developers inside this account that starts with 714. So this is one half of that equation that I told you about. So I'm now allowing this user to switch into that account, or if they are using API keys to access with AWS via the CLI or any other of the AWS APIs, they can assume the role developers inside that other account. So now the next question is, what does that other developer's role look like? Well, let's take a look quickly in our Terraform configuration for that. So opening up the environment one up here, You can see it looks very similar to this one in terms of the structure, where we've got that envars file, which is the different environment Terraform variables. And then also I've got a bunch of Terraform files over here. The make file is pretty much the same. The provider file is the same. VPC is set up the same, just with different values. So just to quickly show you what the development environment looks like, it's got a different account ID, different CIDR range, but nothing too interesting in here. So where the fun part comes in is with regards to this IAM role and this IAM policy that we have over here. So let's quickly take a look first at the developer's role. So what this role does is when we create it inside this account, and this will be created, for example, inside the developer testing UAT and production accounts. What we're saying is that the assume role policy for this is to allow the principal AWS IAM root user from that account, and that is our main account that we actually have created. So this stays static, which is why I hard-coded the account ID in here. And you can see we're allowing the action assume role. Now, like I said, assume role is what you do when you switch the accounts in the UI, or when you call a different profile inside the using the CLI or APIs in terms of to interact with a different account. So now what else we have in here is that we actually set dev and test and the other account permissions. And this is where the differentiation comes in. So just quickly before we jump into what the difference is here is, just to show you, I've created two policies over here. The first one is a S3 full access policy. And if we look in here, it's just a policy that says allow all S3 actions on two specific buckets. And that is the bucket that I've created here, which is just a bucket called HashiTalks user data dash and whichever environment we're busy dealing with. So if we go back to that full access policy, we can see that I've now got full access on this bucket and all objects inside this bucket. Then for the policy, the S3 read-only policy, you can see that I've only got all the get and list operations available for everything inside this bucket. So now if we go back to this developer role, what I've said is that for the development account, so I'm using a count statement over here to decide when to attach this policy. So if the workspace that I'm dealing with is develop, what I'm going to do is I'm going to take this policy and add the S3 full access to it, because in the dev account you're allowed to have full access. In the testing account you're also allowed to have full access, but then when we get to the UAT environment, this is where I change the policy that I want to attach to this IAM group, or to this IAM role that I'm creating. And this is where it now for UAT turns into the read-only one. And for production, I'm not attaching any kind of role, because the developers are not supposed to be accessing this user data bucket in production at all. So now that I've got these in place, let's quickly go ahead and create this for the dev and the testing account. So I'm just going to go down here into the terminal again, head up one folder to the environment one, and then we're going to say env equals dev and cool, and we're going to go ahead and say make plan, so we can see what it's going to create. And it's once again the VPC, the S3 bucket, along with those two policies for S3 for full access and read-only access, and then also that role that allows the users inside the main account to switch into this account. So let's go ahead and apply that. Okay, and we're done. So now let's do the same for the production environment. And now this is where the benefit of using the system comes in, is that your different environments will always have the same resources in them, and will be configured the same way, just with different values. For example, you might have 50 web servers inside the production environment, but only 10 or 2 inside the dev environment, depending on what you want to set up. And by using these Terraform variable files per deployment in terms of, and also per workspace that you're dealing with, it just makes it super simple to keep your infrastructure exactly the same between all the different accounts. Because other strategies that I have seen is where you've got a folder per environment that you're dealing with, and then what happens is you have to remember to copy the file between them. And it also means that if you don't want to make a change to your environment, you would need to edit the file in multiple locations, and that's where you start making mistakes and forget about doing it and breaking things. So I'm just quickly looking at my screen. I see that I just need to log in again, so I'm just going to hit the login button to refresh my session. Okay, so the session is actually valid, so let's just hit the URL again. So one nice thing with using this Cloud9 IDE is, let's say you accidentally close the window, just as a side note. you can go ahead and open it back up again. And it'll take off, or it'll keep wherever you were at that point in time, with the caveat if the instance didn't go into a sleep mode. Okay, so now we need to do it for the production account. So we're going to go env equals, env equals prod, then make plan. So this is a nice thing that I left here in the demo. So this is also a nice safety net, is that if you forget to set a specific config value for one of the environments, you'll get this normal, hey, please enter this variable value that Terraform provides you. And if I go into the production file over here, what you can see is that I actually commented out the VPC's CIDR range. So let's quickly uncomment that, and then I'm just going to cancel this, and then we're going to run that again. And now it should be finally actually show me the plan for everything that I want to go and create. So yeah, that's fine. And we go apply it. So the nice part here is that, for example, also with naming conventions, because I know that's something that's always a nightmare, is that if it's a globally unique resource like a S3 bucket, what you would do with your convention is just add this variable in as a suffix inside the resource's name, because now you know they'll be suffixed with -dev, test, UAT, or prod, depending on which environment you are in. Then for resources that don't require this, for example, let's say load balancer names, those load balancer names will now be the same between all the different accounts. Or for example, let's say you've got an ECS cluster, the name is the same, which makes it much easier to jump between the different environments and not get confused and click on the wrong one in terms of what you're dealing with. So now I want to show you quickly what that policy looks like inside this account. So we can see that how do we give our main account access into our account. So I'm going to go back to the console, and now we're going to switch into, for example, our dev account over here. Okay, it's just loading quickly. And what I can see is that if I go to the roles section over here, I can see that there's an administrator role. And if I click on it, I can see that it's got a policy attached called administrator access. And the trust relationship is that it trusts that main account. So this is what I'm currently using to create all the infrastructure for us, because I need to be able to create it, and having S3 read-only access probably won't allow me to create a VPC. So let's just quickly go back to our specific one, and we can see this is the developer's role. And here we can see there we have got that S3 full access attached to this one. And similar to that admin role that I showed you, we are trusting that main account that we're dealing with. But now, and here's where the fun starts, if I now hop into my production environment over here, what we'll see is that there won't be a policy attached to this group or to this role, because we specifically didn't want to give any developer permissions inside production. And this is now where you get the difference in terms of the permissions. So now that we've got this set up, this is now the basic building blocks for you to be able to now expand using this multi-account setup, because now all the building blocks are there. So for example, if you want to give your developers different access in different accounts, you can just go ahead and create different policies over here and attach them to the various roles depending on what access you want to give on a per account basis. Or for example, you can create additional roles. If you have, let's say, some testers, or let's say production support, they can all have different permissions, and you can easily maintain all of that inside Terraform. And that's one of the reasons why Terraform is so useful for creating all of your infrastructure. It's because you can track everything inside source control, and then also review it and make sure that you know what's changed. So people should no longer be going into the console actually creating any kind of resource or infrastructure by hand. It's definitely doable, because in the past I was at a company where we got to a point where everything inside the account was actually created with Terraform, and no human had clicked around to do something. So the reason my session is now expiring over here is that my Cloud9 environment actually runs inside the AWS account. Because I did role switching, the credentials, when I refreshed it in the background now, weren't able to get it, because I'm now currently in a different assumed role. So what I would need to do is I need to go change back to the main account, and then I need to refresh this page. Let's just quickly do that. I'm just going to hop back to that webinar role in my main account. And as soon as that has loaded, let's refresh this page, and my browser or my IDE should be back. Cool. And we're back again, and now all I'm just going to do is I'm going to quickly just clean up behind myself because I don't want to leave resources running that I won't be using. So let's quickly use the destroy command, and I personally just added this little warning in here because I found that as soon as you have color and any kind of emoji inside a terminal, people tend to pay attention. So this is where it warns you that, and it asks you, are you sure you want to completely destroy the production environment? And that should be a scary thing. In our case, we're going to say yes. So now I'll go over to the Terraform destroy command. So it'll still ask us if we want to destroy all of these resources. And we're going to go ahead and say yes. So the next step here is that now you've got the base between your main account and also your environment accounts. You'll also then do a similar setup for the services that you want to deploy. So you'll have them with environment variable configuration files for each of the different environments, because that way you can just change the configs, like I said. For example, the web server account, you can have in the dev.terraform variables file set the value to 2 and production set to 10. And that's an easy way to actually handle this. So that's all that I want to show you in the demo today. I'm going to be around now for Q&A as well. I think we've got a few minutes left, so please ask me any questions that you have. I'm also going to be creating quite a lot of content around how to use Terraform with AWS in the near future, as soon as I can free up a little bit of time. My 2-year-old is currently keeping me very, very busy during this lockdown period. But I hope to see you in some future sessions. Thank you for joining me today. Cheers.
That was great, Kovus. And I think too, it's very impressive that even in your pre-recorded talk, you were able to anticipate having a few minutes left over for questions. Production value was really good. I am going to check out YouTube real quick and see if we do have any questions. Looks like you've been interacting in there. I wasn't actually able to monitor it while this was sharing, so I had a teammate monitoring it. So it's nice to catch up. I'm going to go ahead and welcome our next speaker, who I also believe is here. Yes, I see him. Let me promote him to a panelist. So Chuka's talk is pre-recorded as well, but I'm excited that he joined us today anyways and is going to be able to answer questions and maybe say hi if he's around.
Yep, I'm around. Hello, everyone. It's actually a cold afternoon. I'm here in Lagos, Nigeria. Just finished ready, but yeah, I'm here and good to be here with you guys.
Hello, I'm so glad you're able to join us.
Thank you.
Sorry, say again?
Oh, I said thank you, KZ.
Oh, thank you. Get your talk pulled up and then I will share my screen again. I'd also like to share a little info about you as well, if you don't mind. You're Chuka is a software engineer at Andela in Lagos, Nigeria, and he is experienced in building secure and scalable cloud infrastructures for clients across the world. His hobbies include writing code, and in his free time, he likes to play games and research and keep up to date with the latest tech. And without further ado, I am going to share my screen and we can start his talk right on time. Okay. All right, all you.
Okay.
Sorry, one moment. I meant to share it with audio and I did not. Let me end it and do that again. Okay, share screen and share with audio. Okay. All right, and here we go. Thanks. All right, all you.
Okay. So I was part of a team that deployed an Azure environment for a client. The requirement was to fully automate the deployment of resources using Terraform, meaning there shouldn't be any manual interaction with the cloud environment after the resources must have been provisioned. We began the project, but hit a roadblock, which was to deploy an app service environment. We were using version 1 of the Azure provider, and the Terraform version was 0.11. which doesn't really support the deployment of an app service environment. I was able to get over the challenge by deploying the app service environment using ARM templates via the Azure template deployment resource that Terraform have, and we'll be discussing about that today. So, okay, my name is Chuka Kadibia Durugo. I go by Chuka. I'm a DevOps engineer at Andela, and also I work as a video streaming engineer at Pluto TV, which is a free television streaming service based off in the US. And at my free time, I get to play games and read articles and keep up with latest tech trends. So for this presentation, we're going to be looking at what ARM templates are and at what point we need to deploy the ARM template with Terraform. I'll also be showing us its use case with Terraform and some important things to note about deploying ARM templates with Terraform. We'll as well have a short demo on how I walk you through the process of deploying ARM templates with Terraform. I'll be highlighting some deployment gotchas and also share resource down just as key takeaways. And so I'll be hanging out in the chat for questions that you may have after the presentation, so feel free to hit me. All right, let's go into this quickly. Now, what ARM templates? Azure, basically, Azure Resource Manager template is a JSON file, like a JavaScript object notation file. And that defines the infrastructure and configuration of your project. So basically, it's a template that has resources to be deployed specified alongside the properties of those resources to be deployed in line within a JSON file. And the template format, it follows the structure. It has the following elements: a schema file. Basically, that's kind of like specifies the location of the schema file. And then you have the content version, which basically keeps track of the content of your templates, keeps track of the versioning of the Azure ARM templates. Then you have the parameters section, which contains values, and that's provided during the deployment of the templates. You also have the variables, and that defines the values that are reused in your templates. It can as well be constructed from the parameters values as well. Then you have the resource section. That's where you specify resources to be deployed into the environment. For instance, a virtual network, a subnet, or a virtual machine, service bus, and every one of those IaaS and PaaS resources you defined within the resources block. Now the big question: why do we need to deploy ARM templates with Terraform? I'll recommend doing this as a last resort, where when nothing else works, because you can lose some benefits when you can lose some benefits of Terraform, especially around the state file. And I'm going to show you that in a bit. So this approach should kind of like be a last resort for you when you are unable to go through the Terraform resource provider to provision your resource. And so generally, you want to carry out this deployment approach if there are null in ARM, which the Terraform provider has no support for it. So for example, your environment requires an Azure SQL managed instance to be provisioned, and you may want to do this using Terraform, but at some point your Terraform provider, assuming you are using the Terraform 0.11 or the current release of Terraform 0.12, which still doesn't support the deployment of a SQL managed instance, this case will warrant you to want to make use of the ARM templates and inject that into your Terraform script to be able to deploy such a resource. And this is a good use case to do this. And aside that, if you are deploying other resources that you can find the resource with Terraform to deploy with, absolutely I would recommend you go through that approach. So if you don't have the feature available with Terraform and you can actually do that within any of the providers listed, then you go through the templates to carry out such a deployment. And this is a use case, the resource that Terraform provides to be able to inject your ARM templates and deploy resources defined within the templates is the Azure RM template deployment resource. That is actually a wonderful resource to accept external ARM template files and pass in the parameters and define the properties of which you actually want to make such a deployment. As you can see, the ARM template deployment resource has properties like the name, the resource group, where you specify the resource group in which you want to provision your ARM templates resources into. In this case, we have it provisioning the resources into the example resource group within the West US location. The ARM template is injected into the template body property of the deployment resource. As you can see, that it's an external JSON file with the name deploy.json. And so the deployment file is located relative to the current working directory of this particular Terraform file. And so you have the parameters section that takes in values to be sent into the ARM templates. And those values can be like a variable that you define within your variables file on Terraform. And I'm going to show us how that plays out a bit. But then this is a structure of how the ARM template deployment resource can be used in deploying your ARM templates files located within a particular path in your current working directory. The deployment mode could be in two ways, either complete or incremental. Specifying the incremental means whatever resource you have defined within your ARM templates is going to add to the resource that you already have existing in the Azure portal. And so that is not going to destroy any of the resources that it finds there. Is going to just add to them. The second deployment mode, which is the complete, will take down every other resource within the resource group that is not defined in the ARM templates. And so you want to be very careful specifying the deployment mode that you are working with, so as not to take down resources you don't really want to take down. And we're going to now go into a key and an important item I would like to mention here, and that is basically Terraform. Upon deploying ARM template resources, Terraform doesn't have any knowledge of the content of the ARM template. So it cannot manage the resources in which the ARM template provisions. Basically, Terraform keeps track of the top level template itself, but it doesn't keep track of the resources, and it's something that you should bear in mind when provisioning with ARM templates. And I'm going to show us what that means at the course of the demo just after now. And so brace up, there's the point where I'm gonna take us down to the hands-on session to illustrate how to go about this deployments. And I'm gonna share the screen here. Right. Hey, Katie, do you see my GitHub?
I do. I see your GitHub.
Oh, great. Okay. This is a GitHub repository where I have the Terraform script we're going to be working with. But now I'm going to actually switch back to my code, VS Code. This is my code editor. I love it. And writing my code, Terraform, or either any of my programming languages is a wonderful tool for code editing. Okay, so we're going to be deploying a very simple application here. This is a web app. And for note, Terraform has a resource to deploy a web app. And I chose to use the web app to try to simulate that with a SQL managed instance. SQL managed instance takes over about 2-3 hours to deploy, and that would take a longer time to do that. And then things like an app service environment, it also takes a lot of time to deploy. So, but within less than a minute, we can actually deploy this. And this is a sample to show you how you can go about deploying an ARM template. So take this template to be like the resource that is not available in Terraform, but you're trying to inject an ARM template into your Terraform scripts. Here we have the Azure template deployment resource. And so you can see we are specifying a count, name, resource group. This count specifies the number of templates deployment to deploy. And here, the template body, which I talked about earlier, is the property in which you inject in your ARM template file. Now, this can actually be an inline property that you send to this template body here, or you can specify your ARM template as an external JSON file using the file function to call wherever you have your templates within your current working directory. You can see it's actually a relative path referencing the deploy.json template right here. And we'll go into the templates shortly now. And we have the parameters section that receives values. The values is coming from the Terraform variables.tf file. It's already stated this way. We are getting the web app name, the SKU name, and the SKU tier. These are basically just price and tiers, and they're variabilized and gotten from the Terraform variables file. So we're passing in these values into our ARM templates as parameters. So let's have a look at the templates. It's a minimal one, right? And this, like we talked about the elements of ARM templates, it has a schema file, it has a content version, and here we have the parameters section that takes values coming into the ARM templates in which the user can set. So these variables can be coming from your Terraform TF-VARS file, and you can set that at the point of deployment. So it takes these values down from the Terraform script and plug it into the ARM templates to deploy the different resources. We also have the variables section that also you have the different names of whatever you want to use a function like a concat function to give a different name for whatever resource that you are provisioning, right? You can use a function to concatenate parameter values as well and use a different way to name your web app. In this case, what we are doing is we are getting the name from the user in the variables file and also concatenating that name with another string value and passing it as a variable called web app portal name. And then we are using this variable as our web app name within the resources section here, where we are deploying the web app. So you can see the type is a Microsoft.web/site, where we have the kind and app. And then we have name. The name, we are getting the name from the variable section, which I already highlighted here. And also the properties, we specifying that it's going to be dependent upon the app service plan that we have defined at this top section right here. And then further down into the template, we have our output. This is going to trigger after the resources has been provisioned to give us the host name of the web app after having deployed down to the Azure portal. And so this is a simple template that we have to plug into our Terraform scripts. And we have that within our template body. Like I said, we could do this inline, like get the whole bunch of this JSON file and plug it down within this template body here, but it's not going to look so clean and it's going to actually be so lengthy. You want to actually maintain a clean code. And so using the file function is just best to make your code much more cleaner. And also I'm making use of the current release of the Terraform provider 0.12, and that is why you're not seeing me use any string interpolation mechanics for kind of like get the variable values, because that is one of the cool features that the Terraform new release has. You can just directly call your variables without having to do string interpolation, and that's really cool stuff. Okay, now we have every one of this defined, and I also have the service principal for Terraform created, within the Azure portal, and it's something that you really want to do before you run your Terraform plan and apply, is to create a service principal in Azure and then export those. I have it currently exported within my shell environment, and it keeps track of the ID and the secrets. And if you want to actually play around with this as well, you could get your Terraform service principal created and exported or plugged into the provider here. I'm currently using 2.0, and yeah, it's not specified on here because it's exported in the shell environment. So let's deploy this and let's see how this gets created. I'm going to move down to Terraform Cloud. I have it stated here. Hold on a sec. Let me get this here. Oh, great. I'm currently using Terraform Cloud, and I found Terraform Cloud great because it's good in terms of managing teams, working with different teams, and managing your state file. And so I have the repository integrated within my workspace web app deployment. And quickly go into the settings and version control. Down here, you could see I have the workspace connected to my repository web app deployments to Azure, which I showed you earlier. And as it's set to always trigger at the master branch upon every deploy, upon every push to that particular branch. And so I have the variables injected within the variables section of Terraform Cloud. So we have the web app name. Upon deployment of this resource, you should be able to see a resource group, HashiTalk resource group within West US2. And these are the different pricing tiers specified basic. Deployment count is set to 0, which means our deployment templates will not deploy because it's set to 0. So I have to set this down to 1 to tell Terraform to provision a resource of this template. And so having that saved, I'm going to queue up a plan. And that should kick off a moment now. All right, in less than a minute, we should see this resource getting created. And let's head to the Azure environments. I just refreshed this just to see that the resource group is not yet created yet. There we go. All right, great. Okay, so we don't have any resources HashiTalk LG, so let's wait for our plan. And let's see, our plan is completed. Just expand this right here to see that, okay, it's gonna be creating the resource group. You can see with the name HashiTalk, getting the variables that we defined already within the variables section. And then here's the content of our templates. You can see it's referencing the ARM templates we specified already. And you can see this is an inline, representation of the templates that we have. And so it's going to provision each and every one of these resources defined within this resource section, an app service plan, and we should expect to see a web app. So 2 resources, an app service plan and a web app, and that's fine. We can go ahead and confirm this. When it's confirmed, and then it's applying. It should take less than a minute. So while that is going, let's go down to our Azure environments, refresh this. So at this point is where maybe you kind of like grab a cup of coffee and just wait for this. And so, like I already said, you should only do this when the resource you want to deploy is not available with Terraform. And yeah, you're gonna get the ARM templates definition for that particular resource injected to the Terraform Azure resource manager template deployment resource that will enable you to deploy an ARM template with Terraform. And when this is created, we should expect to see the resource group And then we should expect to see two resources, which are the web app and the app service plan. So we just have less than 10 seconds. Then we should have this all up. Great. Apply is completed within our Azure environment. I'll just refresh this here, and we should see resources created here. Okay. And there we go, HashiTalk resource group. So let's see what are the resources it created. Yeah, a sample application web app and an app service plan. Going to the deployment session within your Azure environment, we should be able to find the templates. You can see sample application deployment succeeded. Now, this template created these resources that we just observed within the resource group, an app, a web app, and an app service plan. And also we can see the output of this resource giving us the host name of the web app. Then copy that and go down to a different tab to see the application we just deployed. And yeah, this should come up within a second right now. It's loading, great. So this works. This is deployed using templates. And so one key thing, like I earlier said, you need to have in mind when deploying this is Terraform doesn't keep track of these resources that are deployed within this templates. What it only knows is this particular template here. You can see sample application deployment. And so if I do something like, one major challenge is if I intend to want to take down the resource, if I have no need for the resource or it's no longer in use, or for some reason we want to actually take that down, I'll just set this count down to 0. What should happen for a Terraform resource is that resource should be destroyed. But in this case, if I queue and apply, it's going to unlink this template from this resource group, but then we'll discover that the resources are still available within Azure environment. And I'm going to say a quick fix for that. But something that you should bear in mind, Terraform doesn't keep track of each and every one of these resources that it provisions with ARM templates, but it only keeps track of the top template level, which is this template we saw at the deployment section here. And so if I queue this plan, it's going to tell us that this template will be destroyed. But bear in mind that it's not going to destroy the resources. It will only unlink the template from the Azure environment. And so what we are going to have is we're going to have these two orphan resources not being managed by either Terraform or ARM templates. So the question is, how do I go about getting rid of these resources? Yeah, I had a challenge, and there are two ways. The first way, which I wouldn't recommend, is to take down the resource group. Definitely the resource group is going to delete all the resources in it. But you might not want to remove the entire resources within the resource group, because not all resources might not be, not all resources you want to really pull down as at that point. You just need to pull down the web app and the app service plan, right? And if you take down the resource group, it's definitely going to take down everything that you have. The next thing you might want to actually do is to write an automation script, all right, using the Terraform local exec provisioner. And that basically will interact with the Azure API to get the name of the application or resource that you want to take down. And you're going to use the Terraform hook on destroy to get those resources and kill them when it is destroying the templates. So this is completed. And if I refresh this, let me refresh this environment here. You'll see that's taken down that template. But if I refresh this right here, you can see, okay, it's coming up real quick. All right, it say no deployment. It doesn't keep track of that template anymore, but then you can still find this orphaned resources. And so either you can manually delete this, or like I earlier said, you can within your Terraform script have the provisioner, the local exec to run when this resource is getting deprovisioned. It's going to execute something like a bash script that takes the name of the web app and the app service plan and destroy them using the Azure API. And so, or if you're actually going to destroy that from the resource group, that means you want to actually queue a destroy plan, which you might not want to do, because that is going to destroy every one of the resources within that resource group, and you might not really want that. So it's something that you should bear in mind when deploying ARM templates with Terraform. This is the challenge that is there, but then it's something that you should look through when going through this deployment mode. But then was able to help me in terms of the deployments that I had with the clients I worked with, like I earlier said about in deploying the SQL managed instance. I was able to do that using the template script, and I had the bash automation script that automatically deprovisions it upon destroy, and everything was fully automated. And so here we have it. I will just switch back here to my slide. Let's just share this. So yeah, and here are resources that I have for us to look through and go through how Terraform deployment resource works. It has other functions, other ways to go about using the deployment resource with Terraform to deploy your ARM templates. But for the brief,
I'm still seeing your browser.
Oh, you still see my browser?
Sorry to interrupt you. Yeah, sorry to interrupt you.
Oh, let me see. Do you see my slide now?
No, not yet.
Oh, okay. All right. How about now? You should see my slide.
I see it.
Oh, great.
There you go.
Okay. Okay, so I'll just recap. Yeah, so here are the resources that I have for us. We can actually get through this. I have the repo already within the slide, and you can hook me up within the chats, and I'll be here to answer any further questions. So thank you.
Thank you, Chuka.
Yeah, thank you, Katie. Can I just answer a question asked by, I think that was Cypress. So
yes.
Cypress said something like Azure has a provider currently in private review. And yeah, I know Azure is constantly getting feedbacks and getting updates on their resource platforms and how users get to interact with it. Although that's like a reverse, like you said, injecting Terraform config into ARM templates of Azure Resource Manager. But this is actually a kind of like a different demo. We're kind of like seeing where we have a total infrastructure that is already built with Terraform, and we want to kind of like have some resources that Terraform doesn't support, but is ready in ARM, right? And we want to inject that into our Terraform script. And so that is where this actually comes in. I know as at Terraform 0.11, there was no support for the app service environment, but the current version of Terraform 0.12 currently supports the deployment of an app service environment. And so we can actually do that. SQL managed instance, yeah, it wasn't really supported before, but right now it's actually being considered. I know there's a pull request on GitHub on the Azure environment on Terraform config to ensure that SQL managed instance is actually supported. And so, yeah, until that happens, all right, and you just kind of like have to go through a way to get your infrastructure provision right. And that's actually where this comes in. But yeah, I will respond to furthermore in the chat. But thank you.
Chuka, thank you for taking the time to answer that question and for being here today and pre-recording your talk. Thank you so much. So next up we have Oluwase, who I also believe is here today as well. Let me see if I see him in the attendees. I do not, but I believe he did note he was going to be in the YouTube chat. Let me pull up his talk. He is a Microsoft MVP. My fun fact for you today. Okay, so let me share my screen with audio this time. Okay, hopefully you can see my screen. And I'm going to start the talk. All right, take it away.
Okay. Good morning, good afternoon, good evening, wherever you're calling from. This is HashiTalks Africa. And my name is Oluwaseyoluwawumiju. And today I'll be taking you to a ride on how Azure is collaborating with open source. What are the advantages to this collaboration? And you can also check on this event. Actually, I'm doing a pre-record. So if you have any question for me, you can just put it on the chat window and I'll get on it when I'm on the talk live. Now, let me give you a little introduction about myself. My name is Oluwaseyoluwawumiju, as I said earlier. I'm one of Microsoft's most valuable professionals in Africa. And my space is from Office Apps and Services. And also, I am a Microsoft certified trainer and also badged the badge of being the regional lead for West Africa. I'm a consultant. I've been consulting over 18 to 20 years. I'm an author and also an international speaker. And you can follow me on those handles. That is my Twitter. That is my LinkedIn. You can just type it. Now, before we begin, I always like to give this intro whenever I get to my presentation. Why? Because I read about a lady years back in 1866. I think she died around June 27, 1953. Her name is Mary Elizabeth Anderson. Now, what's unique about this lady was that a day she was driving out of a car, driving in the snow, and she noticed that most cars are stopped, and most of those cars had snow all over the windscreen and nothing to remove it. And what baffles her at that time was that every time there's a stop of a car, a young man, a young lady comes out, then there was men that were driving, few ladies then, tried to take something like a stick or something to remove the snow from the screen. And that brought an innovation to her mindset. And that was the turnaround to the car and the automobile industry. She was able to develop what we call a windscreen wiper. Until today, you can drive through the snow, you can drive through the rain. Once you have a wiper, you know something is going to take away the water from the windscreen. And that is what innovation is all about. And where are we going today? We're going to a reality show where we have an open source having an interchange, a collaboration with already known standard OEM company like Microsoft, and our focus on the cloud provision. So our agenda is on threefold. One, we're going to look at Microsoft and open source. Is it real? Is it happening? Secondly, we're going to look what are the benefits we get from open source, and our target, we're going to streamline our talk through HashiCorp and also looking at one aspect of their tool called Terraform. What has Terraform brought about on the table? What has been brought about to change the way we can provision, we can automate, and also manage some of Microsoft cloud provision. And finally, I'm going to direct you to some resource where you can get some things online. Now, in the past, to be real, there has been a boxing match between open source and Microsoft, and that is not a story. And why is it like that? Because the open source market gives room to all the techies to come in, use the tool without paying. And on the other side, Microsoft has standard OEM that standardizes processes and sells on the market. Now, these two battles has been there. the tech industry has been divided into two, where Microsoft and the likes of Google or AWS actually were using their products, selling their products, standardizing their, improving it, especially in the cloud provision, while the open source market is giving their code for real, free of charge. And this has been a division that I've cut across all the IT industry. Where do I stand? But now started with the journey of Microsoft with Linux, they have been able to have an interchange, a collaboration, a love relationship. Now, in the reality now, we can have Microsoft in love and also working with Linux. And almost all the open source solution runs on Linux for the provision of the standard or the environment for other codes and other provision applications to run on it. So many news has gone out where we have Microsoft actually embracing Linux, embracing open source. It is not a story anymore. It is now a reality. It's something that we need to go. You can go online and check it. These are some news I gathered, and we can see even the industry is embracing it. People are actually seeing this collaboration as a reality check, as a way out. I might be used to an open source and a techie person. I can actually leverage on Microsoft Azure, Microsoft Cloud Solution, and provide my customer, my client, the best tech-notch solution, even at a given time, using all the tools I have. The community also has grown. Innovation is now integrating, and enablement has been brought into place, like the HashiTalks company. They actually brought tools by which we can use to enable, automate, simplify how we manage our tools on the cloud. Now, there has been an interchange of contribution. Now, the community is growing. Now, the open source community and also Microsoft community is growing because this collaboration has brought about people coming together, having a common goal, and releasing products that can easily change the way we work. And one go-getter at this point is the acquisition of GitHub. Now, GitHub brought about a turnaround to Microsoft integration into the open source community and bringing more people to come in. And what this does is that it enables us to have a better solution, a better timeline, application, reality, especially in terms of software development and on the cloud has become simplified. As I said, the contributor of most open source is on GitHub, and the takeover, sorry, my English, the acquisition, sorry for that, of GitHub has given rise to integrating not only Microsoft, but every other open source provider to have a common pool of resource. Now, in cloud narrative, so many information have been gathered. You can see the graph talking about the project, and Microsoft in its own has been able with the time and with its integration to have also a bit into the project provision from the open source provision, open source market, giving room to a better integration and better knowledge. Now, let's now take a dive. What is Microsoft's strategy? Now, as I said, it's very flexible, providing a flexible platform. Not only providing a platform, integrating with open source solution provider like HashiTalks, like Linux, and making them to have their tools, enable the tools to be able to integrate properly in the cloud provision. Now, this gives room to what? An extendable, strong ecosystem. And no system can sustain itself when they are divided. They said a divided house is running into domination. There is no way we are going to be divided on the point and we get to the right point. So now this can now extend to enterprise. So an enterprise company can easily onboard onto Azure using Architect Terraform, provision their that's Kubernetes solution or the container solution with ease and with little or no issue on the line of provision of this solution. So the partnership has begun and the partner is there. Now let's look at HashiCorp. I've been talking of Microsoft, what Microsoft has been doing, and let's look at a little bit of HashiCorp. HashiCorp has been able to provide tools. The major tools are the 4.6 you can see, and the one we are used to. And one thing about HashiCorp, people knows the tools even more than their names, and that is the irony. People have been using Terraform, they have been using Vault and Console and even Nomad, not knowing the provider or the company. HashiCorp has been there. The ecosystem of HashiCorp has been there for a long time. And that brings me to introducing you to the streamline of my presentation. And that is how Terraform has been able to collaborate with Azure and have been able to bring a better solution and gives the client and the customer a better reason to go on the cloud technology. Now let's look at how do we see the collaboration between the open source and Microsoft space. Now in this form we are looking at HashiCorp. I can categorically say what this collaboration that HashiCorp brings is just defining infrastructure as a code. What do I mean? I want to bring my VM, spin it up maybe in few minutes without resistance, without issues. I can just use the code through the tool of Terraform and provide my infrastructure without having issue. Other tools which are common, as I said, Terraform stand out in terms of the Azure provision. We have Vault, we have Nomad, we have Console, but I will be talking more on the Terraform. Sorry. So the next thing we're going to look at is how do we benefit from this collaboration? We have seen whether the reality in terms of checking the reality about the collaboration. And I can assure you in reality that this has happened. And I can give you track record of what Microsoft have done with the open source community by acquiring GitHub, giving them a better pool of bringing in a larger ecosystem and a stronger build between Microsoft's solution and also. Now we have also seen how we have been able to integrate with Terraform using Azure provision by providing, using Terraform to provide Azure infrastructure, making it as a code. Now let's look at the benefit. Now you can see across board, all the list there are just some open source which we are going to look at, but generally our target, if you look at on the management portal, you see Terraform, that's the logo of Terraform. And one thing about Terraform, also even in most of the Microsoft provision like Azure Stack, it plays a major role in trying to provide and building up and spin up VM, which is easy and reliable. So you can see Terraform standing out here in the management stack, showing that in the open source market that Azure is actually embedding, that is working with, Terraform lies there. Now let's look at Azure Open Source Cloud Infrastructure. How does it apply? You can also see here under operation, we have Terraform. You can see architect under developers. You can see that the ecosystem is building. And this shows you that Azure is just creating a platform while other open source are working on it to make it work, to make it more smooth and landing process to be more achievable. The truth is that 70% from 2007, 70% of people really don't know where and what cloud infrastructure will look at, what are the priority they need to look at. And sometimes they guess in terms of security, 50% of them look at security. Is it more secure? Is it less secure? Now, another aspect that plays a little role is 48%, who talks about probably the management. And that is where Terraform comes in. Now, in terms of security, the layer is coded, layer is more secure, especially when you are using your universal account. And one thing about Terraform, because of the integration with Microsoft, you are logging in with the security identity that is already provisioned on Azure. That means you can log in into the platform without actually, because it is smooth in the back end. Your integration is smooth. You can log in and you can easily have access to your resource group from Azure. Two ways you can use Terraform is when you use Azure Cloud Shell and you install the Terraform code on it, the shell provision, the shell program, or you use Azure Cloud Shell, the one integrated in Azure Portal. All this provision has already been provided, and the backend have integrated to Azure Identity and also all the resource group, and your storage group is created on Azure. Advantage of HashiCorp. One, the necessary command that you need for creating your VM. So once you have that done,
Looks like we lost audio. See, 1 second. Let me stop sharing the screen real quick. See. 1 second.
you just
Okay, and there it goes again. Let me just restart it. Thank you for the comments, everyone. Okay, share screen. I'm just gonna backpedal us just a few moments so we can catch back up. Let's go back a minute. Okay.
Platform to the zip file, you run it on it. When you run it on it, it provides you with all the necessary command that you need for creating your VM. So once you have that done, you just go ahead and create your VM and say voila, within a few minutes you have your VM. I might actually show you a video afterward if I still have time. If not, you can just reach out to me. I'll just send you the link on the chat when you are live, and I can easily send you the code. The video for you to watch. Now, what are resources you can get resources on open source. You can even mail Microsoft through opensource@microsoft.com to have more information, and you can see the link there. Now, you can get more for Terraform on Azure by going through these 3 links. Learn HashiTalks.com, Terraform, Azure Intro A to Z. You can also go to Azure integration with Microsoft. You can go to azure-microsoft.com and overview of Terraform and the advantage. I don't know if you have any question. As I said, this is a pre-recorded section. You can just send your question and I will look at it while we are live and I will answer it and give you a better direction. And I thank you all for listening to me. I hope I've been able to give you an highlight of what the collaboration between HashiCorp, Terraform, and Microsoft Azure is, and what are the advantages you get from it. Thank you, and have a good day. Stay safe. Thank you very much.
Hi, everyone. Sorry about that outage at the end. And thank you, everyone who commented and let me know. I appreciate that. While I'm sharing my screen, it's a little challenging for me to go back and forth. So your comments are very helpful. Thank you. All right, let me get queued up who we have next. So we have Idris next. I met Idris through the Lagos, Nigeria hub, and I'm so thrilled that he joined HashiTalks Africa as a speaker. I'm just going to check and see if he is here. He is. His talk is pre-recorded, but I'm going to promote him to a panelist in case he wants to say hello. Take him a moment to rejoin. And in the meantime, I'm going to check the comments in YouTube real quick for any questions. Okay, it looks like there's not much there right now in terms of questions, but I will keep looking. Idris, would you like to say a quick hello?
Hi.
Hi. Sorry to put you on the spot like that.
No problem. No problem.
I had a feeling you might be okay with it.
Yeah. Yeah. So hello everyone and welcome to the HashiCorp Africa talk we're having today. The next presentation is about deploying product using Terraform, Ansible, and Kubernetes, and using them. The talk is not going to show you an in-depth expose into these different tools. It's just to help you, give you an introduction into how to use them, and probably even give you ideas on where to use them. Thank you.
Thanks for being here. I want to share a little bit about your bio because I think that it's very dynamic. You have a very interesting background. So 5 years ago, Idris was practicing law, and then he transitioned. Into a software engineer role, and now he is a full-time DevOps and full stack engineer. And in his time outside of work, he enjoys watching anime and reading manga, and then learning new tech skills, keeping up with the latest technology, and also has a love of cats. So this was a pre-recorded talk, like you mentioned, so let me pull it up, and I encourage everyone to engage with Idris in the YouTube chat. Okay, hopefully you can see my screen. It's just loading for a second. Wow, Idris, your talk is almost exactly 30 minutes. Love to see that.
That took a lot of practice.
I bet. Coming from someone who often runs over if they're given a time construct, I do know it takes a lot of practice. Let's give it a second to load. Oh.
How many minutes?
Sorry, say again, Idris? Oh, I think that was actually in the record.
Yeah, that was the recording.
I heard your voice and just assumed it was a question. And it looks like we got some of our chatter. So I'm just going to fast forward through that and spare everyone. They've seen enough of my face today.
Yeah.
All right, here we go.
HashiCorp to Terraform presentations about how to use HashiCorp to Terraform and Ansible to manage a Kubernetes cluster, and also provision resources within or manage resources within the cluster. But before I begin, I would like to first of all begin by setting up the cluster so that by the time I'm done with my presentation, what I will be doing will be provisioning the resources within the cluster so that we don't have to wait for that, for the whole provisioning of the cluster to begin before we are done with the presentation. So before I begin, let me show you guys what the cluster looks like on GCP, because I'm using GCP as my cloud provider. I'm provisioning the Kubernetes cluster. So this is what it is. I have no cluster ready. This is my project. There's no resources, nothing. Everything is empty, nothing there. So going to, this is the directory, project directory where where the code is, the code base, the source code, and everything I'm using to provision the cluster and provision the resources within the cluster. So I have directories like Ansible, Kubernetes, and Terraform. All these directories are just created there for you to be able to easily manage where your source code for the different tools you're using are going to be, and also makes it easier for you to undo versions or even ordinary configuration movements. This makes it modular, much more easier for you to use. So the first thing I'm going to do is go into the Terraform directory and then run Terraform. The first thing you do when you are in the Terraform directory or in the Terraform project is you initialize the directory first to use Terraform, because if Terraform is not initialized, you won't be able to use Terraform to communicate with your cloud provider, and then in essence, you'll be able to create resources within it. So you need to initialize Terraform to use your chosen provider, which I am using Google's provider since I'm communicating with GCP's GKE, that's Google's Kubernetes engine. After initializing Terraform, you plan your resources. What Terraform plan does for you is it's sort of similar to when you want to build a house. You have a piece of land and you don't know what to do with it. So you call someone who has the technical knowledge of planning, designing a plan for you that would fit what you want to build on your on the piece of land. This is similar to the Terraform plan is also similar to that in the sense that you have a bunch of configurations and you would like to see what the configurations look like before they are provisioned in the cloud. So when you run a Terraform plan, you see a bunch of outputs that would show you, based on your configuration, what will be created in the cloud. And using this, you can decide that, okay, so, well, I don't think I need a cluster anymore. Let me change it. Or maybe I don't like the name I've given the cluster. Let me change it. It depends on you. But what this just does is gives an opportunity to plan and have an idea of the resources that will be created in the cloud. Then after planning, then what we're going to do now is apply the resources in the cloud. So what this is going to do for us now is create the Kubernetes cluster in GCP's GKE. But since it's going to take roughly 6 or 7 minutes, we are going to let this run while I go back to the presentation. So by the time we're done with the presentation, we should have our cluster up and running here. Now back to the presentation. So again, I talked about deploying and managing the minimal application in the Kubernetes cluster with Terraform and Ansible. So what are Terraform and Ansible and Kubernetes? All these tools are basically things we use in DevOps. They are tools we use in DevOps for automation mostly. Basically for automation mostly. But then we also use them for, especially Terraform and Ansible in this case, we use them for configuration and change management and for continuous delivery. And Kubernetes, mostly we use that for, orchestrating deployment, since Kubernetes is mostly used with containers and in situations where you want the application to be highly available and fault tolerant in cloud. So what are some of the use cases we have for each of these tools? Starting with Terraform. Well, for the most part, Terraform is mostly used for automation. If you have a lot of steps, maybe for example, you want to, let's say on Amazon, you want to create an EC2 instance and you don't want to have to log in and then sign in, do your authentication, go through all the authentication you need to go through, look for the EC2 dashboard, click on launch instance, and then run through all the settings and all that stuff. You can use Terraform to do all that with just minimal configuration, And being able to do that with Terraform is just basically automating your whole step, having to log in, having to do this and that. Because all you have to do is just provide the Terraform script with your credentials, your access and secret keys, or in case of GCP, you provide it with your service account, JSON file, and it will provision these things for you easily without any stress. All you have to do is just run a bunch of commands. And it's that automation that is mostly important with a lot of these tools, because with that, you can do so much in so little time and achieve, and have more time to do a lot of other things that will add value and solve a lot of business problems. Create solve a lot of solutions for your business, as the case may be. And then the second real use case is of server provision. Like I said, when you are automating, you also have the ease of provisioning your servers in the cloud without having to do take so many manual steps. And then also ease of managing your configuration. This is also important because with Terraform, a lot of things have been, abstracted out for you. You don't have to write so many bash scripts that we jump into too many steps, and then you have to go through the manual, long steps of managing this bash script. All you have to do is have your Terraform, configurations as modular as possible, and then, having that modularity, it makes it also easier for you to change things, update, remove, and basically, like I've said, managing everything easily. You know where to look for things, you know where to find what you need to find, and even variables are also managed easily, and which makes it easier for you to dynamically provision your resources in the cloud, as the case may be. And then there's also, the planning of your resources, which is what I showed while I was running the command previously. Then also infrastructure as code. Infrastructure as code, the use case infrastructure as code goes along with this of management of your resources, because infrastructure as code just means that you have turned all the manual steps you are taking to create your resources in the cloud. You've turned them into code, and then you don't have to jump through all those hoops anymore. All you have to do is run your script, and you're good to go. And the next tool is Ansible. Also, the use case between Terraform and Ansible is not so far off. It's just that, for the most part, you have to just, you yourself, as an engineer, you need to sit down and think about your use case and think about which is the best for you to use in a particular case, or which is the most appropriate for you to use in a particular case. Because sometimes, depending on the use case or depending on the solution you're trying to create, you might say that, okay, I want to use Terraform to write all the solutions I want to create. And then occasionally you'll be like, well, maybe Ansible is what works for me. So there's no one size fits all solution. You just have to come up with your own, you have to decide yourself, like, okay, so I think this is best for me, this is the best for me. So it's like in Terraform, the use case here is also automation, server management and provisioning, use of managing your config, app deployment, infrastructure as code. And then you can check out the links underneath each of the tools to know more about how, check documentation out to know more about how to use these tools and kind of use cases you can use it for, even the one that's not listed here. For Kubernetes is not really a tool per se. It's mostly, for me, I feel like it's mostly technology, because you don't exactly use Kubernetes, but you have different tools you use to, you have different tools that are native to Kubernetes that you use to manage your cluster, create a cluster, manage your cluster, the resources within the cluster. But the use cases Kubernetes itself came to, help us make it, help us assist us in, being able to use containers easily, or create clusters and use containers easily, and also scale our applications faster, and also be able to create an application or deploy an application that is highly available to our users, and also in situations where there are issues where some containers are crashing or they are not healthy, it's able to, Kubernetes is able to help us reprovision those resources and then ensure that as much as possible we don't experience any downtime. Then there's also use of deployment and rolling updates to your cluster. What this means basically is that with Kubernetes, you only have to create, most of the time, depending on your use case, you only have to create your cluster once. And when your cluster is created, all you have to do most of the time is update the cluster with new, if you have new updates to your code base, you update the cluster, as the case may be. And rolling update basically just means that depending on how huge the update is, you don't have to pull down all the resources before the update is done. The update can be done in place, and the update can be done in place, and the users will not even notice any downtime, because you don't have to pull every resources down or what have you, and then you create new pods. And then another use case with Kubernetes is it works very, very well with containerization tools like Docker, Containerd, and so on. But Docker is most popular, so that's what most people use Kubernetes to deploy with. And then you can also use Kubernetes to to deploy applications that are really modular, in the sense that if you have, for example, an application that has a front end and a back end, maybe an API back end, the front end, maybe React, and you want to deploy these two applications, and you have a cluster, you can all you need to do sometimes is, in that one cluster, provision those two different parts of the application, just two different microservices, deploy them in different namespaces. And then deploying them in different namespaces means that you can easily know where to find one particular application and debug or check anything within it, and the other. You don't have to, if you need to find anything within the front end namespace, all you have to do is check the front end namespace for your pod or your resources. And the back end namespace is the same thing. And in that kind of scenario, it also makes it easier for you to put everything within one particular place easily, and also manage your resources as the case may be. So the namespaces feature is one of the many features that Kubernetes has that makes it easier for you to deploy your applications easily without having to worry about creating different clusters to manage different things if there is no need for that kind of solution. So, and then moving on to the last one, Kubernetes is a technology and a tool that is very, 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 very perfect for a product that is built on microservices. And if your product has different microservices, you have the payment microservice, you have the login microservice, you have the image processing microservice, as the case may be. Kubernetes is the best for you. Why? Because all these microservices are things that need to, communicate with each other at some point. And also there are things that may not even be as big as you may think, as most, microservices, in which case you can put them in these different microservices within different namespaces and you'll be good to go. Or you can even put them in different clusters, depending on whatever your use cases. But basically, Kubernetes is very, very useful for microservices. Microservices are, services that are mostly doing one particular thing. And in doing that, they are able to, when they fail, they're not affecting every other services that also uses them. So as opposed to in situations where one monolithic app, a service fails within a monolithic app, and then everything just goes down. So microservices Kubernetes is really perfect for the microservice architecture. Now, how does Terraform and Ansible work with Kubernetes? An example code of how Terraform works with Ansible and Kubernetes is something like this. This is an example code of Ansible. But before I speak about this, let me talk about the example code for Terraform first. With Terraform, most of the things you need to do, you don't really need to do so many things if you are starting out to learn how to use Terraform. You don't really need to do so many things to create a cluster. You can work with the most minimal configuration and you have a cluster that would be created for you to use, to test, to play around, break things and things like that. But of course, as you go along, you get to learn that there are so many things you can do with a Terraform configuration, creating a cluster for you. And this is a snippet of what what can be used to create a minimal cluster. with this, you can create a minimal cluster on GCP. And that's just all it minimally takes to create a cluster. And with that, you can provision your resources within it, and you'll be good to go. This is an example of an Ansible module that you can use for playbook. This is a playbook, but in the playbook you have the Kubernetes module that you can use to create resources within the cluster. So this is just an example that I used where it points to this module assumes that you already have your Kubernetes object in these YAML files, something like this, and then you point to those YAML files, and then you point the module to the YAML files, and then Ansible will take them and then provision them within your cluster. Of course, the assumption is also that you've already made necessary connection to your cluster in the cloud before you run your Ansible playbook. And then this is an example of a Kubernetes object creating a service in the cloud. This is a service, and this is a load balancer service. This is a Kubernetes object. This is what we used to create a Kubernetes service in the cloud. Of course, you can also create these things from terminal, just using kubectl to create these things. But since what we are trying to practice is infrastructure as code, we turn everything to code, and this is what it would look like. Now let's go back to demo. For the demo, this is the code base here that I'm using for the demo, and the steps you can. But since I already started running the Terraform apply command a few minutes ago, it has completed provisioning, and now we have our cluster up here running. So the cluster, the only thing that is created right now is the cluster. We have no resources within the cluster. Now what I'm going to do next now is connect to this cluster by clicking the connect button here, and then you have this command that shows you how to connect to the cluster. So I'm going to copy it, come to my terminal here, and then paste the command here, and then connect to it. By the time this is done, you see that my terminal prompt changed from Minikube to this, and that just shows that I'm connected to the cluster. Now, before I run the playbook, let me come out of this Terraform directory, and then come back to this directory where I have my Ansible directory. In the Ansible directory, you should see I have a playbook directory. Let me show you in the browser. In the Ansible directory, I have the playbook, which just has a minimal configuration. It shows how I'm connecting to my host, how how I'm handling sudo rows, and then the rows itself. The rows are just where my task. Ideally, my task should be here, but since I'm abstracting out my modules, I have my task here under rows, directory, rows, Kubernetes, and task. And then this is my own configuration pointing to my own Kubernetes object here. If you're using this repository, you would need to, when you clone this repo, you must make sure that you use the absolute path to where this repository is cloned, so that your Ansible playbook will be able to find the path where the objects are. So going to the directory where the objects are, we have deployments, which just deploys our application using an image that I already created and saved in my Docker account. And then we have our service object. it's just something very minimal. Now, going back to the terminal, the first thing I need to do is to export these credentials, the variable Google application credentials. This is done so that Ansible would be able to find, because Ansible would always look in the environment for this variable in order to be able to authenticate with our Kubernetes account on GCP. If you can find it, it won't be able to provision our resources. So we need to make sure that we point this variable to the absolute path where the credentials is at, so as to be able to find it. And then when that is done, and we are connected to the cluster, the next thing to do would be to run Ansible playbook. The command Ansible playbook pointing to the directory where Ansible playbook is at, and then also to the playbook file. The reason why I'm using the flag V is because I want it to be in verbose mode so I can see the output as the command is running. Okay, so I need to run it with sudo, that's what this means. So now we wait for the resources to get created in the cloud. Okay, so our deployment object has been created. Now it's creating our load balancer, which is our service object. So now that this is created, we go back to the browser. First, let's check our workloads. You can see this is so just created, and also this is also being created. Now let me click on this so that you see what is going on within it. It's not like there's a problem, it's just that because it is being created for the first time, it doesn't have minimum availability. So because the minimum availability is supposed to be 3 pods, and since 3 pods are not available, it is always going to say there are no minimum availability, and until when the pods are available, since they are still being created, not available yet. When they are available, then it changes from this warning, this danger notification, to being green and all good. So let's give it a couple of minutes, couple of more seconds. Sorry, shouldn't take more. Yeah, so everything is fine now. You can see everything is green. Checking the services also, everything is green. If I click on this, one of the things this service, load balancer service, does for us is it automatically creates the load balancer for our Kubernetes cluster in the cloud. And when the load balancer is created, an IP address is also automatically attached to it. So when I click on this, it should take me to the app I deployed. And that's it. That's just how you can deploy a minimum Kubernetes cluster with the minimum configuration. And using this, you can extend even the configurations we have here to deploy something bigger, much more than this. This is the configuration for create cluster. This creates the cluster for us. This attaches node pool to the cluster. And what this node pool does basically is just to easily manage and bring all instead of creating default node pools that your cloud provider will probably create for your Kubernetes cluster. This helps you bring everything together on your cluster easily. So it's not just something that is randomly showing up in your Google Cloud account, because the thing is that when a Kubernetes cluster is created, it needs virtual machines. When a cluster is created, you need virtual machines to run. And if I check my VM instances dashboard page, you will notice that I didn't create this VMs myself. This was created by Kubernetes itself. So because it needs VMs to work. But if you don't create your node pool yourself, the cloud provider would help you undo that yourself. So it is always better to just undo the creation of your node pool yourself and manage what you would like to be part of the configuration of your node pool and what you wouldn't like to be part of the configuration of your node pool. Like, for example, what kind of machine type do you want? Because like I've already said, it's also virtual machines. So what kind of machine do you want? Because NO standard is like a default, but do you want something bigger than that? If your workload is really huge, do you want something bigger than standard 1? Do you want something lower than that? You can match things like that here. And then this is the provider configuration that tells Terraform where to find, that tells Terraform the provider to use, and also the provider also how to connect to your cluster. You have the TF file. This is just for managing. These are for managing variables, and then you have this create directory where you have to be your service account files, as the case may be. So that's all for me. This is the app. See, it works and everything is cool. Thank you very much. That's the end of my presentation. I hope you were able to learn one or two things. If you have any questions, please don't hesitate to ask in the chat. I would be glad to respond to them. Thank you.
Thank you. I'm going to move quickly along to the next one so we can keep on schedule. See, as I quickly skim the chat to see if there's anything I need to address in this moment. And nothing that I cannot handle after I start the next one. Well, I'm not starting the next one. Pradeep is here, actually. Let me upgrade him to a panelist. Okay, it'll take him 1 second to rejoin.
Hi, Kitty, can you hear me?
I can. How are you?
Yeah, I'm doing good.
Good, I'm glad to hear. Thanks for being here today.
My pleasure. So let me just start my video. Hey, can you hear me well?
Yeah, nice virtual background.
Yeah, thanks. Okay, so.
So while you're getting your slides pull up, I can let everyone know that you are here to give a talk entitled, Hey Terraform, Build Me GCP Infrastructure.
Sure. Let me know if you are able to see my screen.
I do. Yes, I see your web browser right now.
Yeah, okay. Can you, okay, cool. Just checking that you're able to see the correct. So you're able to see my slides, right?
No, so right now I just see Google's home landing page.
Okay. Now?
Correct. Yep, I see your slides now.
Cool.
All right, thank you.
Okay. Hello, everyone. Thanks for joining this talk. I hope everyone is sound and safe at home. Today, I'm going to talk about Terraform and how it helps to build infrastructure on GCP. And I'll do a quick demo to create some resources on GCP using Terraform. Quickly about me, I'm an IT consultant with more than 8 years of experience. My expertise is in big data, cloud, particularly in GCP and AWS, and come from the DevOps background. And recently, become a GD in cloud and Google Cloud authorized trainer. Also, I write some blogs, which you can find on my blog website, pbhadani.com. The services cloud native technologies provides like big data cloud and any tailored trainings or workshop in DevOps or cloud. So let's quickly see through the agenda. In this talk, I'm going to talk about the Terraform, give its introduction, how the life cycle of Terraform looks like, and quick commands to how to set up your own laptop or workstation to run Terraform and interact with Google APIs, and a demo afterwards. So Terraform is an open source tool, open source by HashiCorp. It allows to build, change, and version of infrastructure like we do version or change our Java or Python code. It's allows us to manage the whole infrastructure. Maybe it's on the cloud or let's say GitHub or somewhere in a very efficient way. Terraform.io is the official website for Terraform, and all the latest information and documents are there. I'd recommend always to look at Terraform.io for the latest updates. Let's quickly walk through the what Terraform provides us. So Terraform is a tool which follows the infrastructure as a code principle, which means like we define all the infrastructure in a code template. And then if we want to change it, create it, delete it, we do via code. Everything is done via the code. It also manages the state of the infrastructure in a state file and do all these CRUD operation on it. It can infer the dependencies between the resources. When I say infer the dependencies, which means, for example, my Terraform code is going to create 2 virtual machines and put a load balancer ahead in front of it. Terraform can automatically detect that before joining the 2 VMs to a load balancer, I need to have the 2 VMs up, load balancer up, and then make a connection. Or another example could be if I want to create a Google Cloud Storage bucket and then put a object in it, then Terraform can detect, okay, it has to first create the Google Cloud Storage bucket, then create the object within the bucket. When we, after we write a code, we can run a plan which lists us what Terraform is going to do with this code, whether it is going to create few resources or destroy it or update it or a mix of these 3 operations. So that's it. So it gives like a nice execution plan, and all the resources we can view in a graphical graph way, that which resources depends on what. So the dependencies can be viewed as a graph. Terraform tries to interact with the APIs, for example, Google APIs or AWS APIs in a parallel, so that it can create the resources in parallel as much as it can. Here are a few Terraform concepts which I want you to want to make some familiarity with it. So Terraform provides us as a allows us to interact with the API and handle the authentication. For example, if I want to create a resource on GCP, Terraform GCP provider will handle all the API interaction and the authentication to allow me to run or create any resources on the GCP. Resource is a fundamental concept in Terraform. Resource, which means like an object I want to create or an infrastructure object I want to create on maybe on a cloud or using some provider. For example, a VM instance could be a resource, or a GCS bucket could be a resource. If I'm managing a GitHub repository, a repository could be a resource. Then all these resources can be grouped in a way which describes our infrastructure architecture, and that is called as a module. And a module helps to build the infrastructure as a whole and can be reused over and over by different teams or by different people within the teams. Data source allows to read the object properties which are already there in the cloud. For example, there is a VPC network which is already created by maybe a gcloud command or by some other script or manually, and I want to have that network URL in my Terraform code. So instead of hard coding or running gcloud command to get it, I can use the Terraform data source to read the network properties and get me the URL. So whenever there is change in the network properties, Terraform will automatically get the latest value when I run Terraform plan. And it's, as I mentioned, it stores all the information about what it is going to create or what it has created in a state file that's called Terraform state file. And there are two types of state file. One is local and another is remote. A local state file lives on your local workstation from where you are running a Terraform. So that's okay when we want to just get started with the Terraform, but it's not a good practice to have a local state file when we are working within the team or in a production environment. Because once you lose the local state file, the resources which you created with the Terraform becomes off and you can't manage them anymore. That's why we have a remote state file, which could live on like cloud storage, like a GCS or S3 or on console, so that whenever we want, whenever I run a Terraform, it can read the state file from a remote backend, get the latest copy, and then understand what the code should do. And in this way, as the storage, as the remote state lives in the remote storage, this can be shared easily with the teams or among different people. The benefit comes, there are a lot of benefits from the Terraform. I'm just going to talk about few. So the Terraform and the Terraform modules allows us to reuse the code over and over, so that helps us to build the infrastructure in a very quick way. For example, if I have written a Terraform code to create 1 or 2 VM instances, and if someone wants to create similar pattern, like he or she can just copy the same code or reuse the same code. And if I package that in a module for a particular infrastructure diagram or infrastructure architecture, another team, if they need the similar architecture, they can just call the module and build the infrastructure very quickly. So initial code base might take some time, but once you have some code base, it can be reused very easily. Also, once the resources are created by Terraform, it can be managed in a very easy manner. For example, if I've created a VM instance using a Terraform with 2 tags, and now I want to add 2 more tags, those can be done easily. If I want to change a subnetwork, those can be done easily with the Terraform. We just need to run few commands, and like Terraform will see those Terraform lifecycle commands. We just need to run those commands, and Terraform is going to take care of all those stuff. Also, as we are going to use like doing a lot of code reuse, and also like we can build the infrastructure quickly and destroy it quickly, which means we can bring the infrastructure on demand. That leads us to save the cost. And also it gives the consistent environment all the time we are running the same code base. So Terraform lifecycle runs is a 4-stage lifecycle. It's a pretty straightforward. First is initialization. We can do using Terraform init. What it does is it install all the dependencies like the provider libraries, the plugins, and etc., and make the remote backend connection, etc., and good to go. Once the initialization has been done and we have a code base, we can just run Terraform plan, and it will list out the execution plan, what it is going to do. Once we are happy with the plan, we can run Terraform apply, which will make Terraform to start interact with the cloud APIs and create the infrastructure on the cloud. And when we no longer need the infrastructure, we can just run Terraform destroy, and the whole set of infrastructure which is created by the Terraform code in a particular directory will be destroyed. To set up Terraform, it's very easy on the Mac. I just need to do like a pre-install Terraform, and it is going to install the latest Terraform libraries. I have a blog which illustrate like how to install on the Linux. Also, those steps are here in the slides as well. Just need to get the library and put in a system path, and we are good to go. For particular this talk, I'm going to interact with the Google Cloud. So we need to have a G Cloud setup on the workstation. There is also another blog which lists out all the steps in a detail and explains how to install a G Cloud. But these are the 3 common steps to install G Cloud on your workstation. Let's move to a demo. where I'll quickly show how to create a resource. In this demo, I'm going to show like how to create a Google Cloud Storage bucket using Terraform and get you familiar with the Terraform code base. The code already lives in the GitHub, so you can. I'll share all these links. So it's on the GitHub under the name GDG Terraform GCP Workshop. I have 4 examples. In this demo, I'm going to go over first and second example to get familiar with the Terraform and its variable. So I have already cloned all these this repository in my local system. So I'm going to go on the 01 basic and main.tf. So in Terraform, within one directory, we can define multiple .tf file, and Terraform will combine all those TF file in one big TF file and draw that execution plan. This part where we say provider, we provide a provider named Google. As in this example, I'm going to interact with the GCP, so I'm providing Google. But if you want to interact with AWS, you provide AWS and the required properties for the provider to make the connection with that provider. For Google, we need to provide like which project I'm going to interact with GCP project and which region I should use as a default. So just need to provide our the valid project name where you have access to it. So in my case, let me get my project ID. So I'm going to just paste my project ID, which is workshop demo something, and I'll just keep the region as Europe West 2. In this example, once the connection is set, I'm telling Terraform to give me a Google storage bucket. This is the resource name I want to put within the code. And this is the bucket name I want to have on the Google. As the GCS bucket should be unique, probably I can't use my GCS bucket because probably it has been taken by someone. So let me just give some name, maybe HashiTalk demo 2020, and just leave location as Europe West 2. Before I run this Terraform code, I'll just quickly run gsutil command to show like what all buckets I already have. So if I run a gsutil ls, I can only see one bucket, which is workshop demo something. I don't have any bucket with the name HashiTalk demo 2020. So going through the life cycle, the first step is Terraform init. Going to run, or let me just do a full screen, Terraform init. Okay, sorry, I'm not in the correct directory. I just need to be in the directory. Going to do Terraform init. So we see it is started initializing the backend. In this example, I have not defined a remote backend. So it is going to initialize the local backend. Then the providers and plugin. It infers that I'm using Google providers. So it will download the Google provider libraries and it tells which version the Terraform is downloading. And at the end, it will print out the message that Terraform successfully initialized. If there are any errors, it will print out the errors here. Now, the second step is Terraform plan. So when I run Terraform plan, it's reading the main.tf and inferring what the code wants to create. As this is a fresh code, I don't have a current state file, or a state file is empty, by which Terraform knows that whatever the resources has been defined in the code base, Terraform has to create those resources. So it can infer all these things. And if third stage is Terraform apply. Again, when I run a Terraform apply, it is going to produce a plan and tell me whether I want to continue or not. But still, it gives the plan in this stage, but still I suggest people or users of Terraform users to still run Terraform plans and not directly run Terraform apply, because by mistake, if you run yes or something, it is going to do start its job. So when I say yes, it says, okay, it is going to create the bucket, and after a few seconds, it has created the bucket. So let me quickly run the gsutil command and see if I have the bucket. Okay, I can see that bucket now. And if I do ls, I can see this Terraform state file, which is the local state file. If I just do Terraform state file, it store all the properties in the state file. It is not advisable to update the state file manually outside Terraform code base. As I mentioned, it also handles the changes. For example, if I say that I want to create a bucket, I want to just change a bucket name, for example. In Google, there is no way to rename a bucket, so it should destroy and recreate a new bucket. So if I just do Terraform plan again, so it says that, okay, it is going to replace this, and the replacement comes from here. This bit, this name is changed from HashiTalk Demo 2020 to HashiTalk Demo 2021, and which is making a forced replacement because there's no way to just rename the bucket in GCP. So if I just do Terraform apply and just say yes, it will destroy the HashiTalk Demo 2020 bucket and then create a new bucket with the name HashiTalk Demo 2021. So let me just run gsutil command. And I can see now HashiCorp demo 2021, not 2020. Once I no longer need these infrastructure resources or anything, I can just run Terraform destroy. Sorry, my bad. There was a typo, Terraform destroy. It will again print a plan. What Terraform destroy is going to do, it's saying that it will destroy this bucket and these are the bucket properties. So if I'm happy, if I want to really delete it, I will just say yes. And says, okay, destroy complete. Just to check, I can run again gsutil ls, and okay, I don't see the bucket with the name HashiTalk demo 2021. So this should give us sense that how it's easy to manage the resources. So imagine if you want like a few number of buckets, I can just use like count is equals to, for example, if I need like 2 bucket, I can just say like count is equals to 2, which means it is going to run this block 2 times. And I can just amend the count dot index so that it has the unique name. So if I run Terraform plan now, so we can see it is going to create 2 bucket, HashiTalk demo 2020, HashiTalk demo 2021. For example, if for some cases you need 10 bucket, just need to update this count to 10. And if I run Terraform plan, we can see it is going to create all the buckets from 0 to like 9. So 10 buckets it will create. I'm not going to create, I'm just showing the execution plan. And if I run Terraform apply, it will actually create all these buckets. Now, everywhere we are using all these hard-coded names, so which is okay to get started, but in a real projects, we can't use all these hard-coded values everywhere. So that's why Terraform provides a way to variabilize stuff. And I'll come to the variables, but before jump that, if you see here, I had like a main.tf in a one single file. I had all the codes, and in this example, I'm just splitting the code into 3 different TF files, just to show that the Terraform is going to merge all these files when I run Terraform plan and go through all the code. So in provider.tf, I'm just putting the provider and I'm passing the project value and the region value as a variable. To define a variable, you could define in any TF files. I have generally put like a variables.tf file. I just say variable and the variable name. It's good to put a description because if someone else is reading your code base, it's quickly helps to know okay what this variable is about. It also helps to generate a nice documentation. The type of the variable, and if I want to put any default value, I can just put it. These value can be we can override in the Terraform TF file. To pass all these values, we can either pass by CLI, which is okay if you have only 1 or 2 variables, but let's say we have 10 or 15 variables. Passing all these 10, 15 variables from a CLI would be cumbersome. So we can define all these variables in a file with extension called tfvars. So for example, if I pass the project ID, the one I used here, I can just paste here, and when Terraform runs it, wherever I'm doing var.project ID, it is going to fill this value. It will, this will here, and for var.region, I'm not defining anything here, so it will take the default Europe West 2. So let's go back to this example directory. Again, I'll do like Terraform init, because this is another directory, which means another different Terraform project. It will download all the required plugins and everything. Once it is done, I can just say Terraform plan. A similar example, it will create a bucket, and we can see the location is taking Europe West 2. The name is taking, I'm saying the name would be my project ID and just append a bucket. So it is inferring that name. Now let's see if I just put a region as, if I want to override the region as, for example, Europe West 1, and now run a Terraform plan, and we should see the difference. And we can see that, okay, it's Europe West 1 now. The location would be Europe West 1. And again, if I just do Terraform apply, it will create the bucket. So it started to create a bucket. If the name already exists, it will say, okay, the bucket already exists, and it will fail. Now, if I do gsutil ls, I can see my bucket. And if I don't need this bucket, I can just do Terraform destroy and just say yes. There are a couple of more examples which you can explore in your free time. I'm just covering these two initial example to give a feel like how the Terraform helps us to interact with the cloud providers easily and manage all these resources in a very nice way. So that's all for, I think, the presentation. If there are any questions, I can take the questions. Now, if you have some questions later on, you can reach me on different social media platform, LinkedIn, GitHub, or Twitter, or you can follow the blogs. I try to write some blogs around GCP and cloud, so you can follow me there. Let me see if there are any questions on YouTube. Are there any questions, Katie, you see?
Thanks, Pradeep. I do not right now, but
Sorry,
I do.
I can't hear you.
Can you hear me now?
No.
Hello? Rosemary, do you hear me?
Yeah, I can hear you. Can you hear me?
Yes. Pradeep can't hear me though, so I wonder what's going on.
Let me check my audio. Just give me a minute.
All good.
Hello. Yeah, I can hear you now.
Awesome. Cool.
Awesome. Cool.
Right. Yeah, today has been a few little technical difficulties, but they always wind up being just fine. I'm checking the YouTube chat right now, and I don't see any outstanding questions for you, but I do encourage you to go hang out there for a bit in case anyone has any for you.
Sure.
Thank you for your talk.
Okay. Thanks for having me here. It was a really nice experience.
Thank you. I'm pleased to hear that, and I'm sure that I'll connect with you soon.
Sure. Just bye.
Bye. Hey, Rosemary.
Hello.
Hello. How are you today? Good morning.
I know. Good evening for everybody. Is it? I guess technically it's evening, right?
So it's afternoon right now.
Okay.
Yeah, so in West Africa time right now, it's 3 p.m. and then East Africa, it's 5 p.m. So
Okay.
good afternoon and good evening would work both there.
Closing out the day, huh?
Right. We do have a few more talks. For me, this is a milestone as we transition MCs because we went through Nick this morning and then me and now you. It's like the final segment. So I'm excited. We're really going through the day quickly, it feels.
I know. So many
It's also
good
maybe
talks.
all the coffee I've had.
Oh.
Maybe that's why it feels like it's going so quickly. Well, Rosemary, do you want to play Nicole's talk?
Yeah, so next up we have Nicole Hubbard, who's a developer advocate at HashiCorp. She's going to actually give a talk about console. I am going to share and we'll see if the playback works correctly. So let's hope that those technical difficulties don't continue.
Fingers crossed.
Okay, share. All right, let's make sure that that's actually something people can see.
I see it.
Okay, good. And then I am going to hit play.
And then maybe also hit full screen.
Okay, let me hit full screen. Let me see. Let me know if it's still full screen.
Full screen.
Excellent. And I'm going to hit play then.
Hi, everyone. So today I'm going to be talking about console and giving you an introduction to what a service mesh is. I'm Nicole Hubbard, and I'm one of the developer advocates for HashiCorp focused on console. So one of the questions I get asked the most from practitioners that I talk to is, what is a service mesh? The question that quickly gets asked after that is, why should I be using a service mesh? What will it do for me? So today we're going to take a minute to understand how we got to the point where we need service meshes, as well as what they can help you do, as well as do a demo of them. So let's start with our history of services. So when we started off deploying our applications, we started off with this clearly defined network. We have a firewall protecting our entire perimeter. All of the traffic comes in through that firewall, hits a load balancer, and from there it's routed to our 3 application servers. Those 3 application servers then talk to the database server. In some cases, you actually have an additional firewall between your web service and your database to help ensure that only the web servers can talk to the database. And so there's no additional ingress points to our application. There's only one way in. There's only one set of things talking to the database. It's very simple, it's very easy to understand, and very easy to secure. So when we started with this deployment approach, we were deploying monoliths. And so in this case, we have a service that's actually made up of 4 different subsystems. And so when these subsystems, like for example, subsystem A needs to talk to B, which could be potentially your ordering system needs to talk to your payment subsystem. They just are able to communicate over function calls in memory. They don't have to understand where the other service lives because they're all part of the same service. But as we've grown and we've started to break all of these systems into microservices, we now are actually deploying all of these systems independently. They're running independently, and it creates some new problems with the communication between these systems. So now, when service A wants to talk to service B, or like we mentioned earlier, or ordering system talking to the payment system, how does service A find where service B is? How do they communicate? How does that process get started? And so what happens is we typically configure an IP address or something. But then what happens when we add additional instances of B? Do we go back? Do we update the config in service A on how to talk to the payment system in this case? No, generally that's a lot of additional overhead and doesn't allow us to scale our applications. So what happens in a lot of cases is we'll add a load balancer. And this load balancer gives us a single point. We can give it a DNS name, for instance, that points to the IP for the load balancer, or we can assign it a static IP. And then we just point all of the traffic, in this case for our payment service, to that load balancer. And as our instances scale, the load balancer can send the requests to the new instances. And this works, but it comes with some downsides. we're increasing the infrastructure that we have to maintain. We now also have an additional network hop in all of that traffic. So the traffic coming from our order system now has to go to the load balancer and then to our payment service instead of talking directly to the service. And then also an increased cost in our infrastructure because now we also have to run this load balancer. And in some cases, this load balancer can be a single point of failure for us, where if that load balancer goes offline, we no longer can communicate with all of the services behind it. And so if we look again at our traditional data center, where we have this set up, and then we start looking at what a modern data center looks like, we can see that we've started to add additional things. So we've still got our traditional data center here on the left, but now we've extended this potentially into new hardware in our own data center, into a cloud, or any other systems. And so, but in our new environment, we're running Kubernetes. And we've got our own database server over there, key value servers. The database servers need to be able to communicate to one another. Our old web servers still need to be able to talk to the database. Our Kubernetes applications need to still be able to talk to the old database as well as the new database and key value store. And we start to add more and more rules that we have to define on all of our firewalls to protect our environments. And so this gets harder to maintain as we grow. And we're having to rely on networking potentially to actually go in and make those changes for us, because there's a lot of times as software engineers, we don't have access to those systems and to the ability to maintain them. And with Kubernetes, this gets even harder as you're scaling out. And so as you start to grow your infrastructure and have more and more microservices, you start to run into three main challenges. And those are how your services are going to talk to one another, how you're going to limit communication between services, and how you're going to configure the services so that they can communicate and they can be adjusted in real time on the network as changes need to happen. So let's start with service discovery and the other important piece to that, the registry of your services. And so in our case here, we've got our service A and service B. And service B is starting and it's going to register itself with the service registry. And so now the service registry knows that service B is available at these three IP addresses. And so when service A wants to talk to service B, service A is able to ask the registry, hey, where can I find service B? The registry then returns, hey, B, you can talk to B at 1.2.3.4. That's just one of the three addresses, but it's the one that was returned. So then we're able to see that service A can connect directly to service B, and there's nothing in the middle for the communication. And so that full process involves registering, discovering, and connecting. And this is one of the pieces that you get using a service registry and service discovery. And it will make up the beginning of our service mesh for us. So the next piece is service segmentation, which is how do we limit what services can communicate with one another? And so in our previous example with the monolith application, we had our load balancer coming in, we had our monolith application that received that request and then talked to different subsystems within the same application. And then those applications had to make calls back out to the database. We were able to hard code the database with a static IP. We used a firewall between the application and the database. We also had a firewall between the load balancer and internet, or our internal network that accessed our application, and the service to help protect the service. But as we've moved to microservices, where all of these services need to be able to communicate, but sometimes not always. So we have a bunch of disjointed systems that have different requirements to communicate. So as we can see, A needs to communicate with B, C and D need to both be able to communicate with one another. And then we have a case of A needs to be able to communicate with C and B needs to be able to communicate with D. But there's cases where the applications don't have to talk, like A and D have no communication requirements and B and C have no communication requirements. So we don't want to allow those services to communicate with one another. And so as you start to define these, it gets pretty easy to do it with 4 microservices, but what happens when you have thousands? We work with some customers who have upwards of 4,000 microservices that they're managing intentions between and trying to limit which applications can communicate with one another. And so as you grow, you need a way to programmatically define these rather than trying to create networking rules or VLANs or ACLs or anything along those lines. And so this is where our intentions can come into help. And so the next piece is service configuration. And so when we're running our services, we need them to be able to communicate securely. And so one of the first pieces to that is configuring a certificate authority. And so this will be another one of the key pieces to our service mesh. And so what happens is we generate certificates for all of our applications that are running. These are automatically generated, they're automatically rotated, and these are the same X509 certificates that are used by websites and all traffic that's secured over the internet for web traffic. And so this allows us to start to think of our network as a zero trust network, and we're able to secure all of the communications between our applications without making changes to our application, just by leveraging our service mesh. And so these certificates allow us to both encrypt the data to secure it, as well as provide identity. Since all of the certificates are generated by us and generated by our own certificate authority, we're able to concretely say that this service, who's identifying itself with this certificate, is indeed who it says it is. And so now that we have all of these pieces, we can actually start with our service mesh. And so one of the big things with service mesh is there's 2 different components to it. There's the control plane and the data plane. And so when you're running your applications and your applications are communicating with one another, all of that remains in the data plane. It never goes into the control plane. Your traffic is never routed for applications into the control plane. And so these rules are defined in the control plane though. So in this case, we're using console for our control plane, and we're going to use Envoy as our data plane proxy to actually move all of the traffic. And all of our nodes have a console client running on them. And this will actually cache all of the rules for our environment so that those requests aren't having to ever leave the local machine we're running on. And as changes happen, they're pulled down. And only the instructions that are needed are actually saved per machine. So the next piece is being able to actually limit that communication between services. And so console does this with what are called intentions. So here you can see the first thing we're going to do is we're going to create an intention, and we're going to deny the ability for our web server to talk to anything. And so now our web server can't access any of our other services. And then the next thing we're going to do is we're going to come in and we're going to create a new rule that says our web server can talk to our database server. Now, these rules will apply no matter what server our web service is running on. We can migrate it between servers because these rules are based on the service, not the location of a running process. And so as long as our service is defined, and when we move it and we don't change the service definition, those same rules will continue to apply. So we could actually run our web service in multiple clusters that are connected together with console, and all of the same intentions will apply. Also, the intentions are defined with the most specific intention applying first and the least specific applying next. So in the case of the web server trying to communicate with the database, we have a specific rule that says that that's allowed, so it's allowed. And then anything else, there's no specific rules for, so it'll fall back to our web say anything rule and get denied. We can also manage these intentions in a single UI. So in one UI, we can actually come and we can actually see all of our rules on what communication is allowed. And so from here, we can create deny rules, we can create allow rules, We can even create rules that say, a default deny all so that no communication can happen within our cluster. And then we have, how do we integrate this with our application? So you're probably thinking, what do I have to change to actually be able to use this? Is this going to take a lot of development work, or is it easy? And the good news is this is very simple to add. For the most part, this doesn't really require any changes to your application directly. What happens is we will deploy a proxy that will run right next to your application, and it will handle all of this traffic for you. So you don't have to change anything in your code. The only thing that has to change is the endpoint that you talk to get to the database in this case. So instead of your web server knowing the direct path or URI to your database, instead it will talk to something on localhost and a port that the proxy is listening on, and that proxy will then pass that information wrapped in the TLS, and the intentions will apply. So in this case, we're going to deploy this into Kubernetes. And to make it easy for you, we provide a console Helm chart to help you get started. And one component of our Kubernetes deployment is a connect injection. Connect is what we refer to as our service mesh functionality that allows secure communication between services. And so all we have to do is add this annotation that says console.hashicorp.com/connectinject is true. And this will automatically add that sidecar proxy for us without us having to do it. And so when we deploy this, what happens is now we've got our web server running on one server with the proxy and the console client running. And then we've got our database service running somewhere else on some other server, maybe inside of Kubernetes, maybe on hardware. And then it's got its proxy server and its console client. And so when our web server needs to communicate with the database, what happens first is the web server opens that connection to its local proxy on a localhost port, and the proxy will go out and do the service discovery we talked about. And it will ask its local console client, hey, where's the database that I need to talk to? The console client's going to look at all the information it has cached, and it's going to say, hey, the database is over here, this is the address for it. And then the proxy will open a TLS handshake connection to the proxy server for the database. And then what's going to, wrong way, there we go. And then what's going to happen is the console client is going to get asked by the proxy for the database, hey, is the web service authorized to talk to me? I'm the database service, by the way. And in this case, we've created the intention so that that is allowed. And so the console client's going to respond with yes, at which point the TLS connection will be established. Had it been a service that's not authorized to talk to the database, the console client would have returned no, and the TLS connection would have been immediately terminated. So what are some of the extra benefits we can get with this? So one thing you can do is you can also configure mesh gateways. And so mesh gateways allow you to extend your service mesh across multiple clusters or into multiple environments that aren't Kubernetes clusters and are just a case of a bunch of VMs in another provider or your own on-prem data center. And the really cool advantage to mesh gateways is they can also start to solve overlapping IP problems. So in this case, our API and our web service is running in one data center and our database is in another data center. And both of these data centers are using 10.8.1.1/24 IP ranges. And so normally in the networking world, this is really hard to solve. You have to create all sorts of rules to be able to join together two networks that have the same IP space. But when we add the mesh gateways in, the mesh gateways communicate over any connection they have available to them. So it can be the public internet, it can be another VLAN, a VPN, whatever you have that's connecting these, it can use. And then your API service just talks to your local mesh gateway. It does natting effectively, and forwards that request to the next mesh gateway. And then the mesh gateway there will send it over to the database, and the response is returned through the mesh gateways so that all of your overlapping IPs are handled for you. And so the mesh gateways, they're built upon Envoy still, and these handle all of that for you. And the really cool part about these is when you're deploying them, they become the only point that you have to expose to the internet to allow communications between your services across different cloud environments or data center environments. And so now, instead of having to create rules in your firewall to allow all of the services to be accessed by all the other services, you only have to create a rule to expose this mesh gateway directly, and that's it. And you can even limit that rule to only allow communication from your other mesh gateways to secure it even further. And so another advantage you can get is layer 7 traffic management. And so with this, we are able to, in a standard layer 4 environment, traffic comes in for web.service.console, and it gets forwarded to our 3 instances of our web service. But with layer 7, we're able to actually change the way that traffic works. And so the first thing we can do is we can change the routing of that traffic. And then after we change the routing, we can also do traffic splitting, and then we can do custom resolution. So what does that look like? So in the case of HTTP routing, we can say if a request comes in that's web.service.console/API, instead of routing that to our web service, route that to our API service and strip this /API path so that it's just / for the path when it hits the API service. And so now we're going to send our API traffic to our APIs services. And then let's say we've developed our API, we've got version 1 deployed, and now we have version 2. And we want some of our traffic to go to version 2. We can now create what's referred to as a subset for V2, and we can actually send just say 80% of the traffic to V1 and 20% to V2 so that we can start testing V2. And this allows you to start doing things like canary deployments and blue-green deployments with limited rollover at the time. And then you also have custom resolution. And so we created this subset known as V2. And so custom resolution informs the routing here, how it defines what version 2 is. And so in this case, we're going to look for some metadata we've configured that is meta.version equals 2. And so we define that on our service. So now let's take a look at how some of this actually works in a demo environment. So here, what we have is, I've just got a really simple application we're going to deploy. It's got a dashboard so that we can hit the UI for it. And then we've got a counting service that will provide a count as to how many services have accessed it. And so to get started, what we're going to do is deploy our Helm console chart, which we've pulled down from the public HashiCorp repo that's console Helm, which is that folder we have right here. And so to do that, we just do Helm. Before we do that, let's take a look at these values though. So there's a values file, and this allows us to change the default settings. So in this case, we're changing the data center from the default to Nicole Lab. And then we're going to change our server so that we're only running one replica of this server, and the bootstrap will only expect one instance. And then we're going to enable that connect inject that I talked about earlier so that we can automatically add our sidecars proxies. So now we can do a Helm install console, and we'll give it this values file, and then we'll give it our console Helm chart. So this will go through, and this will install for us, and now we can see we are running with our cluster. So if we check out Kubernetes now, we can see that we've got our console server running, we've got our console connect inject running, and we've got our console client running as well. And so I have k alias to kube control. So this is the same as if we were to run kube control. So there's nothing fancy or special about that. So now that we've deployed that, we can take a look. If we always forget the shortcut for this. Yeah, new tab. All right, so now we can go, let's go ahead and create a port forward. But first, let's get our service. And so we can see we have our UI service here and it's listening on port 80. So let's go ahead and open a port forward to this service. And it's port 80 and we'll forward it to port 8080 locally for us. Oh, no, that was backwards. I mix those up sometimes. All right, so now we can see we're forwarding localhost 8080 to our console server so that we can actually communicate with it. So if we come over here and we actually access localhost 8080, we can see we now have our console server running. We've got one service. Our data center is console lab, and we can see we've got our nodes, and we can see we don't have any intentions at this time. And so now if we come back over here, we can come over here and we can deploy let's deploy our dashboard service. So if we take a look at the dashboard, this is a very simple YAML deployment for us. So the first thing we're going to do is deploy a pod. Its name is dashboard. It's got a simple label. We're going to enable the connect inject true. And we're going to also tell the proxy that we want the service to be able to communicate with counting on port 9001. So this will open something for us on the dashboard pods on localhost 9001 that forwards to our counting service. And so we're going to run the dashboard service on 9002. And we can see that we're specifying that the counting service URL will be localhost 9001. And then we just define a service so that we can actually expose this. It's port 80 locally that goes to 9002, and it's just a very simple load balancer service. So we can apply this now. And if we look at our pods, we can see that the dashboard now is doing an init container, which we didn't specify an init container, so what could that be? And we can see now that the dashboard's running, and there's a total of 3 containers running. So what are those? So let's take a look at our dashboard pod. And we can actually see in all of this that we have a couple of different containers running. If we get all the way up here. So we can see we had an init container added. That's our console connect inject init container. So this handles setting up our sidecar proxy for us. And it's the script that runs, it gets all of this information. All of this was defined automatically just by adding that one line. Then we've got our containers. So here's our dashboard container, which is our dashboard service that we defined. And then we can see that we have a console connect envoy sidecar container running, which is running envoy for us and is our sidecar. And we can see that we're also running somewhere a console connect lifecycle sidecar. So those are now 3 containers when we only defined the one. And so now if we come back over here and look, we can see we have our dashboard service registered as well as the sidecar proxy. And so now let's go ahead and deploy our counting service, which looks very much the same. We create the service count for it. We create the pod. Since we're not accessing this directly and we're only ever going to communicate with this service through the console connect network, we don't define a load balancer or a service in Kubernetes for this. And since the counting service doesn't talk to anything, we're not defining any upstreams. We're only enabling the proxy. So we can go ahead and apply this now. And we can see here, as these start, they will register. So now we can see we have our counting sidecar proxy, and we have our counting and we can actually see this one's not entirely online and hasn't passed all of the health checks yet. Now it has, and we can see that now we're able to use both of these services. And so if we come over here and we actually port forward, let's get that service first. So we can get our dashboard service load balancer right there. And we can port forward. Oh, need a dash. Oh, wait, that wasn't what we wanted. Since we're doing it to the service, we have to find that. And then this will be port 80, and we'll forward this to 9090. And of course, I did it backwards again. All right, so now we can access 9090 locally. And we're able to see, here's our counting service running, and we've actually communicated with our backend counting service once. Now it's been communicated with 4 times, 6 times. There's health checks. This service actually runs, so those counts get increased. So that's why they increase more often. But now if we come in here and we create a new intention and we say, don't allow any services to communicate with anything by default. Let's call this just default deny, and we save it. So now we have now blocked all access between services. And if we come back over here, we can see when we refresh that now the counting service is unreachable. So we have now effectively disabled the ability for our services to communicate without specific intentions being created for them. So now if we come over here and we say, let's go ahead and allow traffic from the dashboard to the counting service, and we save it. So now we have this rule, and we come back over here and we refresh. We're able to see, now we're able to connect again, and everything is allowing communication to flow between these without any problems. And so just like that, we've been able to create firewall rules that allow this, and these apply pretty much instantly. So if we delete this intention, as quickly as I can come back, before I could even refresh it, the dashboard had already realized it lost the counting service. So these apply across your network in real time, no matter where your applications are running, and allow you to do amazing things with that. And so, there we go. And so I'd like to thank you for taking the time to learn more about how console service mesh works, as well as how service mesh works in general. And hopefully you're able to take this and apply it to help secure communications between your applications, as well as help you do things like blue-green deployments or canary deployments. Thanks.
Alrighty, so thank you to Nicole for talking a little bit about console, and we also have Nicole on chat, so if you have any lingering questions, you can feel free to ask. I'm sure she'll be happy to answer them. Especially, I see some great chat going on, asking about Kubernetes and sidecar and some of the proxy stuff. So definitely drop a note in chat if you're interested. All right, so the next person we have up is Samuel. Sorry, Samson. No, hold on. Yeah, there we go, Samuel. Sorry, schedule's a little messed up today, but Samuel is going to talk about testing infrastructure as code on localhost. It's a fun topic. I really enjoy trying to test infrastructure as code on localhost, so I'm curious to learn more. Samuel enjoys exploring new technologies and loves cycling, and we're actually going to do a playback once again. So hopefully the technical difficulties do not persist, but I'm going to give it a try one more time and we'll see what happens. All right.
Rosemary, I'm not hearing anything, but maybe there's a lag.
One second. Let me try this. one more time. All right.
Story of my life.
Let me see if I can maybe share computer sound, optimize for screen share for video clip. Let me just share this again. Start from the beginning. All right, let's try this one more time.
Hello, everyone.
How's that audio?
It's a pleasure to talk to you and present to you on this virtual meetup. So this is a pre-recorded talk, but I'm available when it's running to take your questions and engage on the topic that I'm discussing. So my name is Samuel Kihahu. I currently work as a DevOps engineer at a company called Tala. Tala is a financial services company that whose mission is to provide financial access, choice, and control for the underserved in the society. We are currently based in 4 countries: Kenya, where I'm based, India, Philippines, and Mexico. So I'm going to be talking to you today about testing infrastructure as code on your local host. And the agenda for this talk is on why you would choose to test on localhost, what kind of tests that can you write, what tools you can use, how you can use those tools, and what lessons we've learned as we've worked with this workflow. So why test on localhost? So one of the reasons that would put across is the speed. When you're testing on your local machine, you don't have to work with the lag of a request going all the way to the cloud and coming back to your machine. You're able to iterate faster with your changes and fix issues quickly. Another reason is on cost. It's simply free. You just have to work with the machine resources that you have with you. Another reason is the convenience that you get because you're working with an environment that you're familiar with. So if you run into issues, you're able to easily troubleshoot and get the root cause. Another reason I would put is fail-safe. You're not afraid to experiment and break things because you're actually not interacting with the cloud when you're testing locally, and you're able to validate the changes before you eventually push them out to an actual cloud environment without fear. So for us, when we were exploring this workflow, we chose two tools. One is a Go library called TerraTest. And the reason why we chose TerraTest is we previously used a tool open sourced by the same organization that released open sourced TerraTest called Grantwork. And we had a good experience with it. A colleague of mine had used it to manage part of our infrastructure as code, and we were confident to use it for another of their tool for another project. Another thing we discovered as we were getting into we were evaluating the tools is we realized that it not only supports testing Terraform, but you can actually test other tools like Kubernetes, Helm, Docker, even Packer. So we could leverage the learnings that we would get from testing Terraform code into other tests that we would write for other components. For local stack, this was simply because our current production workloads run on the AWS cloud, and local stack supports AWS cloud. What tests can you write? So for the particular project that I'm describing, we chose to write 2 kinds of tests. These are unit tests, where we were testing whether individual resources could run could be created in isolation without any errors. We also wrote integration tests, where we were testing whether 1 or 2 or more components could be created together with dependencies without any error. So the project I'm describing that we used to experiment with using TerraTest and local stack was meant to allow developers to create some of the common resources that they require while doing their development. An example being SQS queues or SNS. So the complexity of the modules wasn't much. So these 2 tests were sufficient. So this is an example of a TerraTest test. So the TerraTest leverages or is built on top of Go testing package. So we inherit, we use the Go testing package whenever we are writing the code. So in the import, we'll import the package that comes with TerraTest, and then it underneath it's riding on the Go testing package. And the Go testing package supports testing in parallel. And another thing we learned, or one of the things we learned when you are writing these tests, is the need to randomize the naming of your resources, because we realize that if you name them without unique or random identifiers, it would be possible eventually when you run the tests on an actual cloud to have collisions in terms of the similar namings. TerraTest also supports, I would say, helpers that allow you to interact with the various SDKs for the cloud providers. And in this instance, since you're using AWS, you're able to get helpers like getting a random stable region. So when you create a resource, you're able to randomly choose a region from a list that's provided by TerraTest in the backend. The way you'd pass options to TerraTest and interact with Terraform is through this options tract in the Terraform package. And some of the configs that you can pass to it is the path where your Terraform code is located. So in this example here, the code is located one directory above where this test is located. You can also pass variables. So in your Terraform code, if you expect a variable, in this instance, you have a variable named name, you're able to pass that variable using this option. You're also able to pass things like environment variables. So this is an example, is this random AWS region that we got. We're able to pass it as an environment variable to the Terraform that's going to be running underneath. As I said, we chose TerraTest because of the helpers that it has. So for the Terraform package, you find it has .destroy, and we run this as a defer so that eventually it will run as the last function or method and cleans up your environment once you've finished creating your resources. We do an init. When you're running Terraform on the CLI, you do a Terraform init and then Terraform apply. But the Terraform package comes with an init and apply method that allows you to combine the two. So in the SQS Terraform code that I'm referencing here, I have an output that I expect from code as an output from that apply. So I'm able to use a SAT to validate that the naming that I gave and passed as a variable is actually what gets created as an output. So you're able to validate that the code actually does what it's meant to do. And then you're able to delete the resources. So one thing I'd mention is the Terraform package comes with these methods, but also supports so an example is this destroy. There would be an accompanying method called destroy and then capital E, which means it returns an error. So if you choose to use that method, you'd need to handle the error code that is returned if there's any issue that happens when the tests are running. So just something that you should be aware of when you're using TerraTest is that you have the option to use the error returning methods or just the methods that handle the error for you directly. And as I mentioned, since we are riding on top of the Go test package, we need to follow some of the rules for writing Go tests. So an example being following the naming convention. And as I mentioned, the file name needs to end with an undertest.go. So this is the command that you'd use to run this function. So I noticed I had two example functions. So this is testing the SNS, but if you wanted to test the SQS, you'd change SNS to SQS. On the local stack configuration, since we are leveraging or we are testing an AWS provider, would just use the normal Terraform provider, but then would need to make some changes to the options that or the configurations that we set up. So you notice I have just an access key and region here. So you have the option of setting this, and you can even just put for the access key and the secret key, any text would do. And then we skip the validation of the credentials, and we don't validate the API also. So you also need to configure the endpoint. Since you are using the local stack, we need to configure the endpoint for the service that we want. So if for SNS, so when local stack starts up, it starts multiple services running on your local host, running on different ports. That's why for SNS, we need to configure a different port. For SQS, we need to configure a different port. So there is an update in local stack where they've introduced this edge service running on port 4566, and it's supposed to proxy all traffic to other resources or services. So if this is active, you would just have edge configured, and you don't need to configure SNS or SQS. Now, currently this is not supported by the Terraform AWS provider. So there's an open issue on the GitHub repository for the Terraform AWS provider. So eventually, when that gets implemented, it will be possible to use this. So I mentioned here that when you eventually start running your tests both on localhost and also on the cloud, you might want also to use Terraform's aliases, where you are able to configure multiple similar providers, but then differentiate them using aliases. So you'd have a provider AWS, that's the default, that actually talks to the cloud, and then have a provider with an alias that will talk to a local stack. So, and you're able to pass via config inputs to determine whether you want to run the test on actual cloud or on local stack. So local stack is a Python module. You just do pip install local stack and do a local stack start. So I'll be doing a demo at the end of this presentation. Some of the lessons that we learned as we were experimenting with this workflow. So one of the lessons is that there's limitation in terms of scope when especially using local stack, because you can only be able to mock out the AWS cloud. Other providers are not, or other clouds are not supported at the moment. And even when I looked at the roadmap, I didn't see any roadmap items for supporting other cloud providers. So if you're not using AWS cloud, local stack might not meet your need. Another lesson that we learned is, as I mentioned, Terraform provider or local stack depends on the Terraform AWS provider, and they currently at the moment just provide best effort support. So that example I showed you previously of the edge service, this edge service is currently not upstreamed. So you would have to, there are some features that might not be immediately supported. Another lesson that we learned is on the limited functionality. When you use local stack, they only offer a subset of services. I've linked a link here where you can see all the services that are provided with the open source version. So they do provide a commercial local stack pro, which has more services for AWS that you can mock out. But if you're just going the open source route, there are some services that you might not be able to test using local stack. Another lesson was on the CI integration. So when we are writing our tests, and as we wrote more modules for various resources, it became necessary for us to start considering either using tags, which TerraTest supports, or using an option for shorts. This is an underlying package feature for the Go testing package. or using makefiles. So we chose for us to use makefiles, and the reason why I'm highlighting this is maybe you have, let's say, 10 tests and you just want to run a subset of those tests. When you have tagging or you're using the short option or using a makefile, you're able to choose and pick which test you want to run. So it gives you that flexibility. Another lesson is on, as I mentioned, when you eventually want to run tests both on local stack and the actual cloud, you want to start using the provider aliasing so that you're able to switch between the two. Another lesson is on a long-running test. So by default, Terra tests time out after 10 minutes. So if your tests take longer, you want to extend the default using the timeout flag, especially if you're using a CI that would be affected by a timeout of a particular set of minutes. You would want to extend this. So another thing I mentioned when I was describing the sample Terra test is on the error handling. The fact that the Terraform package comes with methods that both handle errors internally and ones that return errors, and for you to decide to handle them. So when you're writing your test, you need to decide whether you want to do the error handling yourself or to use the methods that actually handle the errors. I mentioned about using unique naming of resources so that you avoid collision. So when you're creating the resources on actual cloud and the naming is not unique, you stand the chance of erroring out because of collision of naming. Finally, there's caching. So by default, from GOP 1.10, caching is enabled by default, and it means when Terra test runs, it's not going to run the test. So you need to disable that cache if you want to run the test every time. So just a recap of the presentation. Testing locally is cost effective, is fast, is convenient, and allows you to build confidence before you eventually start running your tests on actual cloud resources. But there are limitations, and these are mostly related to cloud provider support and also functionality support. You can be able to do both local testing and testing on the cloud by leveraging Terraform's aliasing, so that you're able to switch between testing locally and testing on the cloud. Some of the references that I have is a great talk by the people who've outsourced Terra test. So there's a link to that. There's also the config for setting the aliasing that I talked about that would allow you to test between localhost and the cloud. There's also a link to the config for providers, for custom providers. And then I have a link to sample modules that I have to run or to do the demo for you with. So I'm going to switch to my terminal so that I do a demo. So as I mentioned, you start local stack by doing local stack start, and you can enable debug option if you want to see more logging. Sorry, local start. So in the background, local stack starts a Docker container. So if I do a Docker PS, I'm able to see there's a local stack container running. So if I just navigate to my repository, so this is this is what is I linked on the last presentation, where you can go to my GitHub and access this code. So this is a simple code that just creates resources for SQS and SNS. And I've created a tests folder, and inside the tests folder is where I have the file that has the tests. So if you just look at the file, this is what I was saying. You import from TerraTest. You're able to import various packages that it comes bundled with. So this is the example I had for testing SQS. And as I mentioned, it's running in parallel. These are randomly named name. These are random region. And there's also the options that I passed to Terraform. So I'm going to run this example, and the way I would run it is go test run SQS. So as this runs, just a reminder that if your tests are taking more than 10 minutes, it's going to air out. So you might consider adding the timeout flag here. So you can see right now we are creating the resource, and you can actually see these are the outputs. These are the outputs that the module creates. So maybe let me just show you what is inside SQS file. So it's just a simple module that inherits from the open source SQS module and creates a name from the input that I provide. And this is provided from the TerraTest code that I have. Yeah, so that's the end of the talk. So you can ask questions and you can chat when during the virtual meetup.
Alrighty, thank you, Samuel. That was awesome. Love the preview, the demo of a local stack and stuff. That was pretty interesting to see. So if you have any questions or if you want to follow up with Samuel, he's in the chat and he'll be available throughout the stream for questions. Now let's see who we have next. We have more panelists. Next we have Chloe, who is a HashiCorporeal. I don't actually know the correct term. A HashiCorporeal based out of the East Coast here in the United States. So Chloe today is going to talk about service as module, Terraform from architecture diagrams. And interestingly enough, Chloe, you have some interesting accessibility features in your presentation.
I do. So when my slides come up, you will see a URL on the bottom of them. But to just share that with everyone now, it is FEMOPS, FEMMEOPS.club/service-as-module. There you'll find a transcript of pretty much everything I'm about to say. So if it's harder for you to follow along with the speaking, if I talk too fast, if you want to take notes to ask questions later, you can grab the text from there. After the talk, the slides will also be up.
That's awesome. So I dropped that link into the chat on the live stream. So if you want to follow along and read along, please do. Thank you so much, Chloe, for doing that.
Awesome. Also, I am not in the chat right now, but as soon as I'm done talking, I will pop in. So I will be available for questions at the end.
Yay. All right. So I'm going to turn it over to you.
Awesome.
Feel free to share your screen.
All right. Let's see if I got this right. Still getting used to this whole world of streaming. Oh, good morning. The standard infrastructure as code conversation focuses on helping network and system engineers put their code in a format that can be stored in a repository and managed like software code. Today, I'm going to talk about extending that idea or model to treat infrastructure as code as the same as you would treat service code or software code, and to think about it in a software engineering fashion. While the ability to check code into a repo and centrally manage it is a useful evolution in how we manage systems and networks, it overlooks what I see as a benefit of infrastructure as code, which is you can start to think about infrastructure in the same way as you think about other code primitives, such as functions or methods or objects. All of these things can be combined together, and infrastructure as code gives you a way to do that. So hi, I'm Chloe, and I'm currently an infrastructure engineer at HashiCorp, but I came to infrastructure as a software engineering experienced site reliability engineer. Big mouthful. Because of this, I developed a unique set of strategies to learn what my more operations practice peers and senior engineers already knew about infra management. It feels weird to say in the traditional world, but let's say in the way people traditionally think of engineering, operating the code software engineers write has been the domain of systems operators, or sysops. With the advent of SRE, this has changed some, but too often SREs are just seen as sysops plus rather than embodying a new way of working. Infrastructure code is touted as a way to close that gap, but too often all anyone has to say about it is it lets you check code into a central repo to be managed. What I learned while learning about infrastructure as a beginning SRE was that Terraform as a tool let me think about infra in the same way I thought about code. While the ultimate output of Terraform is concrete infrastructure, one of the benefits it offers is the ability to logically group and use code to invoke that infrastructure. Terraform modules are an opportunity to introduce a layer of abstraction, and when done right, that layer of abstraction translates between an abstract view of the system and the concrete implementation of the infrastructure that makes it up. One of the places that abstract view is documented is in the architecture diagram. For that reason, throughout the rest of this talk, I will be referring to the information captured in an architecture diagram as an interface. I think of it that way because I think of interfaces in code as objects that inform conformity between concrete implementations and abstract needs. The architecture diagram is a documentation of that interface, which makes it great to use as a map while writing Terraform. All right, talking about codes and diagrams hypothetically is hard. Let's look at the HashiCorp Enterprise Architecture Diagram for the single cluster deployment of Consul. This is from the Consul deployment guide on learn.hashicorp. I chose this diagram as an example because it clearly documents each of the resources required to run Consul as a service. It describes the relationship between those resources, and it documents the specific requirements or expectations those relationships have. To look at this as an interface, Consul requires some server resources, some client resources, communication between them on various ports, and communication with the outside world. Any system built that can meet these constraints should be able to run a Consul cluster. Using this diagram as a record of the interface to meet, we can use it as a guide for writing Terraform HCL. To do that, we'll be using Terraform modules. In Terraform, a module is a collection of resources that are used together, providing an atomic way to compose infrastructure in logical groupings. This makes it the perfect way to capture the needs and requirements of a service, as it allows for a one-to-one mapping between services in production and infrastructure resources. The first step of creating a module from this diagram is making concrete decisions about what the implementations need to be. I prefer to do this on the diagram, usually by making a copy of the image I can mark up as I want. To help illustrate the technique, I am using a Consul installation on AWS. On this marked up version, the data center label has been replaced by region. I've indicated that the nodes in the Consul cluster will be EC2 instances in an auto-scaling group for resilience, which is the red outline. And I've sketched in additional disaster recovery snapshot store, which will be in S3. Since this version of the diagram didn't contain the disaster recovery infrastructure, I've added it by hand. In addition to the resources necessary for computing, creating a cluster in the AWS cloud also requires resources to represent the relationships between the various computers. When I first started managing infrastructure, I found it difficult to wrap my head around. It finally became clear to me when I went back to my object-oriented roots and reminded myself that everything is an object and an object is a resource. On this diagram, those are marked as well. The replication and gossip relationships with their listed ports, which will become security groups and rules, and IAM policies. By the end of this stage of the module's design, every object on the diagram should have some sort of terraformable infrastructure resource type associated with it. From here, composing the module at its core is about writing code to describe the diagram. Oh, a little water break. To continue using this console diagram as an example, my next step is to create a very basic Terraform setup with whatever boilerplate my project requires. In this case, I have the 3 files required by Terraform, a README, and a license file. Once that's set up, I pull up my main TF and begin writing HCL. Let me back up. I begin scaffolding in HCL. I start by working my way through the diagram and writing placeholder declarations for the Terraform resource blocks I'll need. For this console example, I'll block in the auto-scaling group that will be the console cluster and declare it with the resource blocks for auto-scaling group and auto-scaling launch configuration. The declarations on these blocks, which to my mind always read like method signatures, take a third argument, the resource's name. The name input here is how Terraform will think of this object, and this is how we introduce the interface's abstraction layer to our infrastructure code. Here you can see the declarations I sketched in for the console cluster. The name for each of these is console, as this is the logical unit that represents the service's deployment. I could also have named it console cluster, which would make it even more obvious that the auto-scaling group itself is the cluster. Because Terraform is where the translation layer between abstract and concrete exists, it's important to make sure the naming aligns with how design documentation, such as the diagram, records the abstracts. Since the diagram and documentation for console refer to the servers as a cluster, I name the ASG with the word cluster normally. I'm highlighting that because it's easy to let code drift from the documentation over time as it is improved and changed. If it drifts too far, it can become confusing and erase the benefits of clarity provided by this method. I go through the entire diagram this way, sketching in the placeholder resource blocks I can identify before I start writing any of the actual configuration. Approaching it this way keeps auditing the list of resources created against the diagram straightforward, as there's a clear mapping. Once the skeleton is laid out, I can begin filling in each of the declarations with arguments to configure the infrastructure I need. Since this talk is not long enough to compose an entire module and iterate it the way I normally would, I'm going to narrow down to just the auto-scaling group and launch configuration. When I'm writing Terraform in practice, however, this stage tends to be less linear and a bit more iterative. Since an AWS auto-scaling group requires a launch configuration, I'll start by filling in the arguments for launch configuration. This is the Terraform resource that holds the configuration of the individual compute instances that will make up the cluster. In the first pass of composition, I've either hard-coded values or left to-dos to come back and fill in for many of the arguments. Most of these values will be converted to variables or will be taken as attributes from other resources. This allows me to just keep moving forward on creating and validating the HCL while I draft. While creating this auto-scaling group, many of the other resources I create are referred to in the arguments. For the launch configuration, this is the instance IAM profile and the security groups. Since I've already put in placeholders for them, I can use the attributes exported by the resource declarations to fill those arguments. When I need to validate I've correctly linked them, each of those relationships can be matched to a line on the diagram to be verified. In this case, the name of the resource is an exported attribute, and so I'm able to fill in these arguments by referring to the interface functions they fulfill, such as the AWS launch configuration console. Once I've finished the launch configuration, I can go through the auto-scaling group in the same way, again using hard-coded values I will iterate away from later. Since I already have the auto-scaling group finished, I can again create the linkage immediately with an exported attribute. Being able to link abstracts in this way means at the end of this stage of composing the module, I should be able to match each piece of this main.tf to something on my diagram. I can audit that via a Terraform plan. Once this is coded and validated, I've made the Terraform work, and now I can make it conform to best practices. In this case, that means removing values and to-dos and replacing them with inputs supplied by variables or exported attributes of other resources as appropriate. This is what supports straightforward modification of the Terraform code for infrastructure management, such as upgrades or changing service needs. The module code will only need to be changed if the interface changes in a way the module no longer meets. In the sample launch configuration here, the AMI ID, type of EC2 instance, the name my SSH key is looked up by, and whether the cluster should have a public IP address have been changed to variables. These represent values that might change over time, and so a code approach is to make them easy to edit by capturing them with those variables. Meanwhile, in the auto-scaling group itself, the health check type and capacity timeout remain hard-coded as they represent contracts with other portions of infrastructure that should not change with a service. A few values will also remain hard-coded because they are defaults that are required by AWS and should not change often, if ever. Once this is finished for all the resources and a valid Terraform plan runs that can be audited against the diagram if necessary, the module can be used. While in this structure, it requires each service to run Terraform discretely during the service's setup, but the configuration for the service's needs can now be included in a repository and can be run repeatably. However, using a little help from Terraform, we can improve it a bit more. Converting the code to a reusable module offers ease around automation, importing into other Terraform files, and remixing. While I highly recommend the learn.hashicorp material on module creation, the console example I've been showing has this structure you see on the slide. There's a modules directory containing all the HCL, including variables, previously written, and a root level main.tf that imports the module and supplies inputs to the variables via the root level variables.tf file. This approach offers two benefits in my eyes. The first is that Terraform does what it does best around infrastructure management when modules are used like building blocks. And by making each service importable, the underlying network itself can be mapped as imports of services and the infrastructure required to connect them. It provides a method for a service's infrastructure to be audited against a central record, as well as atomically. Changes to a service's infrastructure handled by other engineers can be fed in as variables without even having to touch the service's code. The other benefit is my favorite, though. Leveraging automation around variables and command line input allows the supplying of input at runtime on the Terraform apply. Developing an automated job that allows values to be pulled from environment variables or configuration files means that once a Terraform module for a service is constructed, resource code only has to change when a breaking change to the interface occurs in service development or operation. In my opinion, this is the true power of an interface. Since there was a fair amount of material here in a relatively short time, I'll bring it back together now on the things I hope you've learned from this and will take away with you. Constructing Terraform modules to represent services offers a methodology for capturing the power of interfaces for managing infrastructure. By using this architecture diagram as a guiding framework, this methodology allows the management of infrastructure through human-friendly abstractions. In a microservice-based architecture, it also creates a human-friendly way to audit networks when needed. Architecture diagrams record an interface. Terraform allows you to write code to manage a concrete implementation to meet it. Everything on an architecture diagram can be represented with a Terraform resource. The name those resources use within Terraform should map to the name it uses on the diagram as closely as possible. Reusable modules are where Terraform really shines, and they enable automation and friendly abstraction. I hope this talk offered you a new strategy for Terraform design and composition, or sparked a new idea for a way to look at your services and their relationship to infrastructure. As I wrap up here today, I'd like to share a personal thought. One of my favorite things about the HashiCorp user community, from coworkers of mine to people I've met at Hugs, to engineers I've nerded out with in the lobbies of unrelated conferences, is their enthusiasm for making technology accessible for as many people as possible. I wanted to share this talk today, not just to help people in the audience who might need a new way of looking at Terraform, but also the engineers out there who don't know how to cross the gap and talk about systems with service owners. Infrastructure engineering has a reputation for being opaque, complex, difficult, and sometimes even painful. It doesn't have to be, though. One of the HashiCorp principles is that beauty works better, and that beauty can take the form of clarity or straightforwardness that eliminates difficulty, misalignment, and friction. It's my deepest hope that you'll find beauty of that sort in the methodology I've shared with you today. Thank you, HashiTalks Africa, for the opportunity to speak today, and thank you all HashiCorp user community for listening. I'll be dropping into the chat for questions.
Hey, Rosemary, I can't hear you.
Sorry, that's what happens when you have a hard mute, the hardwired mute on your microphone. Thanks so much, Chloe, for going through some of these interesting architectural considerations. I really appreciate it. Chloe will be in chat. And if you want to follow again on the transcript, we did put in the link into the chat as well. And I believe you mentioned the slides were also at the same link.
They will be shortly. I haven't uploaded them yet because I wanted to give the talk first.
Awesome. Okay. Well, next we have Samson. And Samson will be talking about managing change process with Terraform Cloud. Samson is a DevOps engineer with over 10 years of managing and maintaining public and private cloud infrastructures. And that's pretty cool. He is HashiCorp certified, which is pretty awesome. 3 times AWS and 3 times Azure certified. That's a lot of certifications, and that's amazing that it's been 3 times for both AWS and Azure, and now he has a HashiCorp certification. So for those of you who haven't checked that out yet, definitely check out the HashiCorp certifications. As well as HashiCorp Learn. So when Samson is not typing code, he spends time playing console games. And I think we're all curious about what kind of console games as well. This is a pre-recorded session. So what I'm going to do is play back the session. And if Samson is in the chat, feel free to drop your questions. Samson will also be sort of briefly hopping on by audio. And we'll do that at the end of the session. So let me stop and play back.
DevOps experience. Hi, my name is Samson, and today I'll be talking to you about how to manage your change process using Terraform Cloud and Git. A bit about me. I have like 10 years DevOps experience. I use AWS Cloud and I use Azure Cloud. I'm AWS certified DevOps engineer. I've got some Azure certification DevOps experience. So I just became HashiCorp certified Terraform associate. And I created my first AWS Cloud account in 2010, and since then it's been really, really interesting. And when I'm not typing codes, I am busy changing my son diapers or playing some games with him or feeding him. So let's go into Terraform. And where are we here? So meet Tunde. Tunde is a DevOps engineer, and I need Tunde and Toby to deploy some changes in my infrastructure. So Tunde is going to run his Terraform codes locally, and he's running his Terraform codes locally. Tunde shares his Terraform codes with Toby. But because Tunde has made some changes that Toby does not have, Toby runs the older codes that Tunde gave him. And what that means is that Toby is going to deploy the old changes to the infrastructure. Now, what we have is we have an unwanted change in our infrastructure, and that is not what we want. So when you work locally, or when you don't use like a remote backend or a remote state, it is not very easy for you to track changes in your infrastructure. And especially when you have more than one person running changes in your infrastructure, you will run into problems, right? You have issues like you might lose your state file, maybe your state file is corrupt, or your developers might check in the wrong code or run the older version of the infrastructure codes and make unwanted changes in your infrastructure, and we don't want that. What I am going to do right now is that I am going to simulate a broken internet connection. Imagine you're writing Terraform code and you need to apply right now in production, and all of a sudden your internet went off. What is going to happen? You would have Terraform trying to release the state lock, and because there's no internet connection, Terraform is going to fail. It won't be able to release the state lock, and there will be like a lock in place, but it will not be removed. So as you can see on the left hand side, the internet is gone. So let's assume coworker 2 is trying to run a Terraform apply, and we are sharing the same remote state with the same DynamoDB. Let us look at what is going to happen. As you can see, my coworker 2 gets an error message saying that Terraform is trying to acquire a state log, but Terraform can't acquire the state log. So I will be forced to like disable like the state log, but I don't know what happened, like what caused the initial state log issues. Now I need to like force unlock, so I can use my Terraform force unlock, put in the state ID, and also unlock the state file. And as you can see, this is going to unlock the state file. Now I have my state file unlocked. Local runs, when I mean local runs, I mean running Terraform init, Terraform plan, and Terraform apply on your local system. They are not ideal for more than one person. If you are managing your infrastructure and you have more than one person that is supposed to manage that infrastructure, you should not be running Terraform init, Terraform plan, and Terraform apply locally. Ideally, you should be running it through a version control system like Git, and also behind a CI/CD pipeline, or you could use Terraform Cloud. So when you run Terraform locally, you could also use, you could use your S3 backend. I'm sure most of us that use AWS are familiar with the S3 backend and DynamoDB. When you use your S3 backend and your DynamoDB, you are simply storing your state file in your S3 bucket, and you are also locking that same state file with DynamoDB. It has its benefits, right? Because you could share your state file, you could have your logs to prevent race condition. However, it has some other drawbacks. Like take for example, I have my state file I have my state file in my S3 bucket, and before when my developer run Terraform init, Terraform plan from their machine, they use the central state file. But the issue I'm going to face is that there is no approval process, there is no review process. It means that anybody can just run Terraform apply and make any unwanted changes to my infrastructure. That is not what we want. And aside that, a developer might be working on the old version of the codes, and they could make unwanted changes even with our central S3 state bucket and our DynamoDB locking. We still have that issue of people merging or people approving wrong changes in our infrastructures and people working with the old version of the codes, and that is not what we want. So I'm just going to go straight into why we need Terraform Cloud. Terraform Cloud is simple. Is a simple SaaS solution by HashiCorp that allows you to manage your centralized runs, your centralized Terraform approval. So what that means is that if anybody is making changes to your infrastructure, there's a central location where you can approve the changes to your infrastructure before you actually make those changes. So that means you don't have your developers running Terraform init, Terraform plan, or Terraform apply on their local system. They just submit a merge request, and once they submit a merge request, you look at the Terraform plan based on the merge request, and if it's okay with you, you can approve the plan and also approve the apply. If you're not okay with that, you can discard it. Also, you can control who is accessing your state file, and you don't need to store like sensitive information in a central bucket where everybody can see. You can control who have access to the state file, and it is still running Terraform plan, Terraform init, and Terraform apply under the hood. Part of the features of Terraform Cloud is that you can integrate it with your version control system. So if you're using things like Git, GitLab, if you're using things like GitHub, GitLab, Bitbucket, Azure DevOps, you can integrate it. It is simple plug and play. You just sign up on Terraform Cloud, select your version control system. Once you select your version control system, you would just choose your repository that holds your Terraform config files. Once you do that, Terraform is just going to import it and start running the init process, plan process, and the apply process in the background. And also I talked about Git branching. What I do is that I have like a default master branch for my Terraform approvers. So I only run Terraform apply on the master branch. Now, what I need my developers to do is that if they need to push any changes to the infrastructure, they create a merge request, they create a branch, then once they work on the branch, create a merge request, submit the merge request. Once they submit a merge request, Terraform Cloud is just going to run Terraform plan on that same merge request, and I can see the outputs of the merge request. If it is something I like, I merge it into the default branch, which is my master branch. Once I merge it into the master branch, I can run Terraform apply. So what that means is that all my developers are not making the actual final changes to the infrastructure. There is a gap, right? There's a gap. So they make code changes, push the code changes to the Git, and I have to approve the code changes before they go into production. So it simplifies managing changes in my infrastructure. And also it is really easy to set up Terraform Cloud. Just go to app.terraform.io, sign up with your email address, choose your organization name, import your Git repo, and set up your variables. And also it is free for smaller teams. They have some paid features, you could check them out also. So right now I'm going to go into a demo on how to sign up for Terraform Cloud and also how to use it to manage your infrastructure. So let's look at this demo. So I'm going to show you a demo on how to actually sign up and set up the Terraform Cloud. So we're going to go to app.terraform.io, create an account on Terraform Cloud. So let me create an account. So I just created an account. on Terraform Cloud, and now the first screen you're going to see is going to ask you like maybe you want to start with a fresh Terraform config or you want to migrate an existing Terraform state. So I'm going to just start with a fresh one. I don't want to migrate an existing state. So create your organization name. I'm going to name my organization HashiTalks Africa, and you are going to have to put in your email address for your organization. So once I do that, I'm going to create the organization. So create, and yeah, so right now we're going to connect our version control system. I'm going to use GitHub. So I'm going to connect my Git, put in your username and password. So once you connect to your Git, you need to fetch the repository that contains the Terraform config. So I already fetched the repository that contains my Terraform config, and I'm going to create my workspace. And you can look at the advanced features of Terraform config. You can disable automatic triggers, and you can also select which default branch you want Terraform runs to trigger. So I'm just going to leave it as default and apply. So once you do that, you would wait for Terraform Cloud to pull your config from GitHub. So it doesn't take a lot of time. But while we are pulling the config from GitHub, I'm going to show you something else. You can go to your variables. Because I'm using AWS, I need to have my AWS access key and secret key. So I'm going to go to my environment variable, and I'm going to create my access key and my secret key. So I'm going to copy that from my AWS, create the access key, and I'm going to make it sensitive. Once you make it sensitive, it means that you can only write to it. You can't even view the access key, which is also like a form of security. So I'm still waiting for the config. Let me refresh. Yeah, so my config has been added successfully. So I'm going to go back to my my repo, and let's assume I have two developers. The one on the left is going to create the EC2 instance, while the one on the right is going to create an S3 bucket. So this is my code for creating my Nginx web server. So I'm just going to change the name to Nginx, and I'm going to commit it and push it to my Nginx branch on my Git. So let's take a look at what is going to happen. So as you can see, I just push my codes, and right now I would open the merge request page, and I'm going to create a new merge request right now, or a pull request. So I'm going to open a pull request and comment it, create a pull request. Once I create a pull request, Terraform automatically trigger a Terraform plan. So you're going to see right now, create a pull request, and as you can see, my Terraform is going to run Terraform plan as a check to it. So when I click on it, I can see the output of the plan. As you can, this is my Terraform plan. So I mean, if this looks okay, I'll go back to the merge request and approve the merge request. So by the time I approve the merge request, Terraform is going to run a Terraform apply. So let's take a look at what's going to happen. I'm going to run a Terraform. Terraform Cloud is going to run a Terraform apply. And it is going to ask us if we need to approve it, because of it requires a manual approval method here. So as you can see, it is about to apply, and yeah, and I could confirm and apply it. So once that is done, you can see I have my Nginx web server running. Now I'm going to go back to the other repository, or rather the other branch. So the other developer needs to create a new bucket. So he's going to work on his own feature branch and create a new bucket and commit and also merge the code to the Git branch. So as you can see, after doing that, I'm going to open a pull request. So once I create a new pull request on Terraform on my GitHub, create a pull request. Terraform Cloud also run a Terraform plan. So it's going to run a Terraform plan. And if once I'm okay with the Terraform plan output, I am going to merge the pull request. So once I merge that pull request, Terraform is going to run the plan and ask me for approval. So once I actually approve the Terraform plan, Terraform is going to actually create the S3 bucket for me. One thing about Terraform Cloud again is that if you have a merge request, let's assume a merge request has been approved by another team member, but we don't want to actually approve that merge request. When Terraform plan runs and it wants to run apply in the Terraform Cloud, it's going to ask us for a final approval process. So what that means is that it needs us to approve the plan. So as you can see, when you use Terraform Cloud, you just need to like create your workspace, import your config, and just have your developers work from different branches in your repository. And also, what you could do is that you could disable write access to the master branch. Make sure that before you can write to master branch, there have to be maybe 2 people approving or multiple people approving the codes. I mean, you could use like different strategy that you want to use, but for me, this is what I use, and it really makes it easy for me to work with teams. And as you can see, Terraform Cloud really makes it easy, and it's free for smaller teams, and it is really easy for you to get started with Terraform Cloud, and it makes your job very easy and faster. Thanks for that. I don't know if anybody has any question. If you have any question, you could ask me right now. Thanks. Bye.
All righty. Thank you, Samson. Samson is on with us.
Yes, I am.
Say hello.
Hi.
So if anybody has any questions, feel free to post in chat and I'll just ask Samson live. But we have a couple people who are saying hello, and they admired your broken internet mocking.
It was pretty epic.
No.
It fooled me. I thought we were having like a HashiTalks Africa glitch.
I know. So out of curiosity, which HashiCorp certification did you get?
The Certified Terraform Associate, and that was last Friday.
Congratulations. That's awesome.
Thanks.
And between AWS and Azure, which is your favorite certification test to take?
Well, I would say AWS. I mean, any day, anytime, AWS. Yeah. I mean, I love Azure also. Right.
Yeah.
Rosemary, way to put Samson on the
Well, it's different, right? You know, tests are difficult to take, but also, I don't find them enjoyable. So some people enjoy them. It's challenging. So it was a really cool example that you showed of how you would work with Terraform Cloud. It's very unique. So do you find, the comments and the integrations with GitHub something that's useful for your use, or are there improvements that you see that we could make to it?
Yeah. So for integration to GitHub and other Git protocols and some other VCS, the integration is very smooth. However, I think my concern, or maybe my request, hopefully, would be to have like a global variable. I see that some people have asked the question in the Terraform GitHub pages, but if you have like a global variable, so that means we have like an access key and secret key that we could have, and we could rotate it anytime we want, and we have like some other workspace to be able to consume that global access key. I mean, I don't know, but what I would probably do is I would test out Terraform Enterprise. I would try it out, and I would see if it has that features. But Terraform Cloud is really awesome, man. I mean, people should try it out.
Yeah, I'm glad. Did you get a chance to try the Terraform Cloud run triggers yet?
No, I haven't tried that. I just like set up my VCS and just start pushing to my branches, and everything is smooth. Like the basic features are really, really even smooth. And when you now move to like advanced features, then that means it will be way smoother.
Yeah, that's awesome. There's a feature called run triggers in the Terraform Cloud, so you'll be able to trigger one pipeline after another. So there's a source pipeline, etc. And someone mentioned that there's a variables API where you can rotate secrets and do those global variables. So I think there's probably, a couple ways we could do it, and different patterns too.
Yeah, true.
So do you prefer Terraform 0.11 or 0.12? I see you had 0.12 in there, so.
Yeah, so I've been using 0.11 for a very long time. And I love the fact that 0.12 is backward compatible, right? So you are not forced to like upgrade your codes. But however, I see like when I start using version 12, I just like the syntax, and I don't have to like do the interpolations every time. It's really make much sense. And also it makes like my runs very faster. So I prefer Terraform 12. The syntax is very crisp and very clean.
Very cool. So have you gone through refactoring all of your code to go
Yeah, it's pretty simple.
Oh, okay.
It's really simple to upgrade. Like it's just run your Terraform 0.12 upgrade, and it is going to, you can run the checklist and see what Terraform is going to do, and you can run the upgrade tool, and Terraform will try to upgrade some of your config codes. So it is really, 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 really easy.
Awesome. And out of curiosity, how did you get started with Terraform in the first place? Like what was really helpful when you were learning it?
So I took a course on Linux Academy, and I was with Andela then. So I took a course on Linux Academy, and I finished like the course in like a day, within 4 hours. And since then, I have never looked back. Like, I keep on telling people like Terraform is really easy. Like it is extremely easy. And because it uses HCL, the HashiCorp language, it is really easy. So, and for the fact that it abstracts everything about you connecting to your service provider, it does the abstraction and it gives you like a plain HCL interface that you can use to interact with it. So Terraform is really easy, and I started using Terraform actively like around 4 years ago.
Wow. So that's definitely 0.11, 0.10 maybe? Even before that, right? Yeah.
Yeah, before 0.11, yeah.
Wow. Katie, any questions that you see in the chat?
No, Anton did have a comment. He was agreeing with the variables API that you can rotate secrets there, like Samson was saying. But other than that, no questions coming in.
Cool. All right. So we're running a little bit early. Do you think we should resume playback of the continuing sessions, or maybe we chat a little longer?
Tell a joke.
Does anybody have a good joke?
I'm kidding. Honestly, I do not like when people say that to me in pauses, so maybe I shouldn't have said that to you.
I have a terrible, terrible joke, and it's my go-to joke, and it makes absolutely no sense whatsoever. So I can tell it, but it makes no sense.
Let's hear it.
What do you call a spider without legs?
I don't know. I don't know.
A grape. I don't know. I don't know why that's the answer. Or I never understood it fully, but that was the go-to joke that I have.
It's funny because it's so silly, but I approached it in thinking as it was like a riddle. And to me, grape is not the answer if it's a riddle.
Oh, we do have a question in the chat. Hi, Samson. If you want to use Terraform to build an image and push to AWS ECS for each commit on an application repository, how would you do it with this setup?
So so with this setup, you need to first of all figure out a way to like you have to abstract your image creation. So you could be using maybe a Docker file to build you said ECS. So when you use ECS, you're running Docker instances, right? You need to find a way to get your Docker file to build your Docker images and push it to like ECR. You could do that like maybe you could use Terraform, right, to like pick up like to build the container. You can use Terraform to like push the container images to like ECR, or you could use like an external to whatever you want to use, but find a way to push the images first of all to Elastic Container Registry. Then once your images are in Elastic Container Registry, you could always use Terraform to create your task definitions, to create your service, and also use Terraform to update like that same service. You write your codes. Just think of you writing your normal Terraform config files and running it in locally, but this right now, you're not running it locally. You are writing the codes and you're pushing it to your GitHub, and Git is going to do the same. Your Terraform cloud is going to do the same Terraform init, plan, and apply process for you. It's the same way you're going to write it on your local system, but you're pushing into Terraform Cloud and Terraform is managing the process for you. So whatever you're doing that works for you locally, just try and modify it and push it to Git and let Terraform Cloud runs the process.
Cool. And I guess it's sort of a secondary part of this, right? Is that if you have a CI framework, let's say Jenkins or something else, right? If you have a CI framework and you were using the CI framework to build an image and push it to the repository, and then, you know, for each commit that someone was making, how does this change when, let's say, you add Terraform Cloud into this? What are the ways that you might use Terraform Cloud in this pipeline, right? So maybe it's for storing, you know, some infrastructure state, separate infrastructure state. But in CI, can you actually work with Terraform Cloud if you have an existing CI framework?
Yeah, if you have an existing CI framework like maybe Jenkins, CycleCI, or whatever you're using, you can still integrate it with with Terraform Cloud. You can still make Terraform to manage the process of plan, and approvals, or you could just use Terraform to manage the remote states. So whatever works best for your team. But to be honest with you, I have used CycleCI and I've used some other CI/CD pipelines to actually manage the plan process, approval process, and run plans on merge requests. But it is not as smooth as using Terraform Cloud. And I'm saying this I'm not trying to market Terraform Cloud, and I'm saying it from my own experience that it is not as easy because I've used that, and you should try it out.
Yeah, it's definitely, I can second that, although I'm a little biased, so. Alrighty, well, if there are other questions, feel free to post in the chat. We'll definitely go through and answer them. Apparently there was a joke by Nick about UDP, but apparently no one understood it, or I don't think everyone got it. And there's actually more, there's some follow-ups as well. So I have Terraform files with the application repository on each commit. CircleCI, there we go, builds. Then Terraform updates the AWS ECS service. If Terraform files are in a separate repository, how can we get it to update the service?
Files with application repository. I don't really understand your question, but what I picked was that if you have your Terraform files in a separate repository, if you have it in a separate repository, you could call it as a module. So when you have your Terraform files externally, call it as a module, then reference like the tags on the Git, call it, and you can, just convert it into a module and call it from your main.tf file or wherever you are running the actual Terraform runs. I don't know if that answers the questions.
Yeah, I think that's a good approach, and I think that answers the question about if the Terraform files are in a separate repository, formulate them as modules, and that's a way that you can self-service those modules. So I think that's a pretty good pattern to do, especially if you're using a CI framework. All right. So if there are any other questions, feel free to post in the chat. Thank you, Samson, for joining us, and thank you for playing back. It was a great demo. I appreciated the breaking of the internet. That was that was the highlight. That and the mask on the Terraform Cloud credentials, so no one can grab your credentials.
Thanks.
Thank you so much.
Hi, Samson. Thank you.
All right. So next we have Sega. Let me pull Sega. All right. So we're running a little bit early, but we're going to try to get back on schedule a bit.
Well, we have Sega in the Zoom webinar if he wants to pop in and say hi for a second.
Yeah. Sorry, it's going to be a bit noisy because I'm at a public place. Hey.
Okay.
Yeah, I was just following Samson earlier. I don't think my talk would be that technical, but I hope it's going to be, appealing to a few people here. I am around, so please, if you have any questions, something you would like to say, you can post it in the chat. I will answer. I'll be around. It's a pre-recorded session, so if I miss something, just let me know in the chat.
Also, curious to know, would you be able to introduce yourself actually?
Yeah, okay.
No pressure. No pressure.
Yeah, so I'm from Ethiopia. My name is Agasilasi, so it's kind of hard to say, right? I'm a front-end developer. I work remotely. I've been working remotely for the past 2 years. I do a lot of Drupal stuff, web design, whatever. So our company is engaged in building enterprise web presences for Fortune 5,000 companies. And yeah, that's what I've been doing for the past 2 years. I don't know, anything else?
Yeah, that's awesome. I appreciate the introduction. So have you always focused on front end?
Not really. Started out as actually as a .NET developer, so there was no front end backing then. So
that's so cool. I have an affinity for .NET, despite everybody telling me
really?
not to. Yeah, I know. Everybody judges me for it, but I'm like, I actually kind of enjoy it.
Yeah, but it's 2020, man.
I know it's 2020, but still, I don't know. I just have an affinity for C#.
Yeah. Okay. So yeah. I've done a lot of PHP, some Ruby, Rails stuff. Currently doing a lot of JavaScript. So yeah, been around.
Very cool. Awesome. Well, I'm excited to hear about the Remote Developers Playbook, and I'm actually going to start playback now.
I want to note too that I let him know that the time allotted for speakers was 30 minutes, and the file he sent over is 29 minutes and 59 seconds. Very spot on.
Yeah.
Very spot on.
Attending this talk. The talk is in Remote Developers Playbook. Just to say a few things about myself. My name is Sagdasilasi Tadessa. I'm a front-end developer at Accelerant. I work remotely, obviously. These are my social links if you want to reach out to me. I've been working as a software developer for over 14 years now. I've been doing remote work for the last 2. To get started, so the quality, we're going to focus on the qualities of an effective remote developer. What I mean by effective is people who get things done, people who have progress in their careers, people who are looked up to. So essentially, these are what you would call the rockstar developers. But before we get started in this, I want to make something clear about what remote means. First of all, remote is not freelance. Okay. Remote is not part-time. It's a full-time job. Most remote jobs are done from home, but it doesn't mean you have to do it from home. It just means that, you're able to do it from anywhere. And last, of course, a remote developer doesn't mean you're lazy. You don't do this every day. It's not like you're sleeping 12 hours or, just relaxing in your couch. All right. So the first thing I want to talk about regarding an effective remote developer would be their communication skills. So as you might consider, because of lack of physical presence and the issue that people are not near each other, they cannot read their body language or how they're acting and everything, communication is quite key to be a successful remote developer. So I would categorize communication into 3 different categories. One is one-to-one communication. So effective developers, when you meet them one-to-one, they are very detailed. They provide you with full context of what you are going to talk about. And usually they focus on completeness of information that's being passed on. And sometimes, of course, these one-to-one communications are for the purpose of criticizing. Which is not a bad thing. It's actually constructive criticism of their work, of their behavior, whatnot. If you're planning to be a remote developer, you need to have the skill of communication. I could actually end the whole talk here. That's how important it is. The next category of communication is one to many. If you do a Scrum or Agile methodology, that'll be your daily stand-up, where you're given a very small amount of time. You're supposed to summarize what you've done or what you are doing or what you plan to do. And you provide a little bit of context because people may not know what exactly where you are and what you're doing. Usually communicate with the interest of time. So you don't want to keep a lot of people engaged in the meeting for too long. That would be boring. That would be unproductive. That's like killing your time and killing company time. And the last type of communication is many to many. This would involve a lot of stakeholders. So this would be more of a protocol-based communication. So you don't speak whenever you want to speak. You communicate based on requests. Also, you keep it very short. Most of these types of communications are rehearsed. So usually in our company, this would be meeting with the client. That would involve high-level people, managers of that sort. And you probably want to say a few things here and there, but you just keep it short and you make it to points which were already discussed in a different meeting. All right, so one other aspect of communication I want to show is how effective developers have a way of expressing themselves, expressing what they do and their interaction with their team. They would usually articulate what success would mean to them and what kind of challenges they're facing, what excites them, what's irritating them, like a situation with a team member or a manager. They would be able to tell you this if you ask them. They would also be good at specifying, their needs, their desires, and they'll be good at, making these very real and tangible. Moving on to the work environment, when they communicate in the work environment, they would be a lot more structured. You would see that, they would define what they want to communicate into certain points, which are all targeted to providing progress to their work, okay? So they would probably be able to describe situations, like what happened yesterday, what's gonna happen today, or what happened during the demo. And they talk about risks, like they have to communicate this clearly to whoever is involved and who's managing them. They have to come up with mitigation plans. They have to discuss their blockers, those things that have been blocking their way of progress, their work, and all of this pointing to success or progress in their work. When it comes to teams, so the key word here is synergy. The whole purpose of communication, of being an effective communicator as a remote developer, is to have a relationship with the team where you are able to work like you're working as one person. Like you would understand people's positions, where they are, the relationships between the team members, what combination of people actually work together better, what conflicts are there. I mean, as long as you're going to be working with people, there's going to be conflict. Who likes you, who doesn't like you, or who do you need to make yourself clear about, or how do you clear miscommunications, things of that sort. And of course, the work is done through collaboration. I have never seen a big company or any company that does software development or any type of work without a number of people getting involved in collaboration. So that is an important point to always consider. There are like 4 aspects or 5 aspects to this that I want to see. One is time management. So I've never seen a remote developer who's very responsible, who everybody looks up to, that is not punctual or that does not consider the other people's time. So it is vital that as a remote developer, you cannot be late for meetings, not even like 5 minutes late. because that's like 5 minutes late of several people. And you're taking or you're eating time out of. And the other is it's related to work, and you need to have this mechanism of being able to estimate your work, like how much time would, for example, as a front-end developer, how much time would creating a login form take you? You should be able to say that. And related to that, how much time can you really commit? You should be able to say, if you're going to work for 8 hours, at least mark out 8 hours of your day for work. I know not everybody works 8 hours, and it's probably impossible to work all the 8 hours, but at least mark it out, block it out for your work. The other is measurement. So you've estimated, you have blocked your time, but you also need to know the actual time that was taken to do the job. So that developer or that remote engineer should be able to measure his productivity on a daily basis, on a task basis. So it's one important aspect that I've seen that, you know, some of the best developers that I've worked with, they know how much time they spent in a day doing what they were doing. And the other, of course, is, you know, it comes with being a remote developer. It's distractions, okay? If you're working from home, you have family members, you have children, there will be distractions, and you need to give at least like some leeway for that. You cannot avoid it. If you can, that's good. But if you cannot, just embrace it, work with it, work around it. And it's something that's going to be popping up every now and then. Task management. So an effective developer would be an expert in prioritizing what needs to be done. So they would know what comes first and what comes second and what comes third. So that manager or as a team lead, you should be able to assign tasks to others. You should know which developer does what type of work in a better way, so that you can assign them that specific task that you have that you can give to them. And of course, in any working environment, one important thing would be to balance the work. Have a balanced time schedule where you're not working 12 hours instead of 8 hours, or you're not going overboard by having an all-nighter or something. So this is something important. The other is change management. So even though you have a plan, you have a schedule, you have everything ready and you're working, things change. And when things change, your plans and your schedule should be flexible enough to accommodate that change to a certain extent without you losing track or without you being hindered. There are risks. Things happen. For example, the internet might go off. This has happened to me several times, and you should be able to anticipate that. And if that happens, there should be backup plans, okay, countermeasures. And when change happens, you need to be able to reconfigure your plans and your assignments. And remote developers who are good at their craft know how to handle change. So what I've seen really good developers do is that they know what they're going to do next year, or they have an idea of what they will be in the next 2 years. Okay, this has to align with the company that you're working for. It should align with what they want to achieve as a company. So you need to understand the requirements. So maybe you're just starting out like here as an E1, you have basic knowledge of web development, HTML, CSS, JavaScript, whatever. But your company might be doing something like a CMS, like Drupal or something, and they want you to be able to have expert level understanding of Drupal before you can move on to E2. So your career development should be aligned to that, and you should have short-term and long-term plans on where you're going. And this is true for every other profession, not just as a developer, but the progress goes from a very small person to a fully grown person into a bigger team. That means your progress would also include involving other people, like being responsible for other people. So you need to have not only technical skills, but also people skills, managerial skills. And another aspect which was related to the career development is that an expert remote developer is an avid learner. They take learning very seriously, and they usually have a personal strategy on how to go about it. For example, most of their learning is targeted. So it has a purpose. It requires like commitment. That is, they're going to put a certain amount of effort and a certain amount of time for achieving that, learning goal. And they are usually accountable first to them. The learning is time bound, that it has a start date and an end date. It's not open-ended. Okay, let's put it that way. It's paced. That means whatever they're trying to learn, it has to be spread out into several days, months, weeks. And with that comes, you need to provide time slots, because you're working 8 hours a day. You have family, or you're involved in something else other than work. You have so many hours in a day that you cannot do any learning at all. So you have to put like a certain time slot, maybe 30 minutes a day or an hour a day, for you to do your specific learning. You have to do it. If you don't have that time slot, then it will be very difficult to achieve what you've planned out. The other point with learning is whatever you've learned, you should be able to demonstrate it, to apply it to the jobs, to the work that you have. And better yet, you should be able to share it with other people. If you've learned something new, some new technology, new way of solving a problem, then you should be able to have a skill sharing program where you actually teach other people how to learn the new technology. And the other point, which is very true in our industry, is that the learning is incremental, is continuous. It never stops, and you need to think about long term. So when we talk about learning, it's good to think about learning paths. So as a web developer, there would be, I would consider like three paths, like what's presented here, to be able to find yourself, if you're a web developer, into one of these categories. And you should see these links provided below, like roadmap.sh, where there's like detailed information on how to go about learning and progressing in your career. The other aspect of an expert remote developer is they are expert educators as well. So you would see a lot of people are, a lot of good developers have blogs of their own. This has so much value to your career, not just for showing your qualities, but it is like an advertisement of who you are. And if people have read your blog and have seen what you've been doing for a certain topic, then even getting hired becomes easy, because they have already come, the people who might employ you might have read your blogs and might have found it to be very useful, and they might have even reached out to you through your content because of the quality of your content. So it's something I've been planning to do myself, but I haven't really gone into it. But if it's something that I see most expert developers, remote developers do on a regular basis, and this is something you should embrace as well. It doesn't have to be a long, complicated blog. It just has to be something of value. If you can add value, then you can blog. That's my suggestion. Of course, even more productive people have tutorials online, video tutorials. YouTube is filled with such resources. There are even the learning platforms. Those are people who have like a developer position, but are able to spend some time, teaching other people how to do stuff, and they actually have like a paid tutorial. If you are interested in podcasts, there are so many out there, but you can also have a voice you can have a different perspective, especially as an African developer. Like the things that are happening near you and close to you, they could be probably different. So sharing that, having like a way to communicate that, I think it's a good, it's one of the qualities that make like a very, very interesting and an expert remote developer. The other is speaking, of course. Again, it comes from the learning, it comes from their ability to manage their time, to put time aside to prepare for speaking, to prepare for like tutorials, whatnot, to attend big conferences as an attendee, but also as a speaker, come across with a senior developer who is not keen on sharing his knowledge, giving a talk in some way or fashion. Again, related to that is a show and tell. In our company, we have a show and tell. It's primarily geared towards letting other team members know what you've learned, show them, demonstrate what you've learned. And of course, another major component in this education sharing sphere is community. Most of us are users of open source software, especially in Africa. We rely heavily on open source stuff. There are so many good communities out there. I've had the privilege to be part of the Drupal community, which has been, first of all, a source of a lot of learning for myself. A good deal of friends and acquaintances have come out of that community, and honestly, a lot of benefit, like career-wise. My last two jobs have been because of people that I know in the community who've referred me to a possible job opportunity. So I think it's vital that we have a close relationship with the community, whichever community that is, that helps us, that we help as well. And as a remote developer, there are so many communities out there that you can engage with without even being physically present. So I would recommend, as if you want to become a really good remote developer, or any type of developer, actually, you need to engage with the community. You need to understand what people need, what you can do, things. And I cannot stress how important this is. And the other attribute I see in a very skilled developer is that they are known for at least one thing. They are a specialist. They have been tried and tested in something, and people have found them to be experts in something. So they are a bona fide specialist. So if you want to be an effective remote developer, you should somehow be associated with one of the words that are being shown here, or it could be a different one. So my favorite one is, of course, the Drupal wizard right there at the top, or it could be a Python charmer or a Rails conductor. The JavaScript ninja, you've seen that a lot of places. CSS chef. So people need to call you, or need to think of these things when they hear your name. Most of the experts in the company I work for, most of the people that are there, you would know who to reach out to if you had a problem in a certain topic, in a certain situation. So those people, I mean, it's a no-brainer. You just go to them, and they'll provide you that solution. Even better, you might find something that they've written, a blog post or a video, or some sort of information online that they have documented for themselves, but you can have a look at online. And this has happened to me several times. And this is actually one of the marks of a great developer. You know they are specialists. One huge point I also see in developers is that they are team players. They understand they can't do everything all by themselves. They embrace their role, whether it's a starting position or the leading position. They know their role. Okay, they know the qualities and the responsibilities of their team members. They know when to reach out to people. They know the responsibilities of a certain developer and how to work with them. And they have a good understanding of how things are done. And they don't go about, wondering who's responsible for that. They already know that. And they also not only that, but they also know their role in the team. And one thing that strikes me about such developers is that their level of ownership. So when it comes to crunch time, when it comes to that deadline week, you can be sure that those developers will deliver. Just like this guy, the number 23, Michael Jordan. Whenever it's time for that clutch shot, he's always with the ball. He doesn't drop the ball. He doesn't pass it to anybody. He makes sure that he's the one that does the real work, the most important work, that is delivering. Okay. The next point is they're also good, in assisting others. So they help others into becoming better developers. They help in like one-on-one coding sessions. They help with, they assist with even tasks that are not related to them, but they know how to do it. They are always on the lookout to help others who are being stuck, who are in need, and they're, the whole effort that they put in goes into making sure that there is something to be delivered by the end of all the work. So as a basketball fan, for me, that will be a championship. As a developer, for an effective remote developer, no matter what he or she does, it has to be delivery of that software product in time, within budget, and within expectations, and probably beyond expectations. The last part here is, even though we're focused on work, on being professional, on delivering on time, on working together as a team, there's also a human factor to being an effective or a developer of high standards. Okay, one is, as we are all humans, we need to think about wellness, our well-being, be it physical or emotional. So these people, I have seen them being very conscious of not only of themselves, but of other people's physical and emotional needs. And they are attentive and they care. Okay. So caring is expressed in kindness, the way people communicate with each other. I know there you might be the superstar of the company, but it means it provides little value that you are, if you are brash and very vulgar in your speech. You have to have that human factor. You need to understand the limitations people go through. Not everybody can make it. not everybody is healthy, not everybody is quick to understand, or maybe not everybody is privileged to have the resources that you have. So I have seen this in the company that I work, that people who are very good, very talented, they are also caring, and they are also connected. They're concerned about team members. They shared their experiences. They are relatable. As an African, as an Ethiopian, I go through a lot of issues with the internet, with power, with family, but I have a manager that can relate to that, and who not only relates to that, but is also willing to share his experiences, and express his concerns, and he's done this kindly. And I see that if you want to be an effective remote developer, you have to have these qualities. All right. And one other last quality that a remote developer should have, by default, of course, is he or she should be able to work from anywhere. If you see this picture, this was taken in Senegal. Some 200 or 300 meters to the left, to the right, would be the farthest westernmost point of Africa. And I had the privilege to go to a very nice restaurant very near the ocean, and open up my computer and start working. And so the beauty of being a remote developer is that you're not stuck in one place. You can work from anywhere. For now, it is home. Every one of us, or most of the world, is at home, but it is something that we can enjoy as well. So yeah, I just want to put this in. If you have any questions, we can take them now.
All right, thank you, Tega. That was actually really cool, especially with some of the circumstances happening today. I think that it is very relevant, and I think a lot of these practices are going to be really helpful, especially in the way of working that we have right now. Just to sort of stay on time, if you have any questions for Sega, you can feel free to drop it into the chat. He did do a wave, and feel free to send him a message as well if you have any additional questions or follow-ups. Next, we have Choice available, and this is actually really cool. She's also known as Tech Empress, which is really exciting. We have her on, and she will be talking about combating imposter syndrome, which I think is a topic that's very near and dear to many of us. Choice, would you be able to turn on video or sound?
Yeah, I'm here.
Yay, all right, it's working.
Okay, so I had very little time to set up my slides, but I'll just share my screen right now.
Okay, sounds great. I will turn off my video, and feel free to go ahead and start when you're ready.
All right. Hello, everyone. Can you hear me?
Yes, that's perfect.
Okay, thank you. My name is Choice Osobo, also known as Tech Empress. I'm a front-end developer, a freelancer, and I'll be giving a speech about combating imposter syndrome. And that brings the big question: what is imposter syndrome? We all know Serena Williams, a tennis star. In an interview with Oprah Winfrey, she said, "It is tough being me. Sometimes when I go out to a restaurant with my sister and place my order, I change my mind once she orders because I feel I made a wrong choice. An author and civil rights activist, Maya Angelou, says, I have written so many books, but each time I just have the feeling, oh no, they're just going to find out what kind of a jerk I am. Lady Gaga says, I still sometimes feel like a loser kid in high school. I just have to pick up myself every morning and say, I am a superstar. And Choice Usoba, also known as Tech Empress, says, each time I have to deal with a stubborn bug or fail at a task, something inside me just whispers, hey, you're no tech empress, you're tech loser. All these people are popular stars, as we all know. Well, except for the last name though, that's me. So if you suffer from imposter syndrome, you may have a sense of inadequacy or insecurity about your ability to contribute, to be successful. You find yourself asking questions, debating questions like, what am I doing here? I'm not a developer, I'm just fooling myself. My colleagues are smarter than me. I need more training. How did I get through the interview process? I'll be ridiculed, fired, and everything will be exposed. You're not alone. We all suffer from this, from senior level CEOs, men and women in the society, to general managers running billion-dollar companies, to tech enthusiasts, to mentors, to even speakers who command hundreds and thousands, like me do, but in hundreds. Writing this speech, and I'm wondering if I'm making any sense. Is it even good enough? Or I'm just going to expose how much of a jerk I am? And yes, its impact affects women as in men every single day. For example, you get a promotion at work and your inner narrative is that they probably might have been short on candidates. Or you're sitting in a big meeting with more men than women and you just think the boss will walk in any minute, tap me on the shoulder and tell me how they finally realize that I'm not qualified for this job. It can be completely derailing. And a tendency towards perfectionism, fear of failure, continually undermining one's achievement. For example, wow, I just trekked up Kilimanjaro, but it's nothing. Second person would have done that in seconds. These are all indications that you might be prone to imposter syndrome. And it can be debilitating because it causes stress, it causes anxiety, it causes low self-confidence, shame, and in some cases, even depression. This could also limit one's courage to go after new opportunities, explore potential areas of interest, or put oneself out there in meaningful areas that could widen one's horizon. But at the end of the day, we all have to remember this. You're here for a reason. In this job, in this business, in this career, your life, you're worthy. You're better than you think. You're smarter than you know. You know more than you give yourself credit for. We need to always remember this and remind ourselves as often as possible. Professionalism plays a significant role in imposter syndrome. You might think that there's some perfect script for conversation, and you can't just do things, afford to do things wrong, which in turn will lead to procrastination. Stop fighting those feelings. Instead, try to lean on them, accept them. It's only when you acknowledge them that you can start to unravel those core beliefs that are holding you back as a huge setback. Some mistakes we make often can really be deterring. For example, we set really high, unreasonable goals and feel ashamed or disappointed when we fail. Perfectionists, they are never satisfied with their achievements. They prefer to focus on mistakes and failures. But it's essential that we build our confidence by becoming more aware of the strengths and weaknesses that we have. One way we can do this is by conducting SWOT analysis to itemize them. So once we have a deeper understanding of these strengths and weaknesses, we won't spend so much time worrying. Professionalism is not realistic because, for one thing, for example, a newbie says, I want to learn HTML, CSS, JavaScript, data structures and algorithm, and Ruby on Rails in 3 months just to be a good fit in the market. Hello? Set realistic goals, goals that are achievable and challenging, and accept honest failures as part of growth. Take them in bits, and when you fail on a course, treat them as learning experience, and you can be much more better when you bounce back up. People with imposter syndrome find it hard to accept compliments. When things go wrong, they blame themselves continually and focus on the downfall. When they are successful, when things go right, they attribute the success to external factors such as probably I got help from someone or good fortune. This can prevent you from reaching out when you need help, thus slowing your progress. When this happens, take a break, calm down. Always remember the game of chess is a battle. So, how do we checkmate imposter syndrome? We're going to discuss 10 steps that has proven to be helpful and can definitely help us in the tech world if we focus on them. Step 1, know that the feeling is normal. Not everyone will come out of their caves and discuss the kind of battle they go through or the hidden wars they have to fight in day and night. What you see on the outside is just a show of success. So it is rarely discussed, but you must believe that you are not alone. Step 2, remind yourself of your accomplishment. In other words, your life's work. Know that you don't just look good on paper or, oh, I have a certificate, I'm fine, I just got this. No, they are accomplishments that you have earned. So yes, you were good. Step 3, discuss with someone. Share your feelings with a friend. Reserve nothing. Open up. Where does it hurt you? Speak out. It could really be relieving. Step 4, seek out a mentor and be a mentor. It's one thing to seek out assistance, and it's perfectly all right to ask for help or guidance. Being a mentor involves teaching. So when you come out of your shell and decide to teach, you'll be surprised how much knowledge waste you've gained back there. But if you don't make yourself available to serve as a mentor, you would never discover those hidden potentials back there. Step 5, expect failure sometimes. Yeah, we might say, no, that's being negative. I'm not a person. No, it's okay to not know what you're doing. It's perfectly okay. As long as you are an enthusiastic learner, view your mistakes as lessons and grow from them. An author, Annie Lamott, she titles every new work as Shitty First Draft. Funny name. And in one of her books, she wrote, my neighbor told her child, here's your new bike. You have to fall off at least 10 times before you get good. Oops, 10 times? Maybe that's why I'm scared of riding bikes. But the point is, it's perfectly all right to fall, but perfectly wrong to remain grounded and not try again. Step 6, forgive yourself. When the inevitable mistake happens, Forgive yourself and move on, because life does the same thing too. Don't dwell on your mistakes and refuse to get back up. Move on. Write the rules. Recognize that you have just as much right as the next person to be wrong. So have a day off and ask for assistance. Step 7, develop a new response to failure and making mistakes. Yeah, Henry Ford once said, failure is only the opportunity to begin more intelligently. So when you get something wrong previously, try again. You never can tell. You might get it wrong, and you might get it right perfectly. Step 8, visualize success. This is not pretense. Spend time beforehand picturing yourself making a successful presentation, acing an interview, or even successful debugging. I do that a lot. Step 9, fake it till you make it. Yes, you have the right to your pretense. No one does but you. So instead of being depressed, downhearted, downcasted, view it as a skill and continue learning. And finally, reward yourself. We often feel like we get these very few moments of happiness in tech, and it's all about work, debugging. People say it's a thankless job, but it's only because of the way you choose to view it. Now, the truth is, in summary, for newbies, when you take data structures and algorithms or JavaScript curriculum on Free Code Camp, or possibly any very good learning source, and you still feel you're empty, or you applied for a junior developer's position and wish they had a graduate trainee program just because you feel incapable and inadequate to handle tasks, or you aced through some stages of an interview and during the final stage, you got turned down, or you aced the interview and got the job, and your first task involves learning a new stack, one that makes you feel like dropping a letter titled resignation. Always remember step 7, to develop a response to such fear. So, as the speaker, if I'm asked what my response is to fears or imposter syndrome, my response to that tiny voice that whispers to me, who do you think you are? You can pull this through. I will simply take a break, breathe, sip my coffee, and reply, I am Tech Empress, and I got this. So yes, thank you so much for listening to Combating Imposter Syndrome. I hope you've learned a lot and see more of you.
Thank you so much, Choice. That was amazing. Also, I love how you're presenting from your phone. I feel like that is the peak of expertise right there.
I was going to say the same thing.
Talk you so much.
Joyce, I'm so glad that you were able to close out HashiTalks Africa. I think that was a great last talk, a great note to end on, a really important message that I think people definitely benefit from hearing. So thank you.
So much. Thank you. I really appreciate it.
All right. So if anybody has any questions, feel free to post in the chat. Otherwise, I think, Katie, are we ready to conclude?
Is that it?
I think so.
It feels a little scary saying like, okay, that's done, but I guess it is. Wow, it went by really quickly, in my opinion.
I know.
Awesome. Well, thank you to all of our speakers, and thank you for everyone that tuned in and asked questions. And thank you, Rosemary and Nick, for emceeing. Today has gone really well, in my opinion. So I'm excited.
There's some fantastic speakers, and I know I have to play them back, and I will be referring quite a few people to referencing some of these talks.
Absolutely. Yeah, we had some really great talks, and I would love to see some of our speakers submit to a HashiConf CFP as well.
Yeah, I know. It would be definitely great to see some of you at HashiConf, going basically through the rest of this year. But also, if you are not planning to speak, but you still want to see some amazing speakers, just like you did today, there is HashiConf Digital. It is June 22nd to 24th. I'll put the URL in the chat. And basically, we'll have some amazing speakers there, and we'll have some fun activities as well. So it will be sort of the conference experience online, and I'm looking forward to it. I don't know about you, Katie.
Same. Most definitely same. Well, my Wi-Fi keeps doing that thing where it's buffering, and I'm so grateful that it's doing this at the end of things instead of been doing this all day. So perfect timing.
Yeah. All right. So on that note, if you want to learn more about any of the HashiCorp tools you saw today, you can go to learn.hashicorp.com. Do check that out. Ugh, I can't speak today. Need more coffee. Thank you all for tuning in. Big thank you to all of our speakers. Incredible content and amazing things that we've learned. And we hope to speak with you throughout the remainder of this year. Definitely stay in touch for everybody who's watching this stream, and stay safe as well.
Bye, everyone.